Hello, hello, check.
వస్తుంది సార్. హలో హలో హలో. ఇది
హలో 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 మైక్ టెస్ట్. ఏందండి
వినపడదు ఇప్పుడు.
ఇప్పుడు ఆను.
అంతే.
Check, check. morning, esteemed colleagues and IOC Tsunami Program Secretariat. The process of Good morning, esteemed colleagues and IOC Tsunami Program Secretariat. Thank you for the opportunity to talk to you today about assessing our progress toward timely and actionable forecasts. Good morning, esteemed
check.
Dev. Okay, you are good to go now. Yeah. It's coming, it's coming.
No, just checking. That's it, yeah. Okay. It's down, yeah. Just checking. Yeah, okay. Not yet. Okay, help me here.
Panchayat man, type C card. అక్కడ కూడా పెట్టడానికి లేదు. మేడంకి ఇచ్చేసారు.
Good morning, ladies and gentlemen. Esteemed dignitaries, the distinguished delegates, myself, Dr. Elaine, I'll be the host for this session. On behalf of the Indian National Center for the Ocean Information Services and the Ministry of Earth Sciences, Government of India, I warmly welcome you to the first conference of the Ocean Decade Tsunami Program, ODTP. The Ocean Decade Tsunami Program is a flagship initiative of the UNESCO Intergovernmental Oceanographic Commission under the UN Decade of Ocean Science for the Sustainable Development 2021-2030. The ODTP envisions the 100% of communities at risk of tsunamis will be prepared and resilient by 2030. Today, we are gathered for the first Ocean Decade Tsunami Program conference, a landmark event hosted by INCOIS in conjunction with the International Tsunami Symposium, ITS. Bringing this prestigious conference to INCOIS highlights our collective commitment to strengthening tsunami resilience, enhancing coastal safety in decade. The inaugural session will commence at 10 a.m. Prior to that, we will begin with a high-level session on ODTP objectives, setting the tone for the discussions ahead. There are a few instructions for the delegates. Coffee and tea will be served outside the auditorium courtyard. Washrooms are on the right side after the exit from the auditorium. Lunch and dinner at the plenary hall ground floor at ITCO, which is just 5 minutes walk from the main building. And now, to begin with, I'm pleased to invite Mr. Bernardo Aliago Rosale to moderate this important session. Sir, please come to the dais. Mr. Bernardo Aliago Rosale, the head of Tsunami Resilience Session at the UNESCO Intergovernmental Oceanographic Commission. He leads the global efforts to strengthen the tsunami early warning systems, promotes tsunami-ready communities, and enhance coastal resilience. He spearheads strategic initiatives under the ODTP, integrating science, policy, and practice for effective tsunami risk reduction worldwide. Mr. Bernardo will introduce the high-level speakers. Sir, the stage is yours.
So, good morning and welcome. On behalf of the Intergovernmental Oceanographic Commission of UNESCO, I'm pleased to moderate this session. We are 10 minutes late, so I will ask the one presenter to shorten her presentation, and the other we are fixed because it's a 28 minutes record presentation. I will introduce then Bill Fry. Bill is a scientist at the GNS Science, the National Survey of New Zealand. He's a seismotechnophysicist and natural hazard scientist, which has a primary focus on understanding earthquakes and tsunami. His research has a fundamental impact on our understanding of these natural hazards, and also, importantly, on how New Zealand communities prepare for, manage, and respond when they occur. I should add that Bill was also a very key person in developing and deploying the network of 11 dart buoys that are in the Tonga Trench Kermadec, that has been, for example, essential to catch the signal of the Tonga earthquake and tsunami. So Bill recorded last night a video from his hotel room in Singapore where he was stranded. But I think that's a very interesting talk, and then we'll have Professor Arkunti, but I will introduce her later. So if we can have the video from Bill, please. And take notes because it's a very, very interesting presentation. Please take notes.
Good morning, esteemed colleagues and IOC Tsunami Program Secretariat. Thank you for the opportunity to talk to you today about assessing our progress toward timely and actionable forecasts, one of the technical challenges given to us by the Ocean Decade Implementation Plan. Today I'm going to be talking about the scientific and operational challenges that we face. I'm not going to be talking about the delivery to the final mile challenges. The talk's going to be broken into 4 key components. One is presenting to you the time metrics, the targets that we've been given in the IOC Technical Publication 180. Then we'll talk about the current operational reality, and we'll do that in terms of the tsunami threat life cycle. The tsunami threat life cycle really combines 5 stages that operational centers work their way through during the course of a tsunami threat. Then we'll talk about the limitations. Why have the 2030 targets been challenging for us? A lot of that comes down to data availability and the way we analyze the data. Then we'll end with a call to arms. We'll present opportunities for the larger research community to come together and help support us in our challenges. This is a matrix showing the time targets for forecasting that were presented to us in IOC Technical Series 180. They're broken into 3 categories, either looking at the earthquake-sourced tsunami or non-earthquake source tsunami, both with known locations and unknown locations. The target metrics are designed around 3 key elements that will fit into our tsunami threat life cycle. Those are the initial indicators. That's really the first time that we have a good indication that a threat might be on the way. For the earthquake source, this is typically the first recorded ground motions we have. Then we have source partially constrained, the middle column. This is when we can typically provide amplitude forecasts. And then source fully constrained. Source fully constrained means we understand enough about the tsunami that we can predict its evolution. So that's when you might think of having something like a time-dependent forecast or the ability to anticipate cancellation. Those targets for the earthquake source are 3 minutes, 10 minutes, and 45 minutes. For non-earthquake but known sources like submarine volcanoes, for example, They're 10 minutes, 45 minutes, and 1 hour. And for non-earthquake unknown sources, so when we just imagine a situation in which we see a tsunami that we haven't anticipated coming from a particular location, those are 45 minutes, 1 hour, and 90 minutes. So how are we doing? This slide is really trying to take a step back and give an honest assessment in a qualitative term about how likely we are in any given event to achieve those targets. I've color-coded this in green, showing targets that we have the scientific and the technical ability to achieve most of the time. Targets in orange that that are occasionally achievable, and targets in red that are rarely achievable. The red targets, they're rarely achievable because these definitely require some observation of the ocean surface of the tsunami wave propagation. Here I'm going to dive in a little bit more into what we actually do and experience in the operational context when a tsunami happens. And we're going to put that into the terms of a tsunami threat life cycle. Essentially, when we respond to tsunamis, it's a process of generating an early estimation of danger and refining that hazard forecast through time as additional data becomes available to us. What that looks like are really 5 key stages, including detection. This is usually from seismic proxy observations or from ground shaking, and this is really our first alert based on seismic observations. And then confirmation. Confirmation is a big step where we can say unequivocally, yes, there's evidence that a tsunami has been generated, and this is typically based on tsunami observations, usually coastal tide gauges or anecdotal reports near to the source. Stage 3 is forecasting. That's when we can produce coastal amplitudes, and this can be based on seismic and or tsunami observations. This is really the point where we have enough confidence to issue a threat level map that shows forecasted maximum amplitudes. Then stage 4, verification, validation of the forecast. This is best done based on tsunami observations. This is when we have evidence to suggest that our forecast was accurate. And then finally, cancellation. Cancellation doesn't necessarily mean when we're at the point to give the all clear, to say the threat's been passed, but it's the point that we have enough information, enough reduction in uncertainty that we can anticipate when the threat will have passed. Now, if we take that concept of the tsunami threat life cycle and we put that into the ODTP terms, then you would find that they map quite well to detection being the initial indicators. So again, those ODTP targets of 3 minutes, 10 minutes, and 45 minutes for the different source, and forecasting, so the middle stage tsunami threat life cycle, source partially constrained, which has the ODTP targets of 10, 45, and 60 minutes. And then finally, cancellation or source fully constrained with the ODTP targets of 45, 60, and 90 minutes. I've told you that the reason we work our way through the tsunami threat life cycle is based on the quality of data. So now I'm going to talk about the data in terms of its sensitivity, and I'm going to map each data stream, many of the current and the novel data streams that we have available to us, or we might have available to us by 2030, into each of those tsunami threat life cycle stages. Those are the columns shown on the top: initial indicators, confirmation, forecasting, verification, and cancellation. For each of those data streams, in each of those tsunami threat life cycles, I'm trying to capture 2 things. One is the utility of the data for that stage, or the usefulness. Is it extremely useful, shown by a large dot, or is it somewhat useful, shown by a tiny dot? Then I'm going to color code those dots according to technology readiness level. I'm not talking about data acquisition technology readiness level, but I'm talking about the ability to use the data in our existing systems or in systems that might be on the near horizon. So just to be clear, things like smart cables. Smart cables, the deployment is probably a lower TRL grade than the implementation. So we know exactly how to use the information from smart cables whenever it's available to us. So that would be the bottom pressure sensors from a smart cable would be a high TRL, not a mid TRL, based on their utility in our current forecasting algorithms. The top row is bottom pressure recorders. So again, including BPR that might be located on smart cables or that might be standalone darts. Those are not typically very useful for the initial indicator phase, but they're very good for confirmation, forecasting, and verification. All of those things that we need to observe water waves for. GNSS static is looking at the static offset of the ground and using that as a way to map the earthquake source that we can then use as a proxy for the tsunami source. And that's useful as an initial indicator and is somewhat useful for forecasting. And this is because the farther away we get from the GNSS receiver or the measurement observation, the less sensitive it is to the earthquake source. Because once you get quite far away from an earthquake source, you can think in terms of 75 to 100 kilometers, you've lost a lot of the ability to resolve what's happened in that earthquake process. GNSS tech, and I'll have a specific slide on this later in the talk, is a way to look at ionospheric signals to map the tsunami wave field. This is really now giving us a lot of possibilities in spatially covering the data we need for each of our tsunami threat life cycles. We're still left with the need to augment any approach like that with absolute amplitude measurements. GNSS multipath and coastal tide gauges, those could be thought very similar, a way to measure the water height very close to the coast. Seismometers, so the traditional way since 2004 that we've been generating tsunami early warning, and this is wonderful. Seismometers are wonderful for initial indicators. That's because the seismic waves we know travel very fast, much faster than the tsunami waves. But because of the uncertainties between going from an earthquake source to a tsunami source, it makes those seismic observations much more useful in the earlier stages of the tsunami threat life cycle. Then I'll have a specific slide about quantum interferometry, and I won't talk about acoustic gravity waves, but we'll have a talk from Usama Qadri later in the conference, who will focus on that technique. And these are really novel techniques that are just now, they're lower technology readiness levels. We're just now starting to try to understand how we might use those in next generation forecasting. So I said you could map the three targets that we had from the ODTP table into the tsunami threat life cycle. That's what I'm showing you here. So I'm just highlighting those in red boxes to show you the different multi-data swaths that we can apply, that it seems obvious to apply to each of those ODTP targets. Ideally, we will have large blue circles in each of these boxes. The process of mapping the data to the life cycle stages that I just showed you highlights one key challenge in meeting those operational goals. And that challenge is really driving a paradigm shift, and that's the necessity of forecasting from direct ocean observations. On the right-hand side, I've now color-coded each of the data streams, showing whether or not they're an earthquake measurement in green a dominantly tsunami measurement in blue, or both earthquake and tsunami measurements in the orange color. And from this, if you look at the large darkly colored dots that you see in each of the red boxes, a pattern starts to emerge in that for the first box, the initial indicators, that's largely dominated by things that can say something about the earthquake source. The middle column, the forecasting column, then shifts forecasting, can use both types of information very effectively, but more so with the direct ocean observations or tsunami measurements shown in blue. And then the cancellation, so to have enough certainty about the forecast that we will understand its evolution, that's really dominated by those tsunami measurements, the direct observations. So this is really suggesting that it's demanding more than suggesting that our operational procedures to achieve the decade targets that we need to achieve, we must begin a migration into more reliance on direct tsunami measurements. One of the biggest challenges we face is that for very, very large tsunamis generated by great earthquakes, the earthquake process, as the earthquake magnitude gets bigger and bigger, the earthquake process gets more and more complex. We've seen this time and again with large earthquakes having multiple fault planes, having dynamic processes that make them different from event to event. So some might start fast, some might start slow, some might involve both the subduction zone and the outer rise, etc. And really, the bigger the magnitude of the earthquake, the more likely this variation is to occur. And that means that a lot of our magnitude determination algorithms, they might be good for one particular type of earthquake, they might be less good for another particular type of earthquake. What I'm showing you here is a lot of magnitude estimations for the recent Kamchatka 8.8 earthquake. These are all estimations from reputable agencies. And they're all estimations that you might imagine you would use in forecasting. I've circled a few of those, and I've shown this before in the debrief to the Kamchatka event. Those are sources that I'll show you forecasts for in the next slide. But early on, if you want to try to understand what information, for example, might have been available to generate a 10-minute forecast in alignment with our target forecasting goals, we add MWPDs, which is a duration scaled body wave magnitude estimate, and presumably an MWP that ranged from about 8 to 8.5, probably a bit more. And then what we see in most moderate-sized events is that quite quickly the MWW, or the gold standard seismic magnitude that we use for forecasting, stabilizes, and there's usually a pretty tight cluster between, say, 0.1, 0.2 magnitude units after some time, let's say after 30 minutes. That wasn't the case for this earthquake. This earthquake, probably because of a complicated rupture process, complicated dynamics that happened in the earthquake, it meant the MWW was quite hard to nail down and get a tight consistency on. So, for example, at 30 minutes, we had estimations from a magnitude 8 to a magnitude 9, which of course makes a very different tsunami forecast. And then finally, the last magnitude I'm showing on here, and it corresponds to the light blue-green line at magnitude 8.6, was a dark MW. So somewhere just a bit after, say about 60 minutes, we had the data necessary to solve for the tsunami source, not the earthquake source. So an earthquake magnitude estimation from seismic waves is really telling us about that earthquake process. The DART solution is really telling you about the tsunami source, or giving you some initial conditions that can help you to recreate the wave traveling to us. A very clear distinction is that it's not necessary to have alignment of the tsunami source and the earthquake source. As long as we can produce a source that will recreate the ocean observations we've seen, we do a pretty good job of making a forecast from it. If you take some of those estimations that I just showed you and you turn those into the wave propagation forecasts, you see they're remarkably different. So the first panel, initial indicators, so information we had in less than 10 minutes. If you take that early MWP, you see the tsunami threat was drastically underestimated. The second panel is that the maximum MWW estimate for this event that came through that I've seen was magnitude 9, and that makes obviously an overestimation, an overforecast. And then around the hour mark, then we started having some updated MWWs where the operational centers really had a chance to dive into the information and come up with what we thought were better moment magnitude solutions. They do a pretty good job of generating a forecast, but they do make forecasts that are slightly bigger than the observed waves, just using the MWW source and some simple approximations that we have to use in operational centers. I'm not talking about after the fact science, where after 2 or 3 months we can go back and we can make better models of the earthquake source itself and include a lot of the complexities that allow us to get better forecasts. We just don't have the ability to do that in the operational centers in a timely context. And the last image was really the best forecast that we had on the day, which was resulting from the inversion of ocean observations. So the first big opportunity, starting to incorporate more ocean observations into our forecasting. The second opportunity, and it's a challenge that arises when we take on opportunity number 1, is to increase the density of ocean observations we have. In an ideal world, you might imagine a map of the Pacific, like on the right-hand side, that shows hypothetical DART locations. This is some work that's largely been driven by Chris Moore from Working Group 1 of the ICG-PTWS. We've done a lot of work to try to map the necessary density of observations that would provide us with enough coverage to achieve some forecasting targets. And we're showing you now a map with hypothetical locations of sea height observations on the right-hand side in red triangles red and yellow and green. Some of those triangles are existing OBP stations. Others are just high to give you the coverage we would need to achieve a rapid detection for sources that originated the subduction zone, and a less rapid detection for sources that originate from anywhere in the ocean basins. Overlaying on top of that are black dots, which represent GNSS sensors, and submarine cables, shown in gray. The reason submarine cables are on this plot is to show you that if we could utilize cables for our sensing, we would go a large way in achieving the density of observations that we would need. So this is really just to give you a context and a feel for the amount of data we would need to achieve many of our targets. On the left-hand side is a new trial experiment we have going on in the Southwest Pacific using one of these submarine cables to detect strain. We believe that it is possible, it's theoretically possible at least, to use this to detect significant tsunami waves. And I've that plot. I'm not going to go into detail today, but we've used strategies to assess the impacts of having things like cables or densification of sensors of all different multi-data types on our ability to provide sufficient warning to coastal communities. Those are showing you the size of the communities and the amount of volcanic tsunami hazard we can mitigate with this particular sensor. But we know we have smart cable initiatives that are ongoing, that are gaining lots of traction now, that will provide useful ways to get at that the density of observations we need to realize these targets. So opportunity 2 is cable observations, smart cable and quantum technology. The opportunities really are in both raising the technology readiness level and increasing coverage. So we need to get these things in the water, and then we need to improve our science and our operational ability so we can use information from them. Significant opportunity number 3 is bringing advances in remote sensing into our tsunami forecasting space. It's been shown over the last several years that when you're at a distance away from a coastal GPS receiver, you can see both evidence of earthquakes and of traveling tsunamis in the ionosphere. The sensitivity of this might go out to maybe 1,200 kilometers off of our shores away from the station. What I'm showing you on the left-hand side is a figure from our colleagues at the Guardian program at NASA JPL, showing you in the blue part of the trace, the first box, the earthquake signature as measured by total electron count in the ionosphere above a GNSS receiver that was located close to the source. And that goes on for about the first, say, 13 minutes. And in red is showing you a signature that is a direct wave. So a tsunami that is clearly visible from the origin time up through roughly, let's say, an hour and a half after it. On the right-hand side is a sensitivity analysis. You've probably seen some of these before from our presentations in Working Group 2 of the ICG PTWS. We've tried to take an approximation of coastal risk exposure in terms of people, and that correlates to the size of circles that you see color-coded in reds and greens. And we've tried to say, if you were able to include GNSS tech into our forecasting algorithms by giving you a good spatial coverage of a tsunami, but also allowing at least one part to the tsunami wave to give us an absolute amplitude of the wave, which is still a challenge for this GNSS technique. How much of the world's subduction zone sources, or right now this is a plot of the Pacific subduction zone sources, could we mitigate with timely forecasts so that on those coastal more of a discretized subduction zone that we could warn for. So what you can see from this is we could get significant advantage, significant benefit from implementing remote sensing technique into our processes. But the real challenge here is understanding both how we realize this in a real-time context, but also how do we generate that next generation forecasting algorithm that allows us to most effectively information, and that's an open question. We've got many ideas about how this can happen, but it would be useful if the greater research community could come together and start trying to look at forecasting from a multi-data perspective. And that is opportunity number 4. multi-data integration of other novel techniques. I've shown you examples of cable techniques and of GNSS tech, but we know there are other things that we can add. And hopefully the plots I showed you give you a good understanding of the way we see the different sensitivity of these data and the need for combining them all together. So we need to figure out how to do that and how to more effectively even use the traditional data we have, like seismic data and direct ocean observations from now relatively ocean bottom pressure sensors like DARTs. So our final request is that we get help from the research community to explore avenues to integrate disparate sensing techniques into unified forecasting algorithms rather than standalone as isolated techniques. Thank you for your kind attention, but more importantly, thank you for all the wonderful mahi you do around tsunami disaster risk reduction. I look forward to catching up with all of you later in the week. Thank you.
Hopefully so. So that was good to get us away. 30 minutes of the conference tired. So our next presentation is from Professor Arkunti, Ibu Arkunti Rahayu. Professor Arkunti Pertiwi Rahayu is Professor of Disaster Aspect in Urban and Planning at the Institute of Sumatra, Indonesia, Bandung, and is chair of the IOC team on disaster management and preparedness. I would mention also that Japanese 2025 Sasakawa Award reduction by the UNDRR. So I invite Professor Arkunti to take the floor, and I'm asking him in 20 minutes. Very sorry.
From the beginning. From slide 1, please. Go from the slide 1, please. Yeah. I cannot operate from here. Oops. Could you help me? Yes, slide show. But this I cannot see here. I cannot see. That's all right, if you can operate from there, yeah. From here. So, here? Yeah, okay, yeah. Ah, yeah. No, like the... So I hope you don't mind, it's just technological obstacle, yeah. So need to increase the URL also for presentation. Mirror. Okay. Okay, yeah, here, mirror. Sama could you're using Mac also, right? Okay. I cannot operate from here. Anyway, yeah. Yeah. Ah, okay. but I cannot operate from here.
You cannot operate the phone.
Yeah, so I don't know how to mirror this.
Okay. Working this. Stop that one, and then
It's okay.
this is a O. So over there,
Guessing.
and then is this view.
Can you?
This view.
Oh, yeah, could you help me? Because I cannot see on this.
And then we go again. Okay, that's it.
Distinguished guests and participants. So I will like to deliver from the perspective of objective 2. So to complement presented our so this is the issue maybe heard about the ODTP or just maybe the first time that you are joining. This is our first for the Ocean Decade Tsunami program. Basically, this ocean we have two. The first one already delivered by is like how to achieve 100 community at 3, be prepared and resilient to tsunami by 20 through program recognition program as well as and the issue here that the 6 key elements of forecasting, warning, dissemination, preparedness and response, capacity development for seed, LDC, so on. And this audit actually with scientific is very important. The picture have 1 year to develop research development very hard to share because I'm sitting here, my colleagues of our TOS working group. This is representing of the, the task team of disaster management as well as task team of tsunami watch operation. This has become important because in this decade we are joining Ocean Decade Tsunami Science, Ocean Decade Science program from UN, but we are looking from the perspective of the tsunami itself, how we have the ocean we want and the ocean we need through the ODTP program. This is very important, and the role of the task team of as well to see from this key element. Them already explained by my colleague Bill Fry, and then I was talking focus on the point 3, 4, 5, and 6 actually. This is very interesting. How can one be covered? Batteries can be resilient and prepared without knowing the risk is very difficult. So, detection, protection, and licensing for, and then I will focus on the warning dissemination and then and capability. We need to see about this. And then without understanding that, without very well recognition program under UNC. And then the objective 4 here, or key element 4, on the I'm going to from preparedness, governance here, the last one I mentioned to implement. It seems like everybody talking about tsunami warning system. 0, for example, Indian Ocean. If 2, how we can question here again here, last mile. People will see people here warning system. They are close to the they cannot touch. The all people is become the issue. On the all. So here, like from the perspective of objective 2, actually reaching 100 to recognize as UNESCO IOC Tsunami Ready and action. So this is very much related with the Ready Recognition Program. To related with this toolkit. So Tsunami Ready implementation equivalency, you know why? A lot of activities, the equivalency 100, because it is like the guideline for Tsunami Ready in the afternoon, inclusive SOP for tomorrow, and has been established focus of the people system. Ready recognition program has been implemented, you know, like in 6 countries, India, together 48, and then some India, CSL, there is Tsunami Ready board established, but risk to be resilient and prepare. So there is also some other that we need to increase. The receiving, you know, the increasing the number of recognition program. We need also one other aspect here, Tsunami Ready Coalition. Actually, Tsunami Ready Coalition is established by TOS working group in Paris that we need to increase together, and they can work together to promote. So who is the people can do together from international, for example, the role of IFRC, and then IEAM, and then ICIS, and so on, and task team, and then all of this UNDRR, UNDP, and from the national as well and from regional. This become the target of the member Tsunami Coalition. The you know, that's the issue. They're not using the tsunami, but the objective is the same: building community resilience. This by having this ready recognition equivalency that has been done by our is very important. We need to identify or establish governance, and then cross-referencing progress is important. Supporting part of our target by 2030. And other activity that I would like to share, sometimes people will ask if I share this program, I get it from Ibu Suci. Institutionalizing tsunami and response. Why we need to institutionalizing? Sometimes people just, without having institutional, you know, the tsunami material awareness and they just ignore. This is very important. By having the institutionalizing, the program be there. And then this is training and capacity. I just speed up because I believe my colleagues will talk about later in the afternoon. And then regional capacity building, for example, TEM, that will be explained later. Here, and here some of 100% people to be ready and resilient. For example, there is also important here, like having the assessment tool, and then here is the guideline for critical. So this is draft is very important because this draft has been activity has been KG and myself. Here is like, for example, is like how they implement on the tsunami. Thank you, Ibu Suci, that you are have tsunami ready infrastructure. But some of would like to have or ODTP. That not the technology, but include the who are disseminate using many devices. Important, this is and replicate in some the local the information using whatever they have. This is one aspect that I'm talking for million and a responsive warning. We thought we give proper, we thought pure location the warning. So this is kind of like for tsunami, and also we have like developed the guideline establishing or constructing tsunami throughout when Bali, but we have continuation by the current we also very important. You could see this because their location is very close to the sea. It's only from 50 meters, so it's very to go to survive. That's why we need the investigation by having vertical evacuation. However, if we conduct the intervention, please, we can do the people maybe today, years. It can be because the tsunami evacuation. You could abandon land. People are very much afraid because they know tsunami megatrust will hit the area. But this is the guideline evacuation. Our BNP. So people trust to the building. After evacuation bill, they have culture of to have the tile, but the what you call aluminum, and then but even after, trust not only to calculate capacity master plan, we need to have annual or maybe every 5 years. Evacuation route should be changed. Signage should be direct. And then you can see what happened here. It's very unique. No people to the area. How the signage? We have vertical evacuation direction, this direction. Good people will. So this is close. Maybe next time. Thank you very much.
Thank you very much, Iwar Country, for this in less than 20 minutes. We just say hello to colleagues that might be or watching video of this. I have a thought. Colleagues Steve application for tsunami ready recognition from a place in Lima, is in the area of the port. See application from El Callao for recognition as, and they have an issue with and we just visited for an appreciation ceremony to two communities in tourist areas that the last 20 or 25 years they have is fantastic. The job that they have done. Vertical evacuation is needed. So that's a subject evacuation and infrastructure for vertical evacuation that is in many, like in Peru or like in Portugal or like in. I wanted to just get from these two interesting presentations on multi-data integration for the scientific community to do data integration of several systems that are under development, presentations over these 5 sessions, but I wanted to just offer, and the second big message is from local champions, very last month. And then infrastructure, particularly for tsunamis with vertical evacuation as the main for that. I will stop there because we have an opening immediately after, but I wanted to just offer the floor for comments or questions to Ivo Kunti. We can ask Bill because he will not be able to reply from his room in the Singapore hotel. But in case you have any comment, we are open to listen your comments. Yes. I have a micro over there. Introduce yourself and then.
Hi, I'm Ira Didinkulova, University of Oslo, Norway. When you were showing your champions, I saw that Indian is very limited area. So is it because you didn't reach further, or it's because you think those are most affected?
Okay, thank you for the question. Because Indonesia, we are exposed to the near-field tsunami, most of places. And then the tsunami will arrive maybe less than 30 minutes. And a lot of cases, like some cities, for example, Padang and then Banda Aceh, they are very urbanized, like population almost reach 1 million. So you could imagine, like Padang, for example, 60% of area is totally flat. The inundation will cover 60% of area. It was just using the very bad mathematics. 6% from 1 million distribution of people, they will expose to the tsunami. The golden time is very limited. So that's why we need to do the intervention, building vertical evacuation. Otherwise, they cannot run. And also for Padang City, there is also obstacle. The safe place is behind the airport, the old airport, the Air Force airport, where airport is just parallel with the coastline. So people cannot jump over the airport to reach the safe place. So that's why it's very need the vertical evacuation. And then the role of the champion is very important because people will listen to the assistant of siren is impossible to reach all these like 600,000 people. That's why in Padang City, you know, the champion, for example, the mosque speaker network, they have like a network association of the mosque, what you call this? Imam Masjid, yeah, maybe, yeah, I don't know the name, yeah. But Indonesia is quite different, yeah. So like a lot of young volunteers, they are dealing in the mosque and then just using the network and they spread this information using the speaker. And also the champion of like, I just remember Parhito mentioned that UNESCO one time they have like the SB, yeah, champion, school champion. This there actually is very powerful to be included into the intermediate actor for the disseminating the warning until reaching the last mile. So hopefully can answer you because it's, you know, it's very high populated area. Just relying on the technology is not sufficient. Yeah.
Maybe I wasn't clear enough. So you were showing the map before, the map of preparedness, yeah? And the Indonesia is those points you were showing. It was very nicely covered all over. But India, it was just a small segment, only in the eastern part. And then there is also, and the south is also well affected by tsunami. So that was a question. Why is it so little, just specific area? Yes.
Okay, actually there are a lot of programs in Indonesia to build the community preparedness, especially for coastal community. Like I mentioned before, on the west is like intervention of the mitigation, building vertical evacuation shelter by the government. East part of Indonesia, the intervention, because we developed the guideline, I made the guideline and already adopted by our National Disaster Management Organization. So the local government, they can build by their own. Using the guideline, they can use like multifunction building. Office can be used for the vertical evacuation and so on. So on the east part of Indonesia, there also a program, but is handled by the local government. Also, the capacity building of the people. We have several programs for Indonesia. We have like family resilient, Katana, National Family Resilient Program. And we have National Tsunami Ready Village, which is actually complement with our Tsunami Ready IOC Tsunami Ready. And also there are a lot of programs under the Red Cross, also under many organizations actually. So just give example. But like the structure, just specially built by the government, just mainly because of the master plan finished until 2017.
Thank you very much.
Just would like to add to what Ibu Harkunti mentioned about the case with India. So the East Coast, like Tsunami Ready, it started in a state called Odisha, that is the province. There's a lot of interest from Odisha because Odisha faced a super cyclone in 99, which actually took about 10,000 lives. So there was a huge component of cyclone preparedness which was actually undergoing in Odisha. And then when we started implementing Tsunami Ready, not many lives were lost in Odisha at all during the 2004 tsunami. It was mostly during the southeast coast. But Odisha stepped up because of this experience they had with the cyclone and a lot of preparedness programs already existing. And they actually bankrolled very quickly into tsunami preparedness because they wanted to become multi-hazard prepared. And then that also led to now other provinces in India getting on board. Now we have Kerala, which has taken up in about 10 villages. Then there are Tamil Nadu is actually come on board. Andaman Nicobar has come on board. So there are about 8 provinces which have come on board now. So it's a slow process, but I think all countries are getting there actually. Yeah. Thank you.
I think that's a good introduction to one of the big subjects that we'll be discussing, which is multi-hazard in the next few years. Building on the expertise and building on the experience of the tsunami community, but not only, because if you go back in 30 years, you might recall Bangladesh, 300,000 people that passed away, and they learned the lesson. They have a very interesting community-based preparedness system, including vertical evacuation infrastructures, to save people's lives from storm floods and from typhoons and etc. So I think that there is a good mix that needs to be found out in between these communities to get people's lives saved, which is our very noble target. So I will stop there. I thank you very much, Bill, in the hotel that might be watching. And then Ivo Akunti that is with us here, and all of you for your very kind attention to this first session. Thank you.
As we have come to the end of our first high-level session on ODTP objectives, I request Mr. Bernardo to felicitate Professor Harkundi. Sir, you can go ahead. Yeah. A small memento as a token of our gratitude. Thank you, Professor Harkunti. Are you? Also, I request Dr. T. Balakrishnan Nair, the Director INCOIS, to felicitate Mr. Bernardo Aliaga Rosel. I thank all of you. With this, we have come to the end for the first high-level session on ODTP objectives. Within a short time, we will begin with the inaugural ceremony. Thank you. A very good morning to one and all. Welcome to the first Ocean Decade Tsunami Program Conference, a landmark global event hosted by INCOIS in collaboration with the International Tsunami Symposium. This conference marks a major milestone in bringing together the global tsunami community, the scientists, the policymakers, the practitioners, and the stakeholders to work together to of safer and more resilient coastal communities. The ODTP advances the Ocean Decade Challenge 6, enhancing community resilience to ocean hazards by promoting science-driven collaborative solutions that strengthens preparedness, response, and sustainability across vulnerable coastal regions worldwide. To begin with the program, we have Mr. Vidar Helge Sanioka, the Chair, Joint Tsunami Commission, IUGG, and Emeritus Professor for Hokkaido University, Guest of Honor, Dr. M. Ravichandran, Secretary, MOES, Professor Harsh K. Gupta, Emeritus Professor, NGRI, Dr. T. M. Balakrishnan Nair, Director, INCOIS. I request Dr. T. M. Balakrishnan Nair, the Director, INCOIS, to accompany the distinguished guests to the dais. Now I request Dr. T. M. Balakrishnan Nair, the Director, INCOIS, to kindly present bouquets to honor our guest as a gesture of welcome. To mark the auspicious beginning of this conference, may I request all of you to kindly rise for the invocation and also request our distinguished guests to perform ceremonial lighting of the lamp. I request Kartika for the invocation and also request the dignitary to perform the ceremonial lighting of the lamp. This tradition symbolizes the illumination of knowledge and the spirit of collaboration.
तुषार हारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिर्देवी सदा पूजिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा.
Thank you, Kartika. To formally welcome you all, I request Dr. T. M. Balakrishnan Nair, Director of INCOIS, to deliver the welcome address.
Distinguished guests, honorable delegates, my esteemed colleagues from IOC and all leading institutes in the world, and my dear friends and colleagues from INCOIS. It is my privilege and honor to welcome our chief guest, Dr. Vidar Helgensens, IOC Executive Secretary and Assistant Director General of UNESCO. It is nice to note that prior to taking up the role of IOC, he was the Executive Director of the Nobel Foundation in Sweden. And he have a lot of delegations on Peace Foundation of Sri Lanka, a lot of discussions. We are also honored by the presence of Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, K. Gupta, our Secretary, DOD, earlier DOD, and Emeritus Professor, Professor Tanioka, Chair, IUGG, Joint Tsunami Commission, and Emeritus Professor, Hokkaido University, and many of our colleagues and leading scientists from the tsunami community. On behalf of INCOIS, the Ministry of Earth Sciences, Government of India, I extend a warm welcome to all the participants of the first ODTP conference. It's an honor to host you in Hyderabad as we work together to advance tsunami risk knowledge, warning capabilities, and community resilience across the Indian Ocean and beyond. This conference is purpose-built around two high-level objectives. You already heard about this. The capacity to issue actionable tsunami warnings less than 10 minutes to 100% of at risk at cost, and 100% tsunami preparedness and resilience by 2030, including through the IOC UNESCO Tsunami Ready Recognition programs. As a part of this conference, we plan review the surface gaps and priorities. That is, purpose a new actions, especially for SIDS and LDCs, and strengthen coordinated among ODTP action and allied initiatives. We are here to turn very good and innovative ideas to implementable pathways. So INCOIS is ready to contribute as India's operational hub for multi-hazard ocean services. We are committed to integrating rapid source characterization, including GNS, tide gauges, deep ocean sensors, and cable-based technologies into forecasting workflows. Advancing impact-based product and communities can act on that. And Particularly, I also mention, as in the present geopolitical scenario, Government of India, Ministry of Earth Sciences, committed to the world community during the IOC assembly that we'll be doubling our ocean observation systems, especially for monitoring the helping the early warnings, because that is a key pillar of early warning to all plan. So also expanding people-centered early warnings through trainings, exercises, and tsunami-ready implementation with our partners across the Indian Ocean region. Very worthy to note that we are working very extensively to make all the coastal communities in the Indian Ocean region as tsunami ready. As a part of our newly formed subcommission of IOC, that IOC India, we also taken this as one of the priority items. A special word of thanks to ODTP scientific community for shaping a ODTP implementation plan that is both technically strong and implementation minded. This is exactly what the ocean decade calls for: actionable science that reduce the risk and saves. So I also like to appreciate the tsunami community, because as a part of many IOC programs or WMO programs which I am chairing, I have seen this community is well connected to the member states, and it's a real bridge between the UN organizations and the member states. What the member states want, it is actually gone to science-based action plans to IOC, and they try to implement it. And most of the time I tell in the GOES or other areas, you have to learn many things from the tsunami community, how they translate the ocean science or ocean technology to the benefit of the member states and the early warning to all. I encourage all participants use various session break to forge collaboration between observation network and service providers, between scientists and practitioners, and among nationals, region, and UN partners. The outcome document we produce is very important, but the projects and partnership it unlocks are what will matter most in 2030. With that, welcome once again to INCOIS, to Hyderabad. My best wishes for a productive conference and for concrete, shared steps that move us closer to the faster warnings and fully prepared communities all along the global oceans. Thank you. Thank you very much.
Thank you very much, sir, for your inspiring words and for steering this global initiative. Next, we have Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, for sharing his opening remarks. His leadership has been pivotal in advancing Indian ocean science and disaster resilience. Welcome you, sir.
Very good morning to all of you. Dr. Vidar Helsington, sorry, pronunciation is very difficult for me. Executive Secretary, IOC, Professor Ichiro Tanioka, Chair of IUGG JTC, Dr. K. Gupta, former Secretary of our Ministry and now Emeritus Professor at NGRI, Dr. Balakrishnan Nayak, Director INCOIS, and also I have seen many of the known faces, especially Dr. Srinivas and other people, and participants and delegates and my colleagues and friends. Very good morning to all of you. It is indeed a great pleasure to be here as part of this important conference, the first conference of Ocean Decade Tsunami Program. I welcome you on behalf of the Ministry of Earth Sciences, and also thank you for taking time to visit INCOIS for this particular meeting. Of course, we gather here under the banner of UN Decade of Ocean Science for Sustainable Development, Challenge 6, and the Ocean Decade Tsunami Program, with the profound implications, the science we produce, must directly serve the people who need it most. Of course, we all know that tsunamis are rare, but when they strike, they can alter the course of entire generation. The Indian Ocean taught us a lesson in December 2004 when the sea rise without warning and minutes are matter. From that tragedy, India resolved not only to protect her own shores, but also contribute decisively to safety of our neighbors. Today, that resolve has taken shape as one of the world's most advanced end-to-end tsunami warning system operated by INCOIS under the Ministry of Earth Sciences, serving our nation and the wider Indian Ocean region. As a coastal population grow and also sea level rise, our responsibility also grow with them. Hence, we need many lines of actions. I have few in my mind. That is, one is, of course, we are already doing in that. One is a community readiness for all at risk at coast. We will scale the tsunami ready approach so that the communities have clear evacuation maps, signage, altering maybe various systems inclusive of drills and response plans that consider schools, hospitals, and including people with the disabilities. Hence, the preparedness must be local, practical, as well as practice according to the local. Second one is a faster and smarter warning systems. Of course, we will strengthen the existing, whatever the tsunami warning system, we need to strengthen end-to-end early warning system from the observation, from the seabed to the last mile, especially the cell phone. This includes various networks of seismic, data buoys, and coastal sea level cages, and GNS and satellite data. All these things has to be real time, it has to be assimilated into the model, and also the warnings has to be generated to the last miles, alerts through sirens or radios or mobile communications. We will work together with the various nations and regional groups for the tsunami warning centers along. Of course, we have to align with the various UN agencies, especially there is a call for UN early warning for all. That initiative, we have to ensure warnings are timely as well as trusted. And the third one is, of course, the risk knowledge for decisive action. We have to modernize our hazard and mitigation wherever the maps, coastal maps. Of course, we have to make a coastal planning, coastal spatial planning, so that it is not only for particular tsunami and all the oceanographic hazards we need to protect. For that, we need to set up the multi-dimension warning system. Of course, we need to plan for the coastal area also digital twins and various models, and we need to have authorities, maybe we have to make a quick action in that. For that, whatever we need to set up. And also we need to build the nature-based solutions, especially protection. For protection purpose, we need to make various solutions, especially with the nature, mangroves, coral reefs, and various wetlands we need to develop all along the coast, especially using the smart engineering. These buffers will reduce the impacts, provide livelihoods, and store carbon, and also it will be helping various ecosystem, health of the ecosystem. And lastly, we need to have a capacity building, capacity, inclusion, and open data. That is very, very important for all of us. We have to build the skills and institutions, especially in small island and also least developed countries. We have to be champion in open interoperable data, and also we need to elevate the local knowledge, especially the indigenous knowledge, and risk communication will be clear, and it should be meaningful and multilingual and accessible to all. Partnerships are our engine, and national government, regional partners, IOC, UNESCO, Global Tsunami Warning and Mitigation System, UNDRR, development banks, academia, and private sector, including civil society, work together for this mitigation strategy. So we are always believe that there are three things, 3S and 3D. 3S means science, we need to do science. That science we need to translate to the services for the benefit of society. At the same, for this very important thing is we need to detect well, and also we need to decide quickly whatever the protocol we are making it, maps and other things we need to decide quickly. And also finally we have to deliver and disseminate warning as quick as possible, as meaningful to all the stakeholders. Dear friends, the ocean connects us. Let it also unite us in preparedness, compassion, and courage. I am sure that together we will turn knowledge into safety and foresight into resilience. Thank you once again for coming, and definitely I am sure that at the end of this meeting we will have an implementable recommendation so that we can collectively adhere to that and do as much as possible. Thank you very much.
Thank you very much, sir, for your visionary guidance. Next, we are honored to hear from Professor Harsh K. Gupta, the Emeritus Professor of CSIR in GRI. Professor Gupta is globally renowned earth scientist and seismologist with over 5 decades of distinguished contributions to geosciences. He has served as Secretary to the Government of India Department of Ocean Development and as a Director for CSIR National Geophysical Research Institute. Professor Gupta played a pivotal role in establishing India's tsunami warning system at INCOIS after the 2004 Indian Ocean tsunami, and has been instrumental in advancing earthquake and tsunami research in India as well as globally. I invite Professor Gupta to share his opening remarks.
A very good morning to all of you, dignitaries at the dais and representatives from all over the world, Srinivas Kumar and my friends. I must first of all compliment INCOIS for hosting the first conference on ODTP. It's a very welcome thing. And Ravi Chandran has covered many aspects. And I thought I'll just get back a little bit. You see, in 1990s, we started the IDNDR, International Decade of Natural Disaster Reduction. It was a UN initiative. And one program was Global Seismic Hazard Assessment Program, GSHAP, in which about 500 people from all over the world produced a global map. I happened to be chairing the steering committee of that committee, which told that at any spot in the world, what are the anticipated maximum acceleration at the basement. And that has provided such an important information globally for people to assess that if an earthquake occurs, what is to be expected. I'm very sure that something similar would happen with this initiative. Let me go back to 26th of December 2004. In India, tsunami, the word tsunami was not known. And it was a Sunday morning on Marina Beach in Chennai. People are having a leisurely walk on the sea coast. And suddenly a sea withdraws. The people don't know that the trough of the tsunami has arrived. So they walked into the sea, picking up shell, fish, etc., without knowing that a huge wave is going to arrive. And this happened not only in India, but at many places, because tsunamis are so rare in the Indian Ocean. All the work started, and then we had a situation that the alarms for tsunami warnings were issued by Pacific Tsunami Warning System and the Japan Meteorology Agency, because Indian Ocean did not have a tsunami warning system. Now, if you look at the Pacific, the circum-Pacific belt is so close to the continent that there is hardly any time between the occurrence of the tsunami or occurrence of the earthquake and the tsunami reaching the coast. When we come to the Indian Ocean, I think it's very important to know what exactly is happening where. So we discovered that as far as India is concerned, there are only two sources for tsunami during earthquake. One is from Java, Sumatra to Andaman Nicobar, an extent of 4,000 kilometers, and another is a small area off Makran coast in the Indian Ocean. So the first IOC meeting took place in Paris, and Patricio Bernard was in your position at that time. And I said that in India, we cannot afford to have false alarms. Because what happens that we have got huge population on the Indian coast, and one or two false alarms, people will not listen to it anymore. And this had happened. And the solution was very simple. The solution was that we cover these tsunami warning zones by planting ocean bottom pressure recorders in the immediate vicinity. So the earthquake is occurred, this is known within few minutes. Whether the earthquake has generated a tsunami or not does not get to be known till the tsunami reaches a recorder, something like that. But when you plant these ocean bottom pressure recorders in the immediate vicinity, due to tsunami, the whole column of water is oscillating. In the open ocean, you've got waves which die within a kilometer or so. But at the bottom of the sea, there's no motion, so it can pick it up. So this I placed before the IOC meeting on 4th of March 2005, and there were about 200 people representing all the countries, and they did not accept it because they had not looked into it. It was just a surprise for them. So the discussion continued for quite some time, and Patricia Bernal, he said that Harsh is telling something, let us look into it. Let us take some time. So that meeting was adjourned, and we met again in Mauritius after about 3 weeks' time, and no one could have found a location other than these two which generated a tsunami. So that made a sea change in our approach. And of course, all the credit to INCOIS, the Ministry of Earth Sciences. INCOIS set up a tsunami warning system, which Dr. Ravichandran just now said is considered among the best in the world. So I think we are in a very interesting phase where the two goals that you have set up, that we must be able to issue a credible tsunami warning within 10 minutes of its occurrence. And the second question is to create tsunami resilience. You see, there are several issues which are very important. Tsunami warning is issued, but is a country ready to accept it and act on it? We must know what is the shallow bathymetry close to our coast and what is the near topography, because that totally controls how far the tsunami wave will inundate. And this is something which each country must do, Indian Ocean, all over the world. So these are things which we have to cultivate and share, but I'm sure that with the effort that's being, this will happen. Let me wish you all a very successful and wonderful meeting. Thank you very much.
Thank you very much, sir, for your quick glance to how India began its journey towards tsunami resilience action and preparedness. We are privileged to welcome Professor Yuichiro Tanioka, the Chair for the Joint Tsunami Commission of the IUGG and Emeritus Professor at Hokkaido University, Japan. His groundbreaking work in tsunami modeling and early warning systems have significantly advanced the global preparedness. He is a leading tsunami scientist, and his pioneering research focuses on the generation, propagation, and coastal impacts of tsunami. He has made substantial contributions to our understanding of earthquake-tsunami interactions, tsunami modeling, and hazard assessment. And he continues to play a pivotal role in international collaborations on tsunami science and early warning systems. May I request Professor Tanioka to address the gathering.
Thank you very much, ladies and gentlemen, and all of the distinguished guests. I'm pleased that the first conference on Ocean Decay Tsunami Program is holding in India, INCOIS, just before the ITS 2025 symposium. That is will be holding from 12 to 14th. And first, I just try to explain what is the Tsunami Symposium. The International Symposium is held every 2 years. And this symposium in INCOIS in India is 32nd International Symposium. Now you know how that the ITS is have a long histories. And I believe all of the tsunami scientists using this symposium as an international forum to discuss about the recent tsunami sciences. And I believe that those outcomes from various researches about tsunami scientists has helped to improve tsunami warning systems and also tsunami risk reductions. And firstly, this International Tsunami Symposium was including geophysicists and tsunami scientists and engineering people. But now we are including social scientist people, which is, we think, that very important for tsunami risk reductions. So now we have interdisciplinary sciences included in these communities. And I believe the outcome of new tsunami researches will help that ocean decay tsunami program in IOC. There are new observation systems, like the Bill was already talking about, like a GSS and tech, and also like acoustic, hydrophone systems observe acoustic waves, hydrostatic acoustic waves, and also like a dust system, and the many other observation systems are already developed, has been developed recently, and we can use those systems. And also, the computing system is also changed, somehow changed very much in recently, because we can use AI system or quantum computing system and cloud computers. And if you use those kind of recent development, the tsunami sciences become more advanced. And the early warning tsunami system is also will be advanced. And that will help that the ocean decay tsunami program eventually, it may be in a real time, but eventually those new systems will help them. So finally, I hope that this conference has a very successful product and a fruitful product. Thank you very much.
Thank you, Professor Tanioka. It is now my honor to invite our chief guest, Mr. Vidar Helgitsen, the Executive Secretary of the Intergovernmental Oceanography Commission of UNESCO and Assistant Director General of UNESCO, to share his thoughts. A distinguished diplomat and environmental policy leader from Norway, Mr. Vidar has previously served as the Norway's Minister of Climate and Environment and the Minister for European Affairs. He also held the position of Secretary General of the International Institute for Democracy and Electoral Assistance, and prior to joining IOC, he served as the Executive Director of the Nobel Foundation of Sweden. With extensive experience in global science, oceans governance, sustainability, and international cooperation, Mr. Vidar's leadership continues to inspire collaborative ocean action. Under his guidance, the IOC is advancing the goals of the UN Decade of Ocean Science for Sustainable Development, fostering science-based solutions for resilient oceans and coastal communities. I welcome you, sir.
Thank you indeed. It is just like for the others, also my pleasure to welcome you to this first Ocean Decade Tsunami Program Conference. Really a milestone for our efforts for the global tsunami and resilience community. Dr. Bala, Dr. Ravi, Professor Gupta, Professor Tanioka, I'm honored to share the podium with you because in this group there is so much leadership and so much experience. There is so much leadership from the early days of building the tsunami early warning system. There is the leadership of INCOIS, which is very close for the IOC, and there is the Indian leadership on earth sciences, on ocean sciences and ocean action, represented by Dr. Ravichandran. The UN Decade for Ocean Science, Decade of Ocean Science for Sustainable Development, I'm using the full title for once, is meant to mobilize global science efforts for sustainable development. And for that to happen, it can't be a science effort only. It is organized to be a co-design endeavor, a partnership endeavor, so that we can bring science to services, bring science to solutions. And in that, it is only natural that the Ocean Decade Tsunami Program is one of the key IOC programs that we are organizing within the Ocean Decade. We're hosting the Ocean Decade on a mandate from the UN General Assembly, but we have some initiatives that are also led by the IOC. This is one of them. So far, midway in the Ocean Decade, we have more than 600 projects around the world, more than 60 programs launched by and driven by many actors around the world. About $1.5 billion mobilized for all these efforts. But most of this obviously is led and driven by others, whereas we are focusing on some. And it's natural for us to focus on the Tsunami Program. Not least because the Tsunami Program has, from the outset, really had the same approach that the Ocean Decade is taking. Science for services, science for solutions, co-design and partnerships. And that's why the Ocean Decade Tsunami Program also is bringing together scientists, operational organizations, governments and communities, embracing a whole of society approach, also consistent with the Sendai framework and the Early Warnings for All initiative. In the 2 decades since the 2004 Indian Ocean tsunami, we've seen tremendous progress as a result of this partnership and co-design approach. We've seen stronger observation networks, improved modeling, dedicated global and regional centers for issuing tsunami warning alerts, and greater community preparedness. And let me take a moment here to recognize and appreciate and thank Professor Gupta on behalf of the IOC for leadership in the earlier times of the Indian Ocean tsunami warning and mitigation system, and with that also your contribution to this as a global endeavor. Thank you very much. And yet, having all those experiences, we also need to look at new challenges, growing challenges coming from multiple hazards and new risk frameworks, including tsunamis from all sources, volcanoes and landslides included, sea level rise and coastal development, all increasing exposure and risks. And let me say, outside the agenda of this meeting, that we're looking at a number of non-hazards coming where we really need establish early warning systems, and where we're setting out on the part of the IOC, building very much on the experiences from the tsunami program. The risk landscape continues to increase. It's becoming more complex. We're seeing cascading impacts on human lives, on livelihoods, and on critical infrastructure along coastlines. And this conference is really an opportunity to take stock of progress, to identify gaps, and accelerate actions to achieve the 2 high-level objectives that many have referred to of the Decade Tsunami Program: timely actionable tsunami warnings for 100% of coasts at risks from all sources, and 100% of coastal communities prepared and resilient by 2030. Addressing these new challenges, we should really build on that same partnership approach and be very mindful of the need to be inclusive. We must not least ensure that those that are most at risk, small island development states and least developed countries, are not left behind. At the meeting there is a session on with an aim of identifying key gaps and needs and proposing new opportunities and partnerships to secure full SIDS engagement with the Ocean Decade Tsunami Program. We need to commit to inclusiveness, gender equality, to accessibility, ensuring that all people, including not least those most vulnerable, can benefit from tsunami early warning and preparedness. So in facing new challenges, and that goes not least when we're talking about new technological opportunities. At a moment in world history when there are amazing opportunities and quite a few risks coming from new technologies, but in deploying these new opportunities for good, let's make sure that they're good for everyone and that resource constraints and uneven access is not going to be yet another hazard in building and early warning going forward. I am really trustful that the output of this conference will not only advance implementation of the Ocean Decade Program, but also contribute directly to global efforts under the Early Warning for All initiative and the Sendai Framework Target G to substantially increase the availability of and access to multi-hazard warning systems and disaster risk information and assessments to the people by 2030. So let this conference be an opportunity to inspire a renewed commitment to science, to solidarity and action. And I wish you with that productive deliberations and coming out of it lasting partnerships. Thank you very much.
Thank you, Mr. Vidal, for your powerful message and support. It's our custom to honor our distinguished guest. I request Dr. Chandran to do the honor of felicitating our distinguished dignitaries with the shawl and memento. I request Chief Mr. Vidal Helgeson to accept the felicitation from Dr. M. Ravichandran. So, Ravi sir has. Next. Next, I request Professor Harsh Gupta to come forward. So please receive the felicitation from I request Professor Yuichiro Tanioka to receive the felicitation. Sir, please. Now I request our director, Dr. T. M. Balakrishnan Nair, to felicitate Dr. M. Ravichandran. Thank you very much, sir. To conclude our ceremony, I'm pleased to invite Mr. Dennis Chang Sheng, the program specialist at UNESCO IOC, to deliver the vote of thanks.
Thank you very much. So again, I say welcome everyone, distinguished guests, participants. So I just want to say that this is really the first conference of the ODTP, which started 2021, endorsement from the Assembly. It's the first time I am here actually at INCOIS. It's the second time I actually come in Hyderabad. The first was in 2005. And recall it was just after tsunami. There was a big conference in Hyderabad. I was younger, so I was a lot of inspiration. So today I'm here. Very important event. So the decade tsunami today is about transformation of the global tsunami warning system. But we came here 20 years ago to try the tsunami early warning system. Today it's about transformation of the global tsunami early warning system with two high-level objectives, which has been shared by everyone. But it's nothing more than early warning and early action and response. So today I'm really delighted that everything has happened except for Dr. Bill Fry, who's stuck in Singapore. So I hope it will work well. I will engage and express your views. And I just want to say, I want to echo what has been mentioned by Dr. Bala and also other colleagues, that we are actually focusing on science and actions, solutions that will benefit society. I thank you very much.
Thank you for your gracious words. We officially commence the Ocean Gate Tsunami Program ODTP conference. The sessions with disturbing and impactful collaborations. I request all of you to kindly rise for the national anthem.
गण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल विंध्य हिमाचल गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे जय गण मंगलदायक जय हे भारत भाग्य विधाता जय 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 हे.
There has been a high arranged outside the auditorium, and since we have to make sure that our program continues on time, kindly join back by 11:30 a.m. itself, right here. Thank you.
Hello.
Hello.
Think of Kafka as a super fast delivery truck and Zookeeper as its
Good morning to everybody. My presentation, in particular, Iranians. And here you see center. Also, stop here.
Pick it from here. They need not use a mic. Portable. get standing and just using it. Okay.
Okay, so for the session, which will be high-level one, high-level objective one, as I mentioned, it's about warning. Just words. So now, I would like to reiterate that for this session one, moderator is Yushiro Tanioka, who is professor in the Joint Tsunami Commission, and emeritus professor, leading tsunami scientist and at the Institute of Volcanology, Hokkaido University. His pioneering research focuses on tsunami. Has made significant contributions to understanding earthquakes, tsunami interactions, tsunami model, and hazard assessment. And he continues international tsunami operations. So I welcome you. And now on, and will be Professor.
You can.
Thank you very much, Tanioka, and thank you for the opportunity to talk to you. I am standing here as the chair of the Global Tsunami Model to introduce you to the topic of my is on co-creating strategies for tsunami resilience, tsunami model associated in knowledge technology transfer. So it's not about only the early warning, it's also so we both high-level goals of here in Hyderabad. Let me say words about the history. So the global tsunami is something that has been in the making for, and it started basically when the GAR report global built time there was the necessity to come into or to get a community and find ways how to do that way to also with the data and so on. From that time onwards there were a lot of meetings, informal mostly, at conferences where we got together and ways how to in a way more sustainable. And one of the major concerns was also to establish probabilistic approaches in assessing hazard and risk in this context. It was Eurocentric because there was coming from the Euro, from the Union as well as other funding agencies. One quite instrumental in the idea for this association, so-called our cost action, not related to the European, was already established European Union into place. These meetings took place of sustainability, where we could in a way develop ideas for coming with an association phase, the official which 2025 became, and so entity can receive, can act as an association. It's a membership, so everybody is to member, and I will talk about that later. The vision of is saving and enhancing resilience, advancement of tsunami science, and dialogue about tsunami has relatively general. It includes the dialogue with end users, with industry, science as well. It includes the large, also includes other kinds of communities affected by tsunami. Our mission, we want a competence center, a one-stop shop who need in hazard on and also on workflows. We want to gather a pool of experts is really invited, that we can be a big expert, be in a way be more visible through the association. We try to train the next generation of scientists as well, so we try to gather learning material, improve our. We have submitted a proposal for another involved in training. We provide services and products, in particular in PTHA, so probabilistic tsunami assessment and tsunami risk assessment, and structure. Other board members, one Fatime Yale, former board chair, and we are distributed into units, units being the legal unit, which in a way is what we are looking for. We are also something we developed over next. So what is the aim? The main, the communities at risk about maps, about the hazard map, also the risk. They also about how to develop tsunami, how to come up with these things. We want to, we also mention, but it's, and the aim is to gather this knowledge and make it available. Our products will be the hazard map, which will be updated basis. There will be components for this is one thing that we are looking at. So the global, and also communicating best practice is another main component. But here are a few examples of what we did already. So we hoped that a cookbook, so-called cookbook on tsunami hazard assessment, fortunately we're working on the last proofs, so it is almost done. We actually designed it in such a way that it is like a cookbook. It contains a lot of examples from implemented parts where tsunami risk has been done. It also contains ingredients. What are the main ingredients that you need in order to cook up tsunami hazard and risk strategy? Then a pilot with Munich Re, so as a with reinsurance company, where we provided probabilistic inundation maps and So these are just examples how we started. And will certainly be a more professional organization with a proper secretariat and service center. We have contributions from Norway and in Italy. We are trying to grow membership. We are in the of. So what are our contributions to the high level objectives? So for the early warning, I would say of the core parts that we can contribute is knowledge and expertise, holistic assessment, and early warning. So capture why do we want to, in a way, propagate? Because it captures the uncertainty and, in a way, gives us a better base, in particular for this. Because the definition of risk is something that needs to be decided societal way. It is not that science has to draw the margin. That is something that scientists can contribute. And this is possible through a probabilistic approach. How likely is a certain outcome? And this is why we think that to the early warning part, and then we have the part where we contribute to the 100% tsunami readiness, because one of the main assets that we can, in a way, contribute is expertise, also data of the small island. Their hazard in first place, and this is a bit for becoming tsunami ready. So this is something that we would like to contribute. We would like to help with risk communication as well. We would like to help to the end-to-end in tsunami resilience. I am finished with my. Thank you very much for your attention.
Thank you very much. Do you have a question? Yeah.
Sir, I am Alfat from BMKG Indonesia. I want to ask a question. The global hazard model map format of the model. Thank you.
So how to assess it is by modeling, including well, we don't have data for foundation, for example. Use certain Green's laws and acceleration factors in order to hazard on land, which is of course somehow coarse, global level. Not sure if that answers the question. Not sure if this is scientific enough. Yes, and so this will be what it are hazard curves, for example, and they are then via a web interface. Question?
Maybe just a fixed picture or some data?
As we are co-creating this requirement, then this may be considered, yes. So if you have requirements, we will try to develop these things. Sure. I mean, I'm not saying that everything is already there in place already, right? And so, as I said, formable, we need the collaboration, we need the community cooperation for really building this, but we try to be kind of a crystallization point for doing this kind of collaboration.
Sir, the data that you are using is broadband seismic data or accelegraph also, this global hazard?
No, it's not just it's all kinds of sources.
Okay.
Hello, George. You nice talk. My name is Professor Baitia. I'm liaison officer from IOC, and I have some experience in the business. And then you mentioned something in the beginning that I am a little bit surprised about. INCOIS ERIC, which is a service provided in terms of whatever in earth science, tsunamis and earthquakes included. And how is the connection with your organization, with INCOIS?
Yeah. So INCOIS ERIC is a service that is provided by the European Union in terms of data provision, also model provision, and it is accessible for the whole community. And this is kind of, how should I say, it's a complementary service. Of course, our product will partly be hosted by the INCOIS ERIC, for example, the modeling tools and so on. And we also INCOIS ERIC by getting data seismic sources, about volcano sources, about meteorological sources. No, meteorological sources are not in that. So, sorry. This meteorological somewhere else. Let's just not talk about that. And then this is what in a way included. So somehow the model, the global hazard model, will in the end be hosted by GTM. Probably, or by INCOIS. It's clear where this is going to be, but INCOIS is just maybe here the coordinator Andre Babeko will elaborate on that later on. There's also a INCOIS complementary and it's a complementary effort. Yeah. No, the secretariat is actually at NGI. INGV is willing to host some services, like for example the services.
Thank you.
Sorry. Thanks for your presentation. A question regarding metro. No. So, have you seen any potential issues in areas where initial inundation, and if different areas that inundate your model? Because this is very useful for areas where you don't have information, probably you can have potential problems on that.
So my understanding is that in areas where the global will not be that detailed, the global has several thousands of interest. You can derive, for example, the hazard curves, probabilistic hazard curves, and risk is not in yet. It's just probabilistic hazard curves, and that means you don't have a detailed inundation map there. It contains the assumption on the possible influence on land, not a detailed inundation map. If detailed inundation maps are not available, then they need to be computed, but they can be computed based on the sources that are models, so they are consistent with that, right? If you have local inundation maps, these are usually not consistent with the global model, but that's not an issue. As far as I'm concerned, it may only be some source considered in the local inundation maps, then there's no contradiction. I think this is again some kind of complementary to the official maps already to assess where certain priority areas should be.
Okay, thank you. Yep.
I'm Shivraj Dupe, a director, Indian Ocean Rim Association, looking after disaster risk management. It's great to know that you talked about global hazard map is being up to the extent possible. Is for this exercise network of across the different regions? Because first thing is hazard mapping, and second thing is that to the quickest possible extent to get that message to the. Is this an exercise implemented with this part?
First of all, I would that question in the sense that a global hazard map is not directly related to the early warning operations. Is an information that is necessary in order to identify, also to identify that are of high vulnerability. It is not directly related to the early warning process. Related in the context, the warning context is how to do an early warning in a probabilistic sense, how to include the uncertainties, manage the uncertainties in a quantitative way. That is what we would like to contribute to the warning part. So we have, in a way, distinguish these two. Global hazard for the preparation, but not so much for the early warning, because for the early warning, as Fry is much about for an individual event, right?
Thank you. So, in terms of probabilistic approach, this approach can capture many uncertainties, but I think the decision maker, they really wants to have like very firm scenario. They expect that scientists one scenario that best solution for this for their location. So how we can deal with yes, we will provide the probabilistic approach, but then they really expect the very firm scenario. They don't want to think further about how to make a decision. Thank you.
I agree, and exactly this in the scientific, which is never exact. We cannot provide, as scientists, doing sound science means we have to communicate the uncertainties. We cannot say there's only one solution, because there's none. We know no one solution as scientists. On the other hand, society, political decision making on what is the final kind of message, and there should be only one, right? And GTM in a way exactly that gap, and probabilistic that gap, because they can say with 99% this area will not be inundated. Say 100%, but say 99%, which is good enough, right? And then you can say, but with 50%, this other area will be inundated, and then you can in a way determine the margins. And this communication needs to be decision makers. In the end, there needs to be a line. But we cannot say we only provide one scenario that already marks this to take place. And it's easier to do that on probability because you have a kind of a varying possibilities. You can, in my city, I'm getting to 60%. In another city, they are accepting 75%, 50% of uncertainty. So this you can discuss on this basis. That's what I'm.
much and these discussions. Thank you again. Thank you. Landslide by Professor.
Okay, thank you, Sensei. It was great for having the presentation, introducing the global tsunami. This presentation here is a bit more still presenting a domain where the GTM can, I would say, in the tsunami hazard and risk analysis, and also Brit is also focused on the objective. So it's a relatively level. I'm representative of GTM, but I also represent GI, the geotech. So landslide tsunamis, I think they really are the second frequent. They have been presenting something like 15% of all. They have submarine landslides which are full. They will always be just detected by a wave slide. Landslides that are in these, we also include the volcano flank collapse and aerial landslides that two volcanoes, and in fact, from the map here, it's either with earthquakes or other geophysical phenomena, but they can also, and you can see events such as in Norway, where you have our trigger on so on any slope material to impact a water. So this should be kept in mind. Should be kept in mind that have a much more local than earthquake tsunamis. And propagation. First, a few words about submarine landslides. Submarine landslides have been observed. So, some examples here from European project Europe, where it's the past of lands, several cubic, but they are also his pre. And although several areas are mapped fairly equally, this in very investigations. Some examples are very well mapped. You see here from the East Coast, the East and the Mediterranean, where you have a the largest landslides in particular, but very few are actually linked to operations. You see here a couple of main examples. The largest in history, back in 1929, the Papua New Guinea in 19 tsunami-genic. The and yeah, feeling that frequency of seeing the numbers of events and run-up heights of several tens of meters, some here, the Askia, Dixon Fjord that are all from, for instance, the Tan Fjord, the rotation as very much known earthquake tsunami, with hundreds of meters of run-up height. Dixon seismic due to the site. Mechanisms is very different from aerial lines are typically much more high low. To say a little bit about it, main factors for is for the submarine the slope, so you need shallow events on steep for impact that really generates tsunamis to be able to model the of the slides, and we need to be coupled. The tsunamis to dispersive, more advanced models for the tsunami problem. So it requires a bit more resources, and you can see here dispersion, waves that need to correct the tsunami problem. The other thing is the PNG Earth-related was triggered by a slide itself didn't have spread in terms of the extent of the source. It's higher, confined, meaning that the wave locally affecting it is difficult in terms of the extent, because it only impacts quite low waves around. Testing, it's somewhere in the infancy of landslide models, I would say. There's been a movement towards marking models, which we really need for our asset analysis. Are mainly experiments. It's important to test towards the field because the lab behavior necessarily. The slides tends to be modeled with smaller friction values, meaning that they have a scaling relationship that depends on the size of the volume of the slides. So we're trying to make this embedded into our hazard models, and this is something that in particular will contribute with. In terms of hazard analysis, it's also a little bit in its infancy. There are not too many examples of them, and the reason for that is that we need data to be able to simulate the hazard, either past data. So in certain regions of CADIS, information, we need slope stability analysis. Statistical analysis and then use in terms of building databases of sources, much like Jørn was illustrating for the global tsunami model for earthquakes, and then propagate to make hazard curves and outputs for landslides. There are only just a couple of examples on this for landslide tsunamis today. I think the lack of data. Probably one of the better examples is from the Cook Strait Canyon in New Zealand, where there is a possibility for constraining landslide data since the last 20,000 years or so, where you can use the past landslide data information, a probabilistic analysis model, and hazard map in the local region. Similarly for Norway, we try to locate this to unstable slopes, and in local regions where you have this unstable slope information, you can combine numerical models and the slope information to build hazard models and provide probabilistic analysis here. In both cases, we need definitely to calibrate the numerical models that we use for determining these. A second thing I wanted to emphasize in terms of this high-level objective is the link to the early warning. And the Norwegian example is one of the few that exists. There are also one in Stromboli that I will mention in the next slide, where we actually do not disseminate the warning as we do for earthquakes. The reason for that is the evacuation time is simply too short. Many of the fjord communities are less than a few minutes away from the impact area, meaning that it's impossible to evacuate people. Instead, we are using then instrumentation such as GPS stations, INSAR data and borehole measurements in order to measure the accelerations of the slope. And this can be then also linked to our hazard zonations. So we are able to evacuate people then in a matter of days before the event actually fails, which is a different philosophy than is typically done for our seismic counterparts. So there are some challenges, and try some final provocative statements around this related to linking the hazard, the risk, and the early warning to landslide tsunamis. We often lack the statistical basis for building the hazard models. We need some past events, or we need some kind of slope stability information to be able to build a hazard model. The dating is also an issue. Often these landslides are not dated. It's quite an expensive operation to get the necessary data. In order to warn, like we do earthquakes, the Stromboli example is one of the few examples where we can actually have gorges that detect the tsunamis, as in this paper by Ripepe and Lacan. They show that we can recurrently detect the tsunami, and because you know that landslides happen recurrently on this slope, then it's possible to build a system like this. When often based on the wave measurement can sometimes given the 10 minutes objective. So final questions is have a very important source. There are much more earthquakes. New hazards. We really need more data, and I think at present to this focus on where we have a knowledge or analysis, hazard data, and otherwise it will be necessary to collect marine landslide data or instrument slopes to be able to build the necessary hazard information for the necessary. So that's a
I can have one question because my timekeeping is not, it's not good for keep a lunch. So, if you have a question.
Finn, this is kind of terminology, but this is really quite important, and I would like to know your opinion. Traditionally, we have like main types of tsunamis, like seismic, landslide, meteorology. But for example, in now new catalog, they have 11 or 12 types of tsunamis. Landslides related to volcanic explosion, landslides related to seismic events, landslides independent, and so on. And actually, there is opinion now that almost every earthquake generates some kind of local landslide. So, there is a kind of math. How can we classify? So, just please tell your it is quite pity that Slava is not here, because this is his question. He's coming tonight. But
difficult one. It's, I mean, if you look at the circles here, these are earthquake with land category in the database. And I think most of them, if you look, they are like this. I mean, the Flores Island is a famous, I guess Palu would be the same. So, yeah, I would put the landslides there, but they wouldn't happen without the earthquake. Sometimes they are more important, like the PNG, for sure. So, yeah, I think we need that category still, and I can only imagine that for random slip events, you know, some of these slope failures are probably hidden in there, I guess, and it's something statistically that we have to treat partly by the earthquakes as well. I don't know how to do it.
because just an example, 1964, Alaska, but local landslide 60-meter wave.
Yes.
But we are talking about seismic tsunami. But Lituya wave also was produced by an earthquake. But we always have in mind this was exactly pure landslide tsunami.
Yeah, the problem, and that's why I try to bring up the aspect ratio, is that they are so local, right? If you want to detect them with these wave measurements, you have to have the wave measurement. I mean, the dart-like or whatever kind of wave gauge you have to have them everywhere, because they can happen on so many slopes. Yeah.
Okay, thank you. So next to go to the observation part, and the talk will be the smart cable systems, and the talk by Ceci.
So I just pass it with this one. With this works. Yeah, good morning, everyone. It's a pleasure to be here representing the ITU WMO UNESCO IOC Joint Task Force for Smart Cables. For more than 170 years, the ocean have connected countries, have connected people across continents. For over a century, scientists have been studying the ocean and the earth to see how the planet breathes and moves. And for over decades, governments have looked for better ways in how to protect their own people. What if we could merge all of these three purposes into a big one effort to serve humanity? That's exactly what Smart Cables is doing. This vision started back in 2011, where the International Telecommunications Union, the World Meteorological Organization, and the UNESCO Intergovernmental Oceanographic Commission got together to enhance submarine cables with science for the benefit of society. To make sure an independent body achieves this vision, they created the ITU WMO UNESCO IOC Joint Task Force for Smart Cables, a group of volunteers, over 400 volunteers with some. So we are very grateful for your time and for sharing your expertise to make sure this dual-purpose infrastructure can serve both research and operational centers. From 2016, three major leaders started in parallel three systems, the smart cables that currently we are having on board. From Italy, Laura Beranzoli started the INCOIS web demo, which was deployed in 2023 successfully. In 2027, we will have two systems. One started with José Barros, a representative from the Telecom Regulatory Agency in Portugal. Jerome Ocan started leading the TAM Smart Cable System, the system that links Vanuatu with New Caledonia. In 2020, a major supplier announced that they will provide the availability of the smart capability. And currently, they are the ones that are building the two smart cable systems that will be deployed in 2027. Right now, we are in a global momentum that I will detail along my talk. So, SMART stands for Science, Monitoring, and Reliable Telecommunication. We promote the global dual-purpose infrastructure, getting together connectivity and science for the benefit of society. Our mission is to have a global array of uninterrupted, sustained, long-term data, free and open data, to global repositories as well as operational centers. Here we can see the global map of telecom cables, and where we did some circles or figures, those represent systems we are talking with. The green ones represent the three ones that I already mentioned. In the Mediterranean, the WEDEMO, in the Atlantic CAM, and in the Pacific, the TAM. But we are part of a major system, the Global Ocean Observing System. For global coverage, we trust on satellites. But to measure other essential ocean variables, we need to have different ways to measure them. Every cartoon here represents a way to measure essential ocean variables. And smart cables provide an unprecedented information, long-term and sustained information of temperature, pressure, and seismic motion of the deep ocean and the seafloor, basically where climate change begins and earthquakes are born. To make sure we accomplish this, we promote adding trusted sensors into the telecom infrastructure. Sensors of temperature, pressure, and seismic motion, meaning accelerometers and seismometers. The essential key point here is that all of those sensors measure essential ocean variables of the global ocean observing system, which help us understand how Earth shifts, how heat content moves, how ocean circulates, and how sea level changes. Right now, there is a major supplier, Alcatel, that is developing this capability as a system as a whole, and there are different small companies that are delivering this by parts. The Ocean Decade Tsunami Program has one clear goal, that is delivering in at least 10 minutes a warning for every people and community at risk. SMART can make those minutes happen. Here, with a simple modeling of the Pacific Tsunami Warning Center, we can have how 5 cables in the Pacific Ring of Fire enhance their own operations. In the seismic register of the earthquake, we see that from their current capability, within a minute, they detect the 10% of the sources, but with the SMART, with 5 cables, this goes up to 35%. And with the tsunami detection, in the first 30 minutes, they almost don't detect anything, but with 5 cables in the Pacific Ring of Fire, they detect up to 40% of sources. But SMART can do more than just providing information of immediate danger. Smart cables can help us understand the ocean itself and how it is related to climate change. In this example, called Observing System Simulation Experiment, a group of scientists, members of the Joint Task Force for Smart Cables, concluded that having the pressure sensors quantify circulation variability and improve climate predictions. So basically, what pressure sensors can do beyond early warning. So SMART is about that, no? Linking early warning with long-term science, safety with knowledge, and the minutes that save lives to the decades that sustain them. Right now, we are having a global momentum. We have the web demo in Italy that is still delivering data in real time. We have the 2 systems that I already spoke about. All of this represents around 250 million euros in investment, which is a clear sign that the world is ready to build cables that not only connect, but also can observe and listen the ocean and the earth. And of course, all of this cannot be possible without the persistence of many of you. And here, there is a good sign that we are progressing. The European Commission has dedicated now a financial structure to fund critical infrastructure, where they are promoting smart cables. This is a small but powerful sign that how far this volunteer body has come. On 7th of October, this meeting of the European Commission, there was a question after the meeting where they asked which key features should be carried over into the next fund for the following 5 years, and right there in the middle was SMART. And right now, as our foundation grows stronger, we are having holders on board. We have the research and education networks with partners in Chile and the Nordic regions, multilateral banks that see smart cables as a good investment for disaster risk reduction and climate, and we have scientists, innovators, engineers from academia, governments and agencies, and companies, including the community of optical fiber sensing that are looking at how to sense at the Earth through light. All of these community represent the next wave of collaboration that we will have. So, as we are a global initiative, we deal with different systems. In this region, we have 7. One by the Nordic Research and Education Network, and the other 6 are led by Telecom, are applying to funding to this CEF2 funding that I just mentioned. In the South Pacific region, we have Chile that is doing the Antarctic cable, and we will have results by next year, early next year, about their feasibility study, and we expect to receive good news. And here in India, another country committed with ocean science and early warning, they are seeing ways in how they can enhance cables for improving what they do. So when we get together science, subsea telecom industry, and governments, we don't only connect countries, we connect humanity with the ocean itself. We are together transforming the global connectivity into a real-time observing network for resilience and climate. And together with the Ocean Decade Tsunami Program, we are closer to a future where every person at risk receives timely warning, and every cable laid becomes a protector of knowledge and life. This is what I wanted to share, and if you want to join this volunteer body, please scan the QR. Thank you.
Thank you. One question?
Actually, everybody who is working on data analysis knows this kind of paradox. Not so easy, but it is possible to get some for instruments. A little more difficult to get money to deploy these instruments. To maintain these instruments is quite difficult, and it is almost impossible to get money for data analysis. So data is coming, and only very little percent of them are processed. And very difficult to find money for this. Just an example, near Cook Island, we have very effective system of bottom pressure, at least. But only about 1% of this data. So this is actually a question. How do you plan to solve this problem, to process the data, what you get? Also, as a person who worked on data analysis for lifelong and also as a professional editor, I see that quality of data analysis is much worse than the quality, for example, of the data modeling. I am opening, I'm getting, I do cry. So, please, I would like
to know about data. Well,
do we have anybody? Do we have any money?
And we have a data management committee. There are professionals. So that's the far we got. And there are things that we have to work so you don't cry. It together, yes, definitely. Thank you.
Okay.
Yeah, thank you for the smart talk. Just a complimentary question actually with regards to the real-time access, right? I mean, at some point, some of the governments, maybe some of the Navy, they will see risky for security purposes. So how it's a good thing to start building right now. You have any development in that sense?
We have the example of Neptune. They develop a document between United States and they deliver it after time. I think it's every 30 minutes or something like that in the case of ocean, but if it's an earthquake or a tsunami, they deliver it in real time.
Thank you. I'm sorry. The next speaker will be Paul about GEPCO 3 2030.
We have to break because the side event is starting at lunch also.
Oh, okay, so we stop in here. I'm sorry because because my timekeeping is not it's quite bad, so that it's already lunchtime. After lunch, we can continue this discussion. Is that okay? And now until 2000.
Very much, Professor. So we'll take the break now. As you can, there is a side event to launch Macron Phase UNESCO, IOC, and Indian Ocean Tsunami Warning cap. And also there will be results presented regarding the system and the passive warning system capacity assessment of tsunami preparedness. We stop here, and I think our guest is waiting for us, right, Sunanda? But we can stop here and we'll continue at 14:30. Okay, coming here, okay.
Are you going to present now? Like fifth one. Session one, this is the one.
It's on the Google.
It's already
the side event.
Side event. Can you see? Check your presentation if it is okay.
It's in the drive. Google Drive.
Just 2 minutes. To this.
Yes, please. Quickly, just have everyone follow.
This one, ma'am. Ah. So how you want to got it? వచ్చిందా?
కాదు ఈ లింక్ మీకు ఫార్వర్డ్ దెన్ అప్పుడు వాట్సాప్ లింక్ డ్రైవ్ so he's going to open it. So
Okay.
yeah, just 1 minute.
Ladies and gentlemen, in the interest of as we get more set up and we can all watch this securely downloading quite slowly. I thought we would begin because I know we are standing in the way of your lunchtime. This has been such an interesting morning session, and hopefully the gap towards lunch with another interesting discussion and some exciting launches of some collaborative efforts. My name is Temily Baker. I'm from UNSCAP. Very happy to MC this event. So as we begin, I would like to invite 3 of our high-level guests with us to this to provide opening remarks. First of all, Dr. Ravichandran, Secretary of Ministry of Earth Sciences, Helgedson, Executive IRC, and Ms. Anna Bonapace, Director of ICT and Disaster Risk Reduction Division for SCAP. So, apologies. Invite Dr. Ravichandran to join at the podium here if you're comfortable, or the chairs, to provide some opening remarks. Thank you, sir.
Very good afternoon to all of you. Of course, I am not going to give very big opening remarks. Of course, we come across UNESCAPE in the last few years. We are working for the various activities, especially how the coastal preparedness for the various disasters or hazards, whatever is happening. We are in hand with UNESCAP. Mainly, we want to have more and more capacity building activities, not only for our country, but also in the entire region. So how we can develop whatever we learn, want to communicate to other countries through UNESCAP. I think it's going on well, and I think develop more and more capacity building activities. I'm sure that Ministry of Earth Sciences and also UNESCAP will come out with more and more plan for the capacity building and preparedness planning and other things in the coming years to come. With this, I thank you very much for inviting me, and I'm sure that in the coming years, already we started some of the things. We will come out with many more plans, both in terms of funding as well as also the capacity building. Thank you very much.
Thank you, sir. And again, I'd like to invite into the podium for your opening remarks, Mr. Vidar, Executive Secretary of UNESCO ISC. Thank you.
Thank you. It's a pleasure to stand here yet again and to open this important side event, which is not only an event. I would say it's a process, and it's a very valuable process. Again, let me thank Dr. Ravi and the Government of India for its leadership, but also thank our colleagues at ESCAP, represented here by Tiziana Bonaparte, for their continued support and collaboration. I said it's a process. We're launching today phase 3 of the project Strengthening Tsunami Early Warning in the Northwest Indian Ocean region through regional cooperation, supported by the ESCAP Trust Fund for Tsunami Disaster Awareness. It's of than $2.9 million in support to the IOC UNESCO initiatives in this region since 2009. And these are efforts that have been strengthening through risk assessment, awareness campaigns, policy support, and community-based capacity development. The current phase will support the ready implementation of Maldives, Pakistan, and Oman, and participating basis. Alongside this, we're pleased to launch this beautiful publication, the Pacific Ocean Capacity Assessment Report, again developed with support from ESCAP, as well as the governments of Italy and Switzerland, and the Asian Development Bank. These assessments, both the Indian and Pacific Ocean assessments, highlight progress and identify areas needs more targeted support, helping guide future donor engagement. These initiatives are, again, closely aligned with Challenge 6 of the Ocean Decade, community resilience to ocean hazards. We are very pleased with the results that we have seen from our work with ESCAP and other partners on this goal, and we are remaining to continuing that so that we can make progress, again ensuring that science, policy, and community engagement come together to lives and livelihoods. So I look forward to hearing more about this during these discussions. Thank you very much.
Thank you, sir. Now our third and final high-level speaker is Ms. Tiziana Bonaparte of ESCAP.
Thank you, Temeli. Secretary Ravichandran, Ministry of Earth Sciences of the Government of India, Executive Secretary Vidar Helgesen from the UNESCO IOC, colleagues, friends, real pleasure, opportunity to join you today at this important side event of the UN Ocean Decade Tsunami Program First Conference. And on behalf of ESCAP, I'd like to extend our sincere appreciation to the Government of India for hosting us in Hyderabad. And in particular, I'd also like to thank Dr. Bala for bringing us all together as a family. I think there's a family spirit that is emerging from our discussions today. I think a family spirit united around a common goal of building coastal and community resilience. I'd also like to acknowledge and highly appreciate the recent contribution that the Government of India, through His Excellency Dr. Ravichandran, made to our trust fund on tsunami, disaster and climate preparedness. The Government of India made a contribution of $500,000 to the trust fund, with a number of other countries. And this reflects, I think, a long-term vision, a long-term commitment to continuing to build disaster resilience. And so today, the purpose of our side event is to launch the Tsunami Preparedness Pacific Ocean publication and the start of phase 3 of the strengthening early warning in the northwestern Indian Ocean region, which Vidar specifically mentioned in his intervention. Both are significant milestones, and they are the result of many years of collaboration and shared commitment to understanding and addressing the gaps in our tsunami warning systems. Launching today is made possible by the generous financial support from Italy and the Asian Development Bank through the Trust Fund. I'd also wish to recognize the leadership and technical expertise of UNESCO and the dedication of the chairs and vice chairs of the intergovernmental coordination groups for both the Indian and tsunami warning systems. The guidance has been instrumental in shaping and delivering the tsunami preparedness capacity assessments. I think these efforts are more than just technical exercises. They really reflect 2 decades of progress since the 2004 Indian Ocean tsunami. They help us measure where we stand today and where we need to go next. The assessments have revealed both achievements but also gaps that persist. They remind us that tsunami risk is rarely isolated. Tsunami risk is compounded by other coastal hazards and intensified by climate change. And so it really calls for an integrated, multi-hazard approach that is inclusive and locally driven. So ESCAP remains committed to the global goal of achieving early warnings for all. We remain committed to addressing the regional dimensions of the ocean decade, in particular Challenge 6 on increasing community resilience to ocean hazards. The insights and outcomes from today's discussions will feed into the 9th session of ESCAP's Legislative Committee on Disaster Risk Reduction. It will be held from 26th to 28th of November, so in 2 weeks' time. I'm really hoping to see many of you at this committee session. It's taking place together with a whole week of events, Disaster Resilience Week. So hoping to be able to host you all and welcome you to Bangkok at the end of November. So let us continue to work together, guided by science, strengthened by cooperation, and driven by our shared goal of ensuring that every community is truly tsunami ready and disaster resilient. Thank you.
Thank you, Tiziana. Before I invite you back to your seats at the floor, I will also request a favor from our photographer to take a photo to officially launch this session. If you'd like to stand and hold the publication, that would be wonderful. And then I will have another favor to ask everyone in the audience. Thank you. And as you take your seats, I want to invite everyone else to stand, and perhaps we'll take a photo of the room. As you can sit down here, you can stand in the middle. We realize...
Beautiful flowers, we shouldn't cover them.
We realize we haven't yet got a photo of the conference, so we will do this on behalf of INCOIS. So please do join together. Okay, we'll also ask a favor. I have not asked him in advance, but maybe Ardito, you can lead us in the be aware, be prepared, be tsunami ready. If you know, you know. Here, I'll record.
I will yell, be aware, be prepared, and then all of us say, be tsunami ready. Ready?
Yeah.
Be aware, be prepared,
be tsunami ready.
One more time. Be aware, be prepared,
be tsunami ready.
Thank you.
Well done, everyone. I think we got the hardest part of any conference out of the way now. As you take your seats, I will invite our first presenter. We have two quick set the scene presentations just to set the stage for this panel discussion on these two things that have been launched. So I'll invite Dr. Srivastakumar. So I don't need to say much. Over to you.
Thanks, Timly. Just as everybody, they're going for lunch, I mean, you just told them we are going to have more presentations. Okay. Okay. Good afternoon, colleagues. So I know several of you, we have worked together. So I'm Srivastakumar, heading the Indian Ocean Tsunami Warning and Mitigation System Secretariat, which is based in Perth, Australia. I've worked before at INCOIS for past 25 years, most recently as the director for the last 4 years before I moved to Perth, actually, working with the UNESCO. So I'll make a very brief presentation on what we are doing in the tsunami through IOC, and then what is our collaboration that we have had with ESCAP. So most of you have seen this graphic. It's actually the global tsunami warning and mitigation system currently as it operates, as it is coordinated by the Intergovernmental Oceanography Commission. We have 151 members who are working across 4 ocean basins. So IoT, Indian Ocean, East Atlantic and Mediterranean, which is one of the first systems, and then remaining 3 systems, the Caribbean, Indian Ocean, NEAM TWS, set up after the 2004 tsunami. So there are 12 regional warning centers which are actually giving advisories to 150 members across all the ocean basins. Next slide, please. So if you look at the elements, more or less in all the 4 basins, these are the key elements. I'll not try to detail everything, but why I show this slide is, you know, this is actually, it has a background why we did with, you know, the kind that we have. In 2014, after 10 years of the 2004 tsunami, we have kind of met everybody. A lot of colleagues in this room have been there as well in Jakarta, and then tried to, what is the progress that we have made in the past 10 years, and then what are the gaps? And then there are some specific gaps that came up as far as Indian Ocean is concerned. There was good progress. We have had hazard assessments. We have had a geoscience data published with a group of experts from within the region and outside, a probabilistic tsunami hazard assessment for the Indian Ocean. That's on hazard. But then we knew that there were gaps that need to be addressed. We knew that Makran has not been studied at all in 2004. So we've wanted to do something to change you know, status quo. Detection, warning, and dissemination after the tsunami, we have had very good services that were delivered by the Pacific in the interim, by the JMA and the PTWC until about 2013, until Indian Ocean's own TSPs, India, Australia, and Indonesia came online. And so we had work of TSPs delivering warnings to 27 countries in the region, in the Indian Ocean, and then we've had observation stations, tsunami buoys, and that. Awareness and response, that was actually something, again, a big gap that was identified in 2014 as well. We have done some work, we have had TICs, we have had IoTIC, and then working on the last mile part. And that was first when I heard saying, no, we should not call it last mile any longer, or first mile. So those were the gaps that we have identified. Can we go to the next slide, please? And we have started working on some of those gaps. Now, then that was when the IOTWM has decided we should have a Northwest Indian Ocean work, looking at specifically what we do in that particular Makran region. That was time actually, as part of the trust fund. We were doing projects on awareness and preparedness and so forth. And we came up with a programmatic approach. Started in 2019, and then the collaboration continues. Not as standalone projects, but as a programmatic thing, trying to say that, okay, we should study the Makran as a whole, and we should have communities prepared. We have gone through 2 phases already, and then we have had probabilistic tsunami hazard assessment, the phase 1 developed, and then we are actually going to work on that. We have colleagues, Andrew Bebeco is here, Finn, all colleagues who have been working with colleagues from within the region, Mohammad Mukhtari and several colleagues who have worked on that and then improving the PTHA. Training has been taken up in 4 countries, in India, Iran and Pakistan, and Oman and UAE, who participated as self-funded project partners, to come up with several training. This is a training that was done called TEMP in this campus, helping them improve their SOPs and then helping them develop, do tsunami modeling and then develop evacuation maps and so forth. So now we are in phase 3. So that would be my last slide, I guess, the next one. Next slide, please. So there was an independent assessment of this project. I will not go into the detail because this is something the advisory committee of the Trust Fund Advisory Council saw through and said that, okay, there is a huge value in what we are doing in the region. Please. So this is what the phase 3, which is going to be, you know, which is announced and being launched pretty soon. So this is what it do. So we will actually build 2 new countries, you know, coming into the project. In addition to the 5 countries that I mentioned before, we have colleagues here. Chatura is there, Wahid is there. They're in this meeting. We are going to build their capacities to develop inundation maps, number 1, and then we will do the strengthening of the capacities of the national top, which is being planned in Indonesia. So that's the plan, to bring people together and then train them on, how to capacities on implementing tsunami communities. Also have some interventions at the community level, helping them put up their signages, their evacuation routes and maps and so forth, and drills. So that is also a part of the project. And then we also have a specific component, though a small component, on tsunami due to non-seismic sources. Like there's a small component for sources that we want to look at, and then that's where we also want to work in Fateme and partners here, looking at the non-seismic part. And then we are also having a small component on SOP, trying to see SOPs are there, good. We have worked with the member states on interventions to build their end-to-end warning chains for tsunami. How can we leverage on that and then try to as a kind of a perspective? A big focus from SCAP actually. So those are the components. At the end, we want to make sure that at least 2 communities in each of the capacities are built in the communities at the country level, and then at least 2 communities from each of those countries, then they are actually recognized as tsunami ready. Setting up of national tsunami ready boards, helping the countries doing all that, and then eventually we'll have, next slide please. So these are the communities that have been identified in these countries already due to the intervention done in the last since 2019. So we hope to be working with partners within these countries to ensure, like for example, India, we have 2 states, Chabahar and Jask in Iran, Gwadar and Karachi in Pakistan, Ambalangoda in Sri Lanka, Diffusi and Fuamula in Maldives. So these are the tentatively we have done some work already with colleagues from these countries, and then we intend to make sure that these communities are tsunami ready, and then it will finally impact of people is what actually the project is going to touch and improve and deliver upon. So thank you very much for your kind attention. The floor back to you, Temeli.
Thank you, Dr. Srini. We'll try quickly as well through this presentation. We've left up on the slide where we landed last year when we launched the Indian Ocean Tsunami Preparedness Capacity Assessment for the 20th commemoration, and I really do an SCAP alone effort. It was 21 or 22 out of the 27 members of the Indian Ocean Tsunami Warning System. I think I have 2 copies of this outside, so if you want one, I'll give one to you, but otherwise I'll put up the QR and you can download this for the Indian Ocean. Next slide. But this, next slide please. Next. Okay, thank you. But this initiative really was a conversation between SCAP and UNESCO trying to figure out what the gaps were, and I think learning from this Makran program, it really developed together out of recognizing what the gaps were in initial capacity assessments. So this is what we decided to do last year, looking at 20 years of the Indian Ocean Basin, and this year looking at 60 years of the Pacific Tsunami Warning System. So we set out together with 3 objectives. One is to evaluate the capacity of tsunami preparedness in both ocean basins, and then to identify what the gaps are for capacity development, and then also for us to look at how we can support addressing some of those gaps, just as we have for the Makran subduction zone. And I will say thank you again to the government of Switzerland and Italy, as well as the Asian Development Bank, who funded these 2 specific studies. Next slide, please. So just to show you, this was actually quite a mammoth effort. I did the numbers. I think 56 coastal countries have participated in the last 2 years in a tsunami preparedness capacity assessment. When you probably ask yourself, why is SCAP here? When our countries ask us, what can we do on tsunami warning systems? I say, you sit in a very interesting place in the world. We are in between ocean basins, very different geographies, very different capacities, and very different levels of risks and exposure. But this is the breadth of the countries that had participated in these 2 capacity assessments. So we're very proud of how comprehensive it has been, and how much we've been able to learn in terms of the progress that we've been able to achieve together, but also what the gaps are and where we can look forward. So the next slide, please. So for SCAP, ESCAP, and I think Srini has also alluded to this, we're very much focused on addressing multi-hazard risk hotspots. So we're trying to take not only where the tsunami risk is high for population structure, but we try to look at this from a multi-hazard perspective. So here are some of those numbers that have come out for the Pacific Ocean at least, and I just wanted to highlight a couple. You know, looking at the low-lying atoll countries like Kiribati, we have such high exposure of populations that are really in not just exposed on coastlines, but exposed on where the water will flow. So when you look at the evacuation planning, how can you evacuate these large numbers of people? Then when we look at critical sector, I was surprised, but also not surprised. You know, 100% of education facilities in Tuvalu are low-lying enough to be at risk of things like storm surge, things like the tsunami waves. But when you consider it in climate scenarios and sea level rise, the risk exposure continues to increase. So this is the perspective that we're coming from ESCAP to really start talking to countries about their sustainable development. Next slide, please. So this is a lot of text here, but I'll give you the book so you can read it for yourselves. These are some of the gaps, but also some of the progress that we've seen. So we've split this up by the early warning for all pillars, which is a little bit different from how we consider them in the tsunami warning space, but we wanted to try and make sure our learnings are accessible across the board. So some of the key wins we've seen is for disaster risk knowledge, 81% of countries in the Pacific Ocean basin have conducted tsunami hazard assessments, but we do see some really big gaps, especially when it looks for the Pacific Island countries and territories, with the ability to make local level assessments. With regards to observation and we've already heard today, but I will highlight that there's big gaps in terms of looking at those local sources and non-seismic sources, which we all already know. Then looking at warning dissemination and communication, mobile networks, internet coverage has made our jobs a lot easier that we're all aware of. But when we consider remote rural island communities, the warning communication infrastructure is a big gap. And then connecting them to the local warning standard operating procedures, this is one of those gaps that we need to fill. And then on preparedness and response capabilities, the Pacific Ocean is quite advanced when it comes to the standard operating procedures and what to do at the national level and having them integrated within national disaster risk management planning. But we do see at the community level this can be increased. Because our UNDP colleagues are here, you know, we have tsunami education only 24% of countries' curricula, and I think this is probably one of these low-hanging fruits that we can achieve together. So these are just some of the main findings that we found across the whole ocean basin. Next slide, please. And then just some more I wanted to pull out for you. Some wins. People have a lot more access to the seismic networks, but data sharing is not as high as we would hope it to be. And this is also similar for the Indian Ocean basin. You know, the DART networks has filled such major gaps, but we also do see some considerable local tsunami source gaps prevalent. You know, there's still more work that needs to be done on post-event data collection, and then also some more work on, you know, making sure that we're monitoring local tsunami risks. These are just some of the findings. This is a big report you'll see, and it's quite comprehensive, so I couldn't put everything up on. Go to the next slide. I wanted to make sure that we follow some time. What we've been able to do with those is, we know the progress, we know the gaps, but what is the next steps? Because there's such a diversity of countries, risk exposure, but also capacities, we've divided that up into kind of where we see countries looking to focus on, whether that be they have high capacity, able to integrate things like artificial intelligence within their system, to medium capacity countries where they really do need to, you know, foster and anchor themselves within the international collaboration efforts, and then low capacity countries where really the focus is about the last mile or the community level, making sure that they can be prepared as much as possible. Next slide. And just to highlight a little bit of where we come from, this work and our commitment from ESCAP is through the Trust Fund for Tsunami Disaster and Climate Preparedness. It was established in 2005 2004, straight after the Indian Ocean tsunami, with a $10 million grant from the Thai government. And since then, it has galvanized support from another 11 donor countries and co-financers. And we really do aim to try and achieve economies of scale and scope through pooled funding in support of South-South and triangular cooperation efforts. Next slide. I wanted to also share with you, we've just launched our new strategy looking forward. And this strategy, 2025 to 2030, is where we hope to address some of the gaps that have been identified in this capacity assessment. So we do want to make sure that all of our investments are risk-informed, but also meeting the needs of countries working together. So the vision that we do have is strengthen coastal resilience to disasters in Asia and the Pacific. It is a broad focus, but it is focused on coastal resilience itself. Next slide. And another thing that I am really excited actually to share with this room is that just as of last week at the World Tsunami Awareness Day, our Advisory Council endorsed a call for proposals. So this will be coming live very soon. Please scan this slide and I'll send you an email directly once this is live. But really this is about seeking partners and future projects to invest in, whether it be a small grant or a longer term program like you've seen for the Makran Seduction Zone, that we can work together over a long sustained period. The three modes of working that we like to support is one, strengthening regional cooperation. Two is mainstreaming science, technology and innovation. And three is really how we can institutionalize and empower local action. Next slide. And with that, I will close. And with that, I think I can understand now why our slides took a long time to come up on the screen, because of formatting things. But I will introduce Mr. Ardito Kodijat, who was also our enthusiastic group photo host, just then to come to the platform. Comes up, I'll also invite the panelists who will be talking about this session. So Dr. Bala from INCOIS, Mr. Bernardo Aliaga from UNESCO IOC, Dr. Suchi Dewa Anugrah from BMKG, and then Dr. Yulong Miao from the Joint Tsunami Warning Center. I think we may be missing one. Oh no, there's a chair. And with that, I might pass over to Ardito. Okay.
Thank you, Temini. So this is the most difficult part because we are standing here, or we're sitting here between you and lunch. So less painful as possible. So let's make the conversation more interesting, attractive, so that we forgot about lunch. So we'll start. So I would like to start maybe with our host. So we have questions that we have prepared, and unfortunately our colleagues, Ms. Nadine Antenen couldn't come because of her illness, so we have these four distinguished guests that will be sharing with us or their thought about these two projects that has been mentioned related to the capacity assessment as well as the Makran region. And maybe it's more appropriate to start my questions with our host, Dr. Balakrishnan. So I think India's leadership through INCOIS has been a key regional tsunami preparedness. What your team has been doing actually very important, and especially also linked into the phase 3 projects that we are going to implement hopefully soon, which is the strengthening tsunami in the Northwest Indian region through the regional cooperation. As Srinivas has mentioned, we are increasing the number of countries participating in the project. So our questions in mind is, what is the biggest opportunity you see when countries can work together in a shared hazard like Makran subduction zone? So what are these biggest opportunity that we can get? Thank you.
Ardito, thank you very much. So
this is a very important question you asked. I think many of the clues you already got from Srinivas and Tamili. So, Northwest Indian Ocean project, the phase 1, I think we are more focused on making a robustness of our early warning systems and gap analysis and make it more much robust. But in the phase 3, definitely we have to go more on the preparedness of these communities. In this, we have a lot of programs we have planned. The first thing is actually how to collaborate with all the countries in the region to have a kind of a observation system, the multi-purpose observation system that can actually cater the early warning needs of the system. For example, we know that the Macron subduction zone, there was it was quiet for many years. 1945 only we have first tsunami. So most of the countries are concerned about the tsunami which can be from this region. So INCOIS is a part, I think we are actually having some programs to establish the kind of a state-of-the-art the monitoring systems or the observation like the cable observatories. While going for this kind of observation, we require a multinational and the international collaborations. So you know that Macron subduction zone is mainly on the east side of Pakistan, and that us we require a multi-institutional or multinational collaborations in the, and that is one of our the first priority. So we also have a request to the IOC Indio as well as this UNESCAP in terms of this multi-hazard the donor fund, how we can collaborate together for this purpose. So importantly, there is one thing for that we also has to focus on how to take many of the countries in confidence for the tsunami ready program. As you know that in the India, we are working with many of the state disaster management authorities and state players to make it. You know very well that we have the Orissa is very enthusiastic and they have 24 villages. Now many other Indian states are coming forward like Stream was mentioned always with the Kerala and the Karnataka. And the more importantly, we are actually focused on Nicobar Islands, where we already started one cable observatory program with almost 170 kilometer long. And also working with the state government to make a regional center of this institute in Andaman itself. So that is actually, I want to make it more, stress it is more because this is good for the INCOIS at Hyderabad, but our more the stakeholders meeting, more observations, and more the tsunami ready communities will also have a coastal entity. So we are planning all over the 5 centers which will cater not only the coastal states but all the coastal island countries also. So we'll have a more data and more communication from that countries. So in addition, we also made the IOC Indio. This is one of the preparedness is one of the priority program. So we have a Indian Ocean Science Conference, International Indian Ocean Science Congress on 1st to 5th December at INCOIS itself. So we are actually having also side meeting of IOC Indio where this we want to make a priority preparedness and the phase preparedness program, and many of the countries are ready to collaborate and ready to contribute in terms of money. So this is some of the initiative we are taking from the INCOIS. Thank you very much.
Thank you very much, Dr. Balakrishnan. So I think, I'm not going to say, but I think INCOIS located here very strategically in terms of having the expertise, like you said, the early warning system, also hosting this IOC Indio. So INCOIS managed to actually leverage on different sources in terms of supporting these regional activities, especially looking from the Makran subduction zone. So thank you very much for that. And I think now I would like to move to which is looking into more global, which is going to Bernardo. So I think through the Ocean Decade Tsunami Program, UNESCO IOC have been mobilizing a range of actions, both at the regional level. You see this, the project of the Makran subduction zone actually helps it to contribute into the UN Ocean Decade.
I will start by saying that ESCAP for us is not just a funding source, it's a real partnership like the one that we have with UNDRR. It's a mutual feeding, I would say. Because we, for example, this slide that you usually are looking at in the tsunami community is as important as all the rest. And this is something that ESCAP is getting into the equation. I wish that we had the same kind of partnership with other regional like ECLAC or CEPAL. Pass the word to the colleagues at ECLAC or UN Africa. That will be very beneficial for the entire hazard community. That's my message here, but I want to know that started in 2010 where the government of the Sultanate of Oman project coordinator was our beloved and cherished Dr. Fauci, that was head of the BMK warning center. We had a meeting of the hazard in the Makran zone. You know that in 225, 326, there was a big tsunami generated in the Makran source that hit the fleet of Alexander the Great. A campaign in India. So, and then well, there's the 1945 Makran tsunami that is more known to the community. But in the same meeting, I historian from the Sorbonne University that was working on the 1723 earthquake and maybe tsunami in coast of part of the fleet there. So that's to tell you that the ESCAP and Makran thing is still not finished. We have a lot of to come, and we have need of more partnerships with UN regional bodies. Thank you.
Thank you very much. And I completely agree. Working with ESCAP, especially at my level, working with Temli, it's more of a partnership rather than a collaboration. And I think one of the most important project, this is the one that you are facing, is very important, but the one important project is the documentation of the IWIT 45 Makran region, because it was the first, I think, in 2015, and based on that, we have a lot of documentation of those who are actually or witnesses the 1945. Because without doing that documentations, I think it's difficult to actually learn from who actually really experienced the project. So it has been a very long-standing partnerships, and I'm sure it will be continuing for much longer. And of course, I think the message is conveyed, so hopefully other regions we did with ESCAP. So, so that's basically related to the two projects of this Makran subduction zone, which is I have been involved and very so engaged with them. But as Tamili mentioned, in addition to this, we also look into what has been actually established and what is actually the gap and the features that we can actually do in partnership between IOC and ESCAP and also with other UNE to address this to Ibu Suci. So Ibu Suci attributed to the assessment preparedness capacity across the Pacific Ocean, the one that we just. Could you share things on the assessment and what priorities actually highlights most for states?
Thank you very much. Start from Indonesia, part of the Indian Ocean, part of the Pacific. Part is actually in the central from the capital, meaning that the gap is being in the eastern part of Indonesia, which is not easy to access. And the other things is for Indonesia, because Pacific part of in the eastern part mostly located in the complicated tech setting, so it is not a tsunami that is facing to this location. Non-seismic, many there are experience on non-seismic tsunami in the location. So maybe the 2004 tsunami we tried on the seismic, then after 2018 tsunami. I think it is only so the homework for us, and for the Pacific, what we find from the capacity assessment is everything is similar with the eastern part of Indonesia, isolated area that is not easy to be accessed. And the other things is inappropriate or inappropriate communication, dissemination to the people. I agree with you, Harkunti, that for this, we have to optimize the local social network that we could champion from this local social. I believe in the remote area, the social network, the local social network is very important. So we already have an example from our sekolah for nelayan. One champion could save in this community due to the tropical cyclone, because these people has been learned from sekolah lapang cuaca, the natural, then before the extreme weather comings, this person can save the people for the very last mile. We have to based on the assessment, we found that there are almost 60% of the member states of the Pacific are not implement ready, because they are not know. Countries, I think it is our homework for the ICGPTWS to promote more massive this program of tsunami ready recognition. So that's from my side. Thank you very much.
Thank you very much. So I think it's capacity assessment, even though it's being done regionally, but also the input is nationally. And as Ibu Suci mentioned, that it actually also helps to identify the gaps that they are facing in the eastern part of Indonesia. And that actually, what Ibu Suci mentioned, that the capacity assessment will also help nationals to actually look into what is their and challenges that they are still going to have to face. And I think Ibu Suci mentioned about the local social network, so the champions, and I think a lot of champions are also available in the small island developing states. So this is something that we can also leverage in terms of introducing the tsunami. % who the 8 countries that is not know yet what is tsunami ready. So lastly, I think it's also important to know from the Australian Tsunami Warning Center, Dr. Yulong Miao. Australia is located as in Indonesia, both Pacific and Indian Ocean. So, and you have capacity Pacific. From your perspective, how can actually regional either in Indian Ocean or in Pacific or in Ocean and Pacific help to was identified through this assessment, and what may be the biggest challenge?
Will to sustaining the fund, and it will be a challenge. And also, yeah, it's just the people's memory has been short, so that so the interest in tsunami is waning after 20 years. And then there's budgetary constraints everywhere, and tension and etc. that may or may not be conducive to regional collaboration kind of mindset. But what can we do here? As I always see, UNESCO coordinated inter program. And each ocean basin now has this system of systems, which means the tiers, the more developed countries take a big shoulder of the investment, but be it in the risk hazard assessment, and be it in embracing the new emerging technologies such as smart cable and GNSS and hydrophone, etc. Yeah, and this government coordination, and also having the groups ocean basin, they can leverage of each other, they can share the practice, and through the TOES working group, which we're glad to have a coordination as well. Standard and mindset, leveraging, sharing information, go a long way towards, improving the ocean basin global capacity by all. And so that's my.
Thank you very much, Dr. Yu. Yes, some countries have the Indonesia, Australia, who is actually facing two, so they are engaged with the 2 ICGs. Some countries only participating in 1 ICGs, but then sharing the TAOs, the inter-ICGs, actually between the. I think the one thing that you also mentioned, high-level objectives, actually also help in terms of trying to address the issues that has been the capacities. I think it's financing challenge anywhere, and every time. I think we as a family, we need to keep on to be persistent, despite of the challenge, funding and so forth. By continue to be persistent, sounding the importance of tsunami, as you said, memory short, it's our duty to be persistent, sounding the tsunami. You don't want to have another lesson learned. We would like this big event becomes that we have been. So thank you very much. So I hope you forgot about lunch. But with that, Ari, Tamily.
Thank you. You can remain seated. I'll invite Tiziana up for some closing remarks. The feast from INCOIS.
You all from your lunch. Yeah, I know you're all getting very hungry. So let me try to be a good auntie, and I'll be short. But I do want to because it's important for people to thank us. So I'd like to first extend a heartfelt thanks to our co-organizers, UNESCO, Ministry of Earth Sciences of India, under the leadership of Secretary Ravichandran. I'd also like to express heartfelt thanks to our panelists for sharing important insights, interesting country experiences, so in particular for capturing that. We work for consensus-based approaches. We try to find the common grounds and bring everyone together under one common objective, one common. So I'd also like to thank our contributing of the Pacific Ocean Capacity Assessment from the PTW as well as the participants of the Makram program under the IOTWMS working group for the Northwest Indian Ocean. And once again, special thanks to the Sciences and Secretary Ravichandran. In tsunami early warning systems, we will continue to work in partnership with you. And I'd like to close by these important comments at the upcoming Disaster Resilience Committee. Finally, and then you can go for lunch. General last week said the ocean means recognizing its power. Invest in business for every coastline and every community. So that inspirational note, close the event.
So this is the lunch break. It is in a different building in this campus, and it's around 400 meters here. Like if anybody would like to take a walk, it's they're outside, so you can colleagues they'll show you how to go there. And there are shuttles in main gate, but maybe you have to wait. They drop and they come back. So that then we'll be, now it is 1:50, so we'll be coming back at 2:50. So delay we are running. Regarding the lab visit, so that is we are planning. So we have here. So before and after the session, so we have lab visit. So you all are welcome to Synops lab. It is in the second floor. I'll be guiding you how to get there. So this is
Hello.
Check.
Okay, can you take your seat, please? We can get started. We are 15 minutes late from the normal schedule and 2 presentations behind. So we'll try to catch up. So again, I will reintroduce Professor Tanioka to continue with 2 next presentation. And just to keep in mind, also we need to take some notes for reporting on tomorrow afternoon. Thank you very much.
Thanks very much. Thank you, everyone, for coming back. the dreaded first speaker after lunch slot, but don't worry. Right. I'm going to talk to you all about the Seabed 2030 project. And whenever I'm speaking to students or to industry partners, I always scare them when I start the presentation with this slide. You don't need to read it, okay? But what we're trying to get across to people is every single one of those things is a law or a regulation or a requirement that if your government or your company doesn't obey can get you sent to jail or pay a big fine or something. And nearly all of these things require maps to inform them. And this is kind of the almost legal driver that sits behind a lot of the reasons for the seabed mapping. So tsunamis matter, obviously, huge, but so do all others as well. And essentially, global maps turns out to be essential to be able to do effective and reliable tsunami prediction. Now, GEBCO, the General Bathymetric Chart of the Oceans, goes back quite a long time. It was started by Prince Albert I of Monaco in 1903. Very high net worth individual, one of the sort of Elon Musks of his day, who had a nice expensive yacht, and he was able to go around with his bunch of oceanographers helping to gather seabed mapping data. But even then, a lot of it came from industry because it was the people laying telegraph cables, telephone cables around the world that tended to have the deep ocean mapping data. So when GEBCO first started, it didn't even have things like mid-ocean ridges accurately mapped. And some of the cable layers had some very, very expensive mistakes. When they go and lay a telegraph cable not knowing there was a mountain range somewhere, it would be stretched across a mountain, hanging over a valley, and of course the cable would break and they'd have to go back and lay it all over again. So gradually the map got better and better until as we moved into the 90s we started using digital reliefs. But it was still between 1903 and 2016 we only mapped 6% of the global ocean, and means an awful lot of it was left. So Nippon Foundation stepped forward and said, well, try and fund or at least inspire people to complete the task. So it's a straightforward system. It's a joint program of the Intergovernmental Oceanographic Commission of UNESCO, which I used to be vice chair of back in the 2010s. Coupled with the International Hydrographic Organization and paid for by Nippon Foundation. There's where we are at the moment. So we went from 6% in 2017, we're now at 27.3. Now, basically all the areas in dark blue are mapped to a reasonable level of accuracy. And when we say reasonable level of accuracy, we mean something like a single spot depth in an area the size of a football field. Yeah? So if you've got a single spot depth in a sort of 100 meter by 100 meter square, we'll count that as well mapped or a thoroughly mapped ocean. So obviously there's still lots and lots of gaps. But as you'll see, particularly in the southern hemisphere, major gaps arrive. And those gaps are filled with satellite data. And the satellite data at its best is about an 8,000 meter resolution rather than the 100 meter that we aim for. So if you're basing your tsunami modeling and your digital twins purely on satellite data, there are going to be some pretty big levels of inaccuracy in the seabed bathymetry model that you're using. which is why we're trying to do this properly with acoustic means to get you eventually a decent map. So we don't aim to try and get 1 meter by 1 meter. We know we can't do that. We ask for 100 meters by 100 meters, but we will work at 400 or even 800 meters over, say, abyssal plains, areas where there's not a lot otherwise going on. How do we do it? Very much reliant on robots now. There are only a limited number of human-occupied platforms available. You know, the traditional legacy survey ship, there aren't actually that many of them. And critically, data, if you send out a survey ship to gather data, the data belongs to whoever paid the ship to go out there and gather it. It doesn't belong to the ship operator. So if you're Fugro or Guardline or somebody that you've been given a big contract by, say, BP to go out and survey an area to build a new oil field, you can't just give away that data set. You have to go to the client and say, please, can we donate your data set? Now, if it's in waters within national jurisdiction, out to the edge of the exclusive economic zone, normally, as part of marine licensing, governments require the private developers to share their data sets. But once you get beyond the 200 miles, it's the Wild West. And then it's people like me going to the oil and gas company and saying, come on, you know, please, I know you've got that data, share it. And they'll say, well, we're not giving away our multi-million-dollar 1 meter accuracy survey. I said, no, I don't need your 1 meter accuracy. I'll take your 100. You can take out where all the internet cables are, for example. We don't want people dredging them up. So once you get back to them, say, we'll take a lower resolution grid, usually they start being quite helpful. And we're getting very reliant now on autonomous systems. The new ones like Drix and Sail Drone are really, really effective forms of gap. We work a lot with the general public, even high net worth individuals, and that can range from people like Victor Vescovo, who used his own private vessel and submersible to dive to each of the deepest parts of the major ocean basins. He's contributed all of his data to us. We have a charity called Seakeepers, who data loggers on private yachts. We have cruise ships working for us. There are even over places like the Everglades and coastal coral reefs. We've got people with echo sounders on stand-up paddleboards. So there are all kinds of resources becoming available. And sometimes that shallow water, higher resolution stuff is exactly what you need to make sure you've got accurate tsunami prediction pathways. You can use satellites to an extent, except you have a fairly limited accuracy. Let's say about 8,000 meters over full ocean depth is better than that over shallow waters where you can physically see the bottom. Ditto, LiDAR only really work low. So there is a role for satellites for drones, but it tends not to work other than the very shallowest waters. Just we face the reluctance to release existing data. We reckon at least 25% of the be mapped up in private vaults. So a lot of our work is persuading those people who have legacy data to release it. I would pay a lot of credit there to there's something called the Corporate Data Group installed within the UN Ocean Decade Office in Paris. And the Corporate Data Group have been absolutely brilliant. They're talking to companies like Chevron, BP, Alcatel Submarine Network. I know a few of the other presenters here. And these companies are starting to really come together and bring up their legacy archive. I mean, Alcatel, for example, have going back to the 1860s from the companies that today form the Submarine Network. So we're putting together a system with them at the moment where we'll help them get interns who can do data mining, going back to that legacy data to help fill in the gaps. And we're expecting to get some pretty neat stuff there. Getting people to pay for data collection is always a challenge, particularly in areas beyond national jurisdiction. Who pays for it? And even if someone is paying, it's the UN issues. I have companies coming to me saying, I've got a wonderful data set, but I never actually asked permission to map any of that water. How do you keep me in jail? It's quite a complicated legal process of having to do retrospective applications for mapping for stuff that was maybe 1920s. So it gets quite interesting and very, very complicated. A lot of outreach. We turn up at the trade shows. We try and shake hands. We try and meet people face to face and go through it all in as much detail as we can. So I've shortened it a little bit because I knew we were running out of time today. So hope that gives you in a nutshell a quick basic introduction to Seabed 2030. I'm on one of the other panels tomorrow as well, so you might get to learn a little bit more. And seek me out over coffees, over meals, and I can fill you in on gaps. And I got giveaways as well. You can have a Seabed 2030 badge and things like that. So, yes. That was the 2020. That was 2024 to 25's new data. Yeah.
Oh, the red lines are the new data.
Red is new data in the last 12 months.
Wow.
We typically get about 1% of the ocean per year. 1% of the ocean is 4 million square kilometres, size of an area of the European Union, larger than the Indian subcontinent. So we're getting that typically per year. So the readers and this is all donated because anybody to serve persuading people to give up. It's getting into those grey areas because if it isn't on a great circle route between seaports and it's not in an area where there's oil and gas exploration or pipeline laying or cable laying, how do you persuade anybody to send a platform out there? You can see, for example, MH370. That's all the survey tracks trying to find the missing airline, and that's happening again. That search has resumed again recently. We should get a bit more data from that as well. But we're very reliant upon these donations at the moment. Okay. Thank you. Okay. Right.
Thank you, Mr. Chairman. So, a question that often arises when it comes to tsunamis is how the seabed information or the sea level information and the bathymetry is matched to the topography data. How do you deal with that challenge to, in a way, bring these two data sets together?
Right, so that one overlays the other, where we find that the real bathymetry is more accurate than the radar mission, then the real bathymetry gets priority. But you tend to find that we're using that kind of radar data to help fill in gaps where we haven't got real bathymetry. But bathymetry always wins. But if we haven't got it, then we'll use the other data set. The other issue is highly dynamic areas. So particularly again in coastal zones, the frequency with which they might be resurveyed is so slow that if there's been, say, a major storm event or indeed a tsunami, it may well be that the bathymetry has been changed by the pattern of that wave going through. So then you have to redo it later afterwards. Okay.
So just to say that Alessandro Amato provided a recorded presentation because he could not come.
Not played, audio? This one, huh? video? This video, this one.
Along with that video is presented. Here check loose connection.
No, not loose connection. What is one moment I will select audio. Pinch already. Wait.
Also, in many countries of NEAM, there are continued efforts to improve the tide gauges network that Good morning to everybody. My presentation. Good morning to everybody. My presentation will be on the recent advancement in the deep sea monitoring in the NEAM region. I would like to thank the organizing committee and in particular Sunanda and Dennis for Chanseng for inviting me to give this presentation. I apologize for not being able to be there with you. I'm really sorry I could not manage to come. I will talk briefly of this topic and how we're trying to improve our monitoring of sea level for tsunami detection. In particular, I will give an update on ongoing initiatives with the development of smart cables, deep sea observatories, tsunami buoys, monitoring of non-seismic tsunamis. In particular, I will show something about the Stromboli volcano in the Mediterranean Sea. First of all, let me emphasize that also in many countries of NEAM, there are continued efforts to improve the tide gauges network that at the moment are still the most widespread and used tools for monitoring tsunamis. As you know, in this slide you see one of the most relevant developments of the last couple of years, the one carried out by Turkey, by COERI in particular, with the installation of 20 new tide gauges in the Marmara Sea, that, as you know, is one of the areas with the highest seismic and tsunami risk in our region. A recent earthquake with a magnitude 6.3 in last April 2025, with a small tsunamis that occurred, was detected very well, showing the efficacy of this network. Other progress are to improve the tide gauges observations are ongoing in several member states. For instance, Greece is updating the whole network with a major upgrade involving the installation of over 30 new stations in several locations. Going to the smart cables initiatives, you probably know about this project called CAM for the Atlantic, in which telecommunication cables will be deployed between mainland Portugal, the Azores and Madeira, an area which is famous for the so-called Lisbon event, earthquake and tsunami, in November 1st, 1755. We had the 2070th anniversary just celebrated in Lisbon in Cascais last few days ago, and there were also important other tsunami events in this area in the past. The smart cable will include several nodes equipped with seismometers and pressure sensors. It will be operational by the end of 2027 and will allow to reduce times of tsunami alert and the uncertainties on the causative source, thus improving our capacity to forecasting the impact of tsunamis along the European and the African coasts. Another interesting initiative is this MISTS project, still in the embryonal phase, let's say. Was proposed by a French consortium to which several member states are involved, are going to be involved. The idea is to have a very long cable crossing the Mediterranean from west to east, to which different branches can be added to improve the connection and the scientific and monitoring component in different areas. As you see, the smart cable will cross active areas of the Mediterranean where destructive tsunamis have occurred in the past, like the Ionian Sea, the Crete and Hellenic Arc, the Cyprus Arc, and so on. There are also ongoing efforts to exploit existing deep sea infrastructures to contribute to tsunami monitoring. In this slide, you can see two recent examples in the Ionian Sea, where seismic and tsunami monitoring has been added. In the left picture to the EMSO Calypso Seafloor Observatory offshore eastern Sicily. In this case, an instrumented cable has been deployed with 3 nodes hosting seismometers and pressure temperature sensors. To the right, we see another very interesting initiative, the Deep Seafloor Observatory in the Ionian Sea at 3,500 meters depth. This is a big infrastructure built by the nuclear physics community with a huge, very huge investment in which we could install some geophysical instruments for seismic and tsunami detection. The data will be soon distributed through the IOC portal. Last update refers to the recent deployment of tsunami buoys, the first tsunami buoys in the NEAM region in the Ionian Sea. This is the boat with the 2 buoys that you see, the yellow big cylinders over there. This occurred last September 2025. Here you see some pictures and some movies about the installation. And in the bottom left you see the map with the location of the 2 instruments in the Ionian Sea, offshore Sicily, offshore Calabria, an area in which very important earthquakes and tsunami occurred in the past. This initiative has been led by INGV in Italy in the framework of the project MEET, funded by the National Plan of Research and Resilience. The depth of these sensors are about 2,600 and 3,200, and they are connected with acoustic links to the buoys. The buoys have been built by the Spanish MSM, Mediterráneo Señales Marítimos, in cooperation with the Sonardyne from UK. I have to say that one of the 2 buoys had some problems in the last couple of weeks. We are trying to understand what happened. Anyway, the data from at least one at the moment are currently received by our center in Italy and will soon be distributed through the IOC portal. Of course, buoy will improve our tsunami forecasting capability in real time. So let's go to the last part with the volcanic tsunamis. Our SEG has recently activated a specific task team on this important topic, on non-seismic tsunamis in particular, and volcanic in particular. As you know, in the Mediterranean, most of the tsunamis are generated by earthquakes, but we have also some important active volcanoes that produce tsunamis both in the distant past, for instance, the Santorini, Greece eruption and caldera collapse more than 3,500 years ago, or in more recent past, in Stromboli in 2002, there was an important tsunami. Also, probably you remember that in 2025, at the beginning of this year, Santorini raised again the attention of scientists, decision makers, cities and tourists in Greece, and not only in Greece, after a series of hundreds of strong earthquakes that occurred at the beginning of this year. So there was the threat of something going on, but fortunately at the moment nothing happened, but there is some project to improve the monitoring in this area. Also Stromboli did generate, fortunately, small tsunamis in the last few years, for instance in 2022, and is currently monitored by a local alert system activated a few years ago by the University of Florence. More recently, this July 2025, INGV has installed an experimental cabled buoy just offshore the Sciara del Fuoco. You see in the picture, that is the flank of the volcano where most tsunamis are generated. At the moment, this new type of monitoring system is working well and sending data to our monitoring center. Also, other efforts to improve the forecasting for volcanoes, for volcanic tsunamis, are ongoing in the other Aeolian island around Stromboli, like this one in Panarea. You see the Stromboli volcano here in the background, and you see here the elastic beacon where a pressure sensor has been installed in this July. They are working well at the moment. In this case, this is an observatory, multidisciplinary observatory to monitor volcanic activity, geothermal activity, and in shallow waters in this case, and we could instrument these observatories with new instruments. So I think I will stop here, and I thank you for your attention and for the invitation, and I wish you a good, very good afternoon.
So thank you very much, everyone, and special thanks to Professor Tanioka. But you keep sitting. I would like to call on Alexander Ravinovich to come on like surprise. Because it's not predictable, right? So I would like to invite you to hand over memento to Professor Haneuka.
Okay. And I believe that I should say something about my friend. So, actually, Tanioka-san is my boss. And that is why I cannot say anything bad about it. He is the chair of the Tsunami Commission, and he would certainly know that the Tsunami Commission is the most important commission in the world. And just because Tanioka-san of this commission, you can imagine how important is Tanioka-san. And I'm very proud to be his friend for many years. And it is actually my pleasure to cooperate with Tanioka-san. And it is my pleasure, and at the same time, it is my honor. So I would like now to give this. Thank you very much.
Thank you very much. So I just want to say thank you to Alessandro Amato also for the presentation online. Maybe he's watching us on stream. Now we move on to the second part of the session 1. There are 6 presentations left. So I would like to invite Professor Johan Jose to come forward. So just to give a small introduction about Professor Johan Jose, he's a professor of marine geophysics at the Spanish National Research Council. He is a distinguished marine geophysicist based in Spain and an internationally recognized expert in ocean floor observations, geohazards, and tsunami risk science, and a former Director General of EMSO ERIC, European Multidisciplinary Seafloor and Water Column Observatory. He has led major international initiatives on deep ocean observatories, geohazard monitoring, and tsunami risk reduction. Thank you. Please come forward to moderate the next part of session 1 with 6 presentations, and I hope we keep track also on the discussion for reporting. Thank you.
So, good afternoon. Thank you very much for your nice words. According to what Dennis told me, we're going to be very strict now. 12 minutes, 3 minutes, if not, no questions. We don't follow your rules anymore. Sorry about that. Okay, well, as Dennis was saying, we have 6 topics continuing this high-level objective. We have 3 regarding the observation, which is part 2, which is interesting, always to have observation. Then another one concerning forecasting and warning. I will introduce one by one. Then something related with the tools or technical development. Is a software development for early development of compressive tsunami software. And finally, which is the last part of the session, is to service provided by IPOS ERIC. So I'm going to ask for the first talk, which is called BOM, Sea Level Observation and Monitoring by Joel Long Mayo. you have the floor. Thank you very much. 12 minutes, as much as you can fix it, better.
Yeah, thanks very much, Chair. So I'm going to talk a little bit about how we, at the Joint Australian Tsunami Warning Center, how we integrate, make use of sea level monitoring in the tsunami early warning system, operation. Yeah, just a little bit background information. JTWC is a joint partnership between Geoscience Australia and the Bureau of Meteorology to recognize their respective expertise. Australia does the earthquake detection, and the Bureau of Meteorology is very good at weather forecasting and warnings. So we combine with that government sponsored kind of initiative. So so the way it works is it's obviously 24/7 all year round, and so Geoscience Australia will detect and analyze seismic information, and then once they get an estimate, and once they think that that earthquake might have tsunami-genic potential, which is normally magnitude 6.5 and above in undersea, and then it'll send the message to us and to the Bureau, which is not only but also a video link, and that is almost like in the same room that you talk to each other. And then the Bureau of Meteorology then do the assessment of tsunami potential to Australian with the MOST model as the pre-computed database. And then we issue advice to Australian, either no threat to Australian or there's threat, which is a watch. And then after that, we'll do the monitoring of utilizing the available sea level network and to decide whether to adjust warning or not. And obviously, we all know that JTWC is also one of the 3 regional service providers for the Indian Ocean tsunami warning system. And so we also provide live threat information to national warning centers, tsunami warning centers in the Indian Ocean. So just a quick overview of the quick process. Starts and detection happens obviously within minutes by Geoscience Australia, and then they will send the solution to the Bureau, and upon receiving that, we'll make assessment and decide whether to issue a warning or no threat to Australia. So the target is around 30 minutes. That's because we are not a near threat Australian. So the closest one to us is 2 hours away. So we can afford to wait until 30 minutes. But we tend to be doing much better than that. So normally on average it's around 13 to 14 minutes. And then obviously as Bill said, we're not sure at that time. So the initial one is always an estimate. And so we have to rely heavily on the sea level network to monitor whether tsunami has been generated and how big it is. So so based on that, we will either, we'll try with if there is a real tsunami threat, or the threat is within, we will upgrade that warning. And then this warning will be repeated every hourly until the sea level network suggests that threat is gone. And that's, so then we will cancel. So there are 2 levels of a warning. So one is a marine threat, which means it's, the tsunami is capable of dangerous rips, ocean currents, and so people in the water could be subject to, a major issue, and small boats could be affected. So yeah, people need to just get out of water for that. But next level is obviously a major one, land threat. Land threat is when not only it's dangerous in the water, and but also, yeah, the low-lying coastal areas could be inundated. So our advice is to move inland at least 1 kilometer or go to high ground at least 10 meters. So yeah, just talk a little bit about the sea level network that Australian supports. And if you look at the map, you will see that we cover both the coastal and the deep ocean ones around Australia, but also in 14 Southwest Pacific countries. So there are 44 tidal gauges altogether. Those are colored as green, those are green triangles. Yeah. So yes. So those stations were there a long time ago. And 5 pretty much used for climate monitoring purpose, just for sea level rise and the monitoring. And it's part of the Australian aid project to the Pacific. So yeah, so it's been there since 1991, and but the data are not transmitted live. So following that 2004 Indian Ocean tsunami, so the government put in a $69 million project to set up the advanced Australian tsunami warning system, and one of that is to fastly creating the real-time data communication facility, and each station need to have a dual communication channels, so that creating redundancy. So yeah, and also during that process, some additional stations are added to it, which is less than climate monitoring quality, but it's good enough for tsunami. So yeah, and in addition, 6 dart buoys, deep ocean dart buoys being placed. That was as a result of this project. And they paired in, they put in the pairs, like 2 in the Indian Ocean, 2 in the Coral Sea, 2 in the Tasman Sea, next to the fault line. And they deliberately try to capture the tsunami as earliest as possible before it reach Australia. So they're built for redundancy purpose. And so what's not showing on the map is many third-party data that we also have access to. They're not really shared internationally, but these data, what we got here, are all shared internationally. That's operated by Bureau of Meteorology. The third-party data are run by many emergency services, hydrographical offices, and the storm surge lab, etc. So there are many more than what we are seeing on this screen. And obviously, when it comes to operation, we cannot just rely on just the Australian operated network, and our network feed into the global network. And as you can see, many data are available, freely shared by GTS, by FTP. But you can tell there are, some areas have more data than the others. So that's to do with the data sharing or lack of. So this particular website is heavily used. This is IOC owned one, hosted ones, and so it's highly valued and heavily, but at times it suffers from a traffic jam. And this NDBC website has a specific buoy data, live data, including dart buoys. And you can tell that, so not all that dart buoys are operating. So the red means they're not operating at the time of this particular snapshot. So, and on the right-hand side, you can see that Australia has 6 dart buoys strategically placed in 3 ocean basins, 3 ocean areas. And then thankfully New Zealand come on board since the 2016 Kokara event that was undetected. So the government putting a lot of emphasis, investing in the Southwest Pacific and also to its east and the north. And so they actually put in 12 data buoys, which really heavily helped the detection in that part of the world. And internally, we also developed our own sea level viewer, just so that it's more reliable, quicker to access data, because that is the key, that we got to be quick and accessing without any traffic jam. And but it's not every data. It's essentially it's all the data buoys, plus our own managed coastal sea level data. And some study has been done. I know as Professor Alexander in there, so I'm a bit nervous about talking about this. Some study has been done just in terms of which coastal tidal gauge is more quality and or could be subject to any impact by various things. So the study by our bureau colleague Jane Wang in 2009, quoting the Alexander's work, is looking at the impact by, of the wave signal is actually not made equal. So it could be subject to continental shelf. So any can be either amplified or dampened or just neutral, depending on where tidal gauge is. And so you can tell that if it's subject to a big, long continental shelf, and then there will be huge dampening of the signal. And if it's if it's near the entrance, in the closed or open, so in the closed one it can be it can be noisy, but it's in the seashore and whatever all the resonance effect could amplify the signal, and and also the size of a bay, etc. Yep. So yeah, so so when the event comes, when we look at observation, we will be looking at data on its own merit. So decide whether it's actually true reflection of the impact, and and some stations can be used as an early warning or just a verification because it's too late by that time. We can only just assess the impact. This is the second last slide, and the data buoys is also used to adjust our warning strategy, and so in the absence of the real-time modeling, which is and also inverse method that Bill talking about, we can't make use of a model observation in the forecasting adjustment. But what we can do is to call this envelope method. It's a very crude way of assessing. If given an observation of a dot anywhere in the world, we are able to assess whether that dot translate into equivalent earthquake magnitude. So for that, some of those two slides is showing that depending on the depending on the observation, and we can tell whether this is underestimate or overestimate of the tsunami impact to us. And yeah, so just the last slide. So as I said, we need more and better monitoring. But the traditional coastal and the data buoy networks are still our backbone, and for the regional and the national global tsunami warning system. And sustaining that financially is very costly and challenging, and even harder to expand. But that's what I'm saying. We needed more data sharing. We needed more third-party data. And we should also embrace new emerging technologies to lessen the pressure on the existing network, but also fill gaps identified, and also to meet the new challenges with non-seismic tsunami. So thank you much for that.
Thank you very much for this useful information. There is time for only one question. No questions?
I have. Okay. But not
You have 30 seconds for the question.
Do you have access to other sources of the data? I mean, because Bureau of Meteorology is not the only source. And my second question, what is the situation for the Antarctic coast? And third, islands, like Norfolk, Lord Howe, or what?
Yep. So the current situation in Antarctic, we do have a few stations there, and as you know, that Australian is one of those many countries that has a base station there, and so we actually do have a tidal gauge there. But even us don't have it directly yet, so that's something we are working on. But we do have a Norfolk and Lord Howe Islands, offshore islands, which have observation there. But there are also many third-party data that we also have access to. So yeah, what I showed is what Bureau operates, but there are many other operators that in the future we want to integrate and make it universally accessible by anyone, by storm surge people, by tropical cyclone people. So that's, and by flood people. So flood operation is important.
Thank you very much, Yolong.
Yeah.
Thank you for your talk. Well, our next speaker is, the title is Monitoring High Frequency Sea Level Fluctuation in Coastal Regions of Ukraine, Alexander Matijin. The floor is yours. More questions, eh? Good for you.
To change slides, this one, sir, and for pointer, this one. Okay, yes. Australia, bigger or less Ukraine? Bigger, so Australian bigger or less Ukraine? Usually in scientific problem, okay. But Australian maybe attacks from tsunami, but Ukraine no. Dear colleagues, I'd like to present you attention a short message about the current status and prospects of sea level and atmospheric monitoring in Ukraine, which are essential for studying and predicting the impact of tsunamis. Tsunamis and meteor tsunamis are relatively rare in Black Sea. Meteor tsunamis have been recorded 3 times in Black Sea and Azov Sea over past. Okay. Thank you. Thank you. Thank you. Okay. Then, meteor tsunamis have been recorded 3 times in Black and Azov Seas over the past 20 years. Hydrometeorological service need to conduct appropriate observations to assess the impact of tsunamis on coastal infrastructure. These observations should ensure a high-quality recording of sea level fluctuation parameters. Meteor tsunamis studied should also include recording certain meteorological parameters. In accordance with the frequencies of meteor tsunamis, wave oscillation, it's necessary to record sea and atmospheric parameter with following resolution. Okay, you see. Mediterranean regions where meteor tsunamis may occur are highlighted in red. The areas of Black and Azov Seas where meteor tsunamis were observed, as well the maximum heights of meteor tsunamis waves. As we see, maximum wave height is more than 3 meters. Then, Ukraine have 6 hydrometeorological station on the Ukrainian coast of the northwestern Black Sea. Only 2 of them are equipped with tide gauges. But the meteorological equipment can record changes in atmospheric pressure and width with a resolution of 3 seconds. The location of hydrometeorological station allows for the recording of localized meteo tsunami waves along almost the entire coast. Currently, Ukraine lacks the capacity to fully implement a marine environmental monitoring system. Also, atmospheric processes are monitored fairly comprehensively, with the exception of aerological observation due to military actions. We'd like to make use of Horvatia experience. Meteo tsunamis occur quite frequently in this country. Assistance to Ukraine could be provided through the European Twinning and Euro4GRI programs. Therefore, the Ukrainian Hydrometeorological Service assumes to use 6 radar stations for measure high-frequency sea level fluctuation. Ukraine will establish the sea level fluctuation monitoring system to obtain information on processes in the tsunami frequency range. I hope it in the nearest 3 years. Thank you for the station.
Thank you. Thank you very much. Excellent in time, wonderful, better than ever. So
Okay.
we have time for a few questions.
Развивайте.
Thanks, stay here. Don't move.
Military, да. Okay.
Yeah, thanks for the presentation. Just my comment. This is the first time I heard this word being used. As you probably know that between WMO and IOC, this has been sensitive issue in terms of talking about the terminology to be used. So I just want to make you aware that in the WMO world, and they prefer not to be called this. Instead, it's something to the effect of weather-driven, weather-created, weather-generated long-wave disturbances. I know it's a mouthful, but this is to avoid the confusion of the tsunami. This one is generated by weather, and the weather, it's getting the similar impact to the coast. So it's more in the scope of responsibility of WMO. So that to predict it, you need a weather forecasting, you need a pressure monitoring, you need a sea level, obviously, but it is well within the Met Services responsibility. But where we can help is the monitoring, detection, monitoring side. Yeah.
Certainly, we have numerical model, Delft 3D, flow plus SWAN. That forecast the sea level. Good. То есть, sea level, we have forecast for sea level. Good for them. Essentially, we have model. We have model for forecasting weather for sea level.
He was complaining about the name. Eh? About the name. I mean the wave.
Not complaining.
Not complaining. Regulation.
Just be careful that this is now become two UN agencies agreed
No,
not
but
to use this technology.
at the end, your tsunamis is coming from up, and his tsunamis is coming from the sources from deep. Meteo tsunami. Thank you very much. Any other question?
A little comment. Actually, we have like two main types of meteor tsunamis. I call them good weather and bad weather meteor tsunamis. And bad weather, it is quite natural to predict, to forecast, because you can do. But for good weather, for example, for the Mediterranean region, it is, and also for British Columbia, it is quite common to have meteor tsunamis during very beautiful weather, high pressure. And then there is a strong train of atmospheric gravity waves, some local resonant effect. We have, like in Croatia or in Spain, up to 6 meters. Not related to hurricane, not related to typhoon, not related even to Willy Willy.
Maybe we need to talk about that.
Okay, thank you very much. We go to the next speaker, and we go to the source of the tsunamis, again, back. Tsunami detection on standard telecom cables. Mikhail Masur, the floor is yours. Mikhail, you know the story, no? 12 minutes. The shorter, the better.
Thank you very much for the introduction. I'll try to stay on time. So I'm Mikhail, and also like to thank the organizers for putting together this wonderful event. So as kind of given by the big logo, I work in industry. I work for a company who makes telecommunication equipment, but I'm in the research division, where I do a lot of work on submarine cables. So why are we here? Well, we are clearly interested in the topic of detecting and tracking tsunamis and how we can use submarine cables for this. And today, although, oh yeah, now we have nice formatting here. Apologize for that. There's basically 3 ways we can do that. We can use dedicated cable-based observatories, which are expensive, but these are of course the best things we have. Things like the SNet, famous. We had a great talk about smart cable, so I won't say a lot about that, more than the fact that it's very exciting that these things are soon coming in the water. And then we have fiber sensing, which is basically an attempt to try to use the existing telecommunication network for environmental monitoring. So what do I mean with that? So basically today there is a little bit over, we just crossed 1.5 million kilometers globally deployed telecommunication fibers. So this is the internet. It carries 99.99, something like that, % of all the traffic. It enables meetings like this to be streamed on YouTube, which I was very happy to see. And our mission is, of course, as we build out this infrastructure, which is happening rapidly at the moment, what can we do to also make use of it for things like early warning applications? And again, now all the slides look messed up, but how do we do this? So in this case, we're talking about existing cables and future cables, meaning that things like smart and dedicated observatories is not available to us because we actually cannot change the cable while we put it in, after we put it in the water and it's down on the ocean floor. And the work I will be showing you today is really using cables that are 25 years old. So basically looking at technologies that we can rapidly deploy leveraging this network. And today it's very, very close to 600 cables out there if you look worldwide. Why does it work? And we won't be technical, so let's just say that if you want to detect a tsunami on a regular telecommunication cable, what happens is that the change in water height basically changes the pressure on the ocean floor. That's why we use ocean bottom pressure gauges. But it also means that there's a small, small length change to any optical glass fiber present on the ocean floor. And if we can monitor this length change, we should be able to see, to detect the wave. And that was done recently. So this is a beautiful figure by Jamstech. It was published last year. I think they have really been leading the way in trying to show this and looking at how they can use fiber sensing to complement their existing infrastructure, both the DONET and the SNET. And we are kind of trying to follow the same line and say, okay, can we use the telecom grid to take this even further? So what DAS enables you to do, and we heard it being mentioned many, many times here, is really that it gives you a very high spatial resolution strain rate monitoring along a submarine cable. It has been shown again to detect the tsunami nearshore, but it has this problem that you can only go up until the first repeater. And the reason why I'm here today is to talk about the results of how we try to extend this beyond the first repeater. So that's a great tool, but again, we're trying to overcome this reach limitation to push it out further and further offshore. So a brief look at the experiment we had running when we were, which basically was a submarine cable around the world now, trying to do long reach fiber sensing, or basically flipped around. We're trying to extend the reach of distributed acoustic sensing to the ocean basin. It was running during the magnitude 8.8 Kamchatka earthquake. For this community, there's not a lot to say to it, but this is when things becomes interesting. So if we look at DAS, it looked something like this, and we detected it, the seismic waves, tsunami waves, and several groups around the world caught it on DAS. So it was actually a pretty great event for the general DAS community. But you can see I put in this arrow for the DAS reach limitation. So this is the first optical repeater present in the cable, so 1 out of about 101 repeaters, and it happened to be 4 kilometers away from land. Technically 43, because it's about a kilometer of fiber on land before you actually go down in the ocean floor. So again, it's great. It really is an amazing technology, but it doesn't really fulfill the need we have in terms of early warning, in terms of understanding the system, because it's just too close to land. And this, of course, holds true for other applications we're interested in as well, such as general seismic monitoring or environmental monitoring. But it turns out that this reach limitation, or so-called thought of reach limitation, is actually not fundamental. And you can expand this. So this is what it looks like if you push over the entire cable length. So in this case, again, it was 4,400 kilometers. It had 101, I think, submerged optical repeaters. And you're now looking at DAS going not only to the first repeater, but going the entire way from California to Hawaii. So 0 in this case is California, and Hawaii is 4,400 kilometers away. And it does this while maintaining a spatial resolution of 100 meters. So again, we're interested in technologies that can complement existing sensors. And I think the reason we generally, and the community generally, is interested in fiber sensing is to provide a complement that can achieve very, very high sensor density. There's a lot of other challenges with it compared to standard multi-component instruments, but on the upside of it, it's really that we can have high sensor density. And in this case, we had 100-meter spatial resolution along this cable. So it's something like 44 plus 1,000 measurement points. The cable, again, connected California and Hawaii, and in this case, we're a little bit lucky. I don't know if this will run. Maybe it will, maybe not. We can try. So this is a sped-up version of the NOAA MOST model that we have from them. Just to show we actually had a great test case in this case because we had a very clean wave propagating on top of our cable. And of course, because people we had a sensor, the first thing that happened when our phone starts getting text messages was, did you detect a tsunami? And it turns out that if you run an animation, the slides stop working. We actually were able to provide quite some insights. So starting off, here is the NOAA. On top of it, you see our cable. And you see coastal pressure gauges present in California and Hawaii. So basically the only 2 observation points that we had along the cable. And it really also, I think, highlights what we're trying to do here. We're by no means trying to replace any of the sensors out there. We're trying to answer the question saying, there are 600 cables out there today. We have more and more advanced cable technology coming in the future. How can we use the telecom grid to kind of fill the gaps and interpolate the results on a larger scale? So this doesn't work. But here is an example. So the graph you're seeing on top is from the DART. And below you see, maybe not, a result that we covered from the cable. So again, it's a standard telecommunication cable. We're 500 kilometers offshore Hawaii, down in the deep ocean. And on top, you see kind of the overall frequency spectrum going from 100 microhertz up to 1 hertz. So you can see strong seismic energy in the beginning, but you can also see, let's take this away, the kind of nicely recorded tsunami wave occurring somewhat like 5.5 hours later. It's a pretty the energy is of course significantly weaker than seismic waves, but it's clear. It's also a good cable because generally in deep water. Pretty quiet down there. There are no events. But we can actually start tracking. So what you see here to the left is the first point along the cable that is 15 kilometers out. Basically in shallow waters, very close to land. It's in a very nice environment. You can still see it. It's a little bit weaker. It also shows up 500 kilometers offshore, 1,000, 1,500, and all of this kind of shows the same very nice dispersion curve. It keeps going, and we're now 2,000, 2,500 kilometers offshore. It's a little bit for us right now to compare it and work with. We're trying with the model tool. It would have been great if any other sensors out, but we don't. So again, it's an example of how we try to use the cables to understand it and see how we can complement the existing systems. Basically, all along the cable, from the beginning to the end, we see the same story. There's a very strong seismic event, of course, but a few hours later, the tsunami shows up, and we can actually track it. If you lay them out, it looks something like this. So we haven't found any other reference, at least, who could do this, but this is basically tracking the tsunami trajectory as it crossed along our cable. We do this in real time, so of course, to make a figure like this, you have to wait a while, but the overall latency in terms of second to get the information from all sensor points along the entire cable. And it's a small part, right around 3,000 kilometers, where there is a small sea mountain, so the quality there is not as good. That's why the line is missing. And that's, of course, also a benefit, just highlighting it with a it's nice to have very high sensor density, because it means that if we have some area where the cable is poorly coupled, or there's a lot of other activities, collect that without any bigger implications for our tracking capability. In the interest of time, let's try to give 1 minutes back. Let's wrap this up and say the reason for giving this talk is to say a few things. The first is that we are not saying for the first time that we can detect tsunamis and distributed acoustic sensing. This has been pioneered by others. But what we're trying to say is that the reach limitation of distributed acoustic sensing that was highlighted in a few talks here being used on the first pass is actually not true. You can extend this to use the same technology along the entire cable. We believe that this opens up a lot of possibilities, especially because DAS, if engineered the proper way, is compatible with telecommunication and all the 600 cables installed today. So the template is messed up, but you can basically, I think, just look at this figure to the lower right and say that this is actually us in real time being able to track the wave as it moves over the ocean floor. And give or take on it, the cable overall had something like 100 to 200 solid measurement points that we worked with. I think that's it. Thank you.
Fantastic, Mikael. Thank you very much. Very interesting. We have time for a couple of questions.
Oh.
When you use the DAS, the problem is that amplitude is not calculated well. So what do you think about that?
So that's true. In our case, we have to calibrate it. So we have long-term observations over the cable, and we calibrate it with other sensors before. So we have a pretty solid like pressure to strain conversion, because we measure strain and we want pressure. So we can calibrate that because it varies along the cable.
So you have a, they have a calibration at that point.
Yeah.
But is that possible to go in the land?
It looks like it's possible. I mean, using things like tides and so on. Of course, and I think that's really where the complementary nature comes in. Like, it's not natively calibrated because it's a strain. It's not a pressure sensor. But because you have a lot of observations over time, it seems that it's possible to calibrate it pretty well. I think it's also the question about, I mean, the goal here is really to enable high-density tracking with respect to other sensors. So if you have a couple of solid references that you trust, for example, in the Kamchatka case, I mean, there was one dart buoy that captured it initially. So if you would take that and kind of constrain the problem, I think you have a fairly high chance of doing it. And I think Jamstack have been showing their approach is really to build the density between other sensors, and I think this is a similar approach.
Thank you for a fascinating presentation. And really interesting that it's compatible with all installed submarine cables. My question is on costs. So how much is the cost of retrofitting an existing cable with a sensor compared to the additional cost of adding sensors to newly deployed cables?
that's an excellent question, and I should be careful now commenting. I mean, we know that adding...
Sorry. Seeing it's an excellent question, part B, who funded this? If you're able to tell us. Thank you.
Who funded it? So we have worked on it for a while, and Bell Labs is mainly funded by Nokia. It's our internal research branch. So the work we have been doing last few years is coming out of Nokia. Together with, there are some partners here that have fundings from their own. The cost is always hard to say, right? What I think we can say is we know that each sensor you put out is something like $1 million. If you have a single DAS unit today, which is the same kind of technology that we do use, those are something like $100,000 to $200,000. I think it's fair to say that a single sensor like this that gives you all the points along would be less than one sensor that you would put dedicated on a cable. Now, the second question of that is there is a cost which is also associated with the fact that you lose bandwidth of a telecommunication cable. And this one doesn't lose bandwidth. So you can use the full bandwidth available for telecom. And that cost is probably something like 40 to 50 million US dollars for a new cable. So I think exactly the cost of the sensor is going to be marginal compared to the cost that you would have to pay in terms of lost bandwidth of the cable. Is that an okay answer maybe to, we don't know exactly what it would cost, and yeah.
Thank you very much. I think we stop here. Well, no, one question. Go ahead.
My question was similar to Tanioka-sensei. So I'm just wondering if the accuracy of the observation, have you compared with that waveform and your waveform observed by DAS?
Yeah, so that's great. So we're working on that right now. In the there is a dart buoy that is not too far away from the California side. So we're working on comparing to that one, and it looks, I think, pretty good. There's also some other features occurring, like between the tsunami wave and the earthquake that we thought was a measurement error that showed up on the dart. So we're trying to figure out what all of those are right now. I think inherently any fiber sensing system will require some calibration. And this goes for this one, it goes for DAS, it goes for everything else. So it's not a sensor I would trust as your one data point to put out the wave height on. That's not also what we're trying to do. So it looks like you're calibrated pretty well. It seems, looking at the noise floors and so on, that it's stable over time, which was surprising to us. But it looks like it actually holds its, looking over months now, it seems stable. So then again, I mean, you have to, the trick here is you have to pick your cable segments. If you take a segment where the cable is loosely coupled, the amplitudes are all over the place. So you kind of have to calibrate it, but you also have to pick a segment of the cable that is actually suitable to use. And in this case, because we're looking down to microhertz, right, it has to be incredibly stable. So something quiet on the ocean floor is suitable.
Thank you, Mikael. We stop here for a coffee break, a short coffee break, by the way. No? One more presentation, and then we go. Well, next presentation, we change the subject a little bit. We go for forecasting and warning, and it is global real-time early alarm for tsunami. Usama Kadri, the floor is yours.
Yeah, thank you.
12 minutes.
Yeah.
Reducing.
Actually, can I just ask, can I use this? Yeah, all right, yeah. Well, now I got the microphone, sorry. All right, thank you, everyone. Thanks for the invitation as well. I'm going to start with a very brief introduction about the philosophy behind the technology, and then move to the main challenge, one of the main challenges that we have with finding real-time hydroacoustic data, and then some recent activities where we try to mitigate that challenge. So the tsunami generation, the basic philosophy behind it is very, very simple. In order to generate a tsunami, you need to have displacement of the water layer. And that displacement means that you have a vertical motion. That vertical motion compresses the water layer. As a result, it generates also these compression waves, which we also call acoustic gravity waves. And this is true regardless to the source of the tsunami generation, right? And this is part of the advantages maybe of using hydroacoustic data in that regards. Now I'm going to talk in a symposium more technical details about the INCOIS, but for the sake of this talk, I'm going to carry on with research activities. So the idea here is that when we have a tsunami generator, we have an event, acoustic gravity waves would travel at the speed of sound, which is traveling much faster than the tsunami itself. And they would carry information about the source. And once they reach to the hydrophone, then we want in real time to find out that information. And in order to do this, we've been developing for more than a decade now, we've been developing mathematical models mainly for the sake of fast calculations, inverse problem models, forward models, as well as machine learning, first, second, and third generation now. Our approach is complementary, so we would like to, as an input, to have as many different sensors as possible, but our main sensor is really the hydrophones. A few years ago, we put everything, all these modules together, and we created a software which we also call GREAT. And the main feature of it is that it can detect the tsunami, it would analyze it, and also disseminate in real time. And by real time and end-to-end analysis, we talk about 8 minutes. That's the capability, given that we have a hydrophone that provides data in real time, which is located within 1,000 kilometers in distance, all right? So the data that we get is from the CTBTO through ITMA, but more recently, actually, we have a direct channel for getting also the data. So from Cardiff University, we can, using these data, we can assess the tsunamis globally. But you can see one problem is, if you look at these triangles there, we have 4 blue triangles. This is basically the only 4 stations that we have access to in real time. In a good day, when we actually have that access streaming and not failing to do some. So how do we mitigate that? So we would like to have a network of, this is the illustration of if you wanted to have within 1,000 kilometers, right? It doesn't have to be really 1,000 kilometers, but if you want to have within 1,000 kilometers, hydrophone station from all the high-risk areas around the world, then this is more or less the type of network that you would be looking at, around 30 hydrophone stations, to have a global assessment of tsunami using hydrophones. But we don't have that. We only have 4 out of these. And the question is, what do we do in order to move forward with that? And here I'm going to just emphasize a few activities that were going on recently to push things forward. I think one of the main activity was the ICG steering meeting in Jakarta in June, which I found very, very successful. And it was opening channels. It was very productive from my perspective, which was also followed by a working group after 2 months, which also I found very efficient. And the idea is to push forwards with utilizing all kind of technologies, among which also acoustic data. Another important activity was the conference by CTBTO, the Comprehensive Nuclear Test Ban Treaty Organization, which basically we get the data from there. I can highlight the UNESCO's IOC, led by Mr. Bernardo Arriaga, who had a panel there, and also I think a poster as well. And our group also, that we had 2 posters. And the idea was to disseminate how important the access for this data. And I've noticed through these years working with CTBTO that there is many steps forward from their side towards the community, which is good. There was also other opportunities, of course, in that meeting to work with new NDCs and other collaborations. But there was a birth of a new idea there. This is part of the poster that I presented there. It has to do with the Kamchatka event as we analyze it through the software. Now, of course, the hydrophone is very far away, so in real time it won't work. So one of the ideas that we came up with, until we fill the gaps, let's do this probabilistic approach using past data. I won't speak technically about that because this is not the topic here, but the main point is not this really. The main point is that I get approached by a colleague from Japan's weather agency, and he asked if we can actually analyze infrasound data. And that opened some new chapter in what we've been analyzing. So in fact, he was referring to this part, and he said that they notice this kind of behavior oscillation that is arguably related to the tsunami generation. And we were more interested in the first part because it's also is coming earlier. So the first question from our side is, would the software digest that kind of information, given that the sampling frequency, which is very important for us, is a much lower sampling frequency than the CTBTO data? So the answer is yes. I was surprised actually, but the answer is yes, that it was able to digest with not bad accuracy. So we started looking at other cases. The idea is, so this is the Kamchatka case. The idea is to now see how far we can push with the downsampling, right? Because we wanted to see if we could actually make use of infrasound, or maybe also other pressure gauges that that are available until we fill the gaps. But there's another problem also, that with infrasound, we actually need a different inverse model, right? Because the signals would travel in the earth, and it travel into the earth as well. So it's slightly, well, it's not slightly, it's a different model, right? So these are the two things that we needed to start focusing on. So with the downsampling, it was easy because we took all the data, lots of the data that we have from the CTBTO with 250 hertz, and we started downsampling that frequency and see if what you're looking here at are the main 4 properties of a fault, all right, an effective fault. So on the left corner, up left corner, there is the half width of the fault. And then you have half length of the fault. And this is the uplift speed, and this is the duration of the eruption. Very simple, okay? And you notice that for downsampling, for example, for the half width, it doesn't really matter a lot. But it does matter with the others. So the 20 hertz, for example, gives you lots of uncertainties also on the results, right? So we need to understand how much uncertainties these would include. And with the analytical model, the new analytical model which I started working on, and this is just to illustrate the Kamchatka case, new inverse model to account the elasticity of the ground and also all the propagation along the ground. These are some preliminary results that look promising, but we don't implement them yet into the software, right? We need some work to do before going there. But the point is that in this case, in the Kamchatka case, and you've probably seen that we've had of earthquakes in the past half a year or even more in that region, that would give an end-to-end analysis, right, giving the distance, a small distance there, that would give an end-to-end analysis of 2 minutes, which would be a good complementary tool. So on the left side, you see the hydroacoustic stations. On the right-hand side, you see the advantage of using the infrasound stations as well, right? There's about 60 stations there. So just to really, I'm concluding with talking a little bit about the projects that we're currently working on. So we continue the work with developing the new models. There's one project that has to do with the volcanic sources, the Meteor Tsunami, and there is a work that is especially dedicated to hydroacoustic deployment, and this is in collaboration with Met Malaysia and UPM and University of Maryland. And very recently, there's a few large grants. Hopefully, if we get something, then that would open the door also for new collaborations, also with JWA, BMKG, and INCOIS. Just last thing, if you're interested, if you're a tsunami provider in the Tsunami community and you'd like to receive the alarms from the email, from the software, then you can just scan this. If you're not from this one of the TSPs or from the, at this point we would not be able to share that until it becomes more accessible. Thank you.
Thank you. We have time for a couple of questions. Nobody? I have a question for you. When you talk about the infrasound, you talk about you need to know the elasticity of the path. This means you need to know the whole structure of the crust. So how, I don't see the advantage. I mean, how you know? I mean, you don't know the elasticity of the whole crust for such a long distance. If I understood well, I don't know what you mean by elasticity then.
So, okay, so right now, I can. So right now, what we have, the inverse model relies only on the water layer, right? On the hydroacoustic data, which means for the inverse model we consider the seafloor as rigid, right? Now in the Kamchatka case, for example, and one of the reasons why it actually worked, because most of the propagation was in the water. So the correction that we need for the inverse model is for the phase velocity, right? Then the phase velocity, once these waves couple with the elastic layer, then they start propagating faster. As you start, as they start shoaling, or the water becomes shallower and shallower, they start going faster and faster from what is called a Scholte wave into a Rayleigh wave, right? Now you don't need a very refined understanding of the elasticity of the ground. We talk about hundreds of kilometers in wavelength, right? So you need to have some kind of approximation of the elasticity. You don't need to go also all the way inside, because these are they're propagating at the surface, right? So they're only at the surface of the seafloor that you need the information.
So now we're finished. We have a coffee break. Yes. And then we come back in how much?
15 minutes.
15 minutes.
50%, sorry.
Session 2,
all the today's everything.
No.
The other one is.
Now one thing you have to copy na.
Session 2.
Four. Okay. Now this all 3 also is there.
Everything will be whatever it is will be. You gave one presentation. Yes, session 2 and mine it will be here. Can I just check? Yeah, you check it. You can check. Thank you very much. Yeah, just so I make it quick. Yeah. Okay. Hopefully it works. Like this morning is nightmare. Okay, just show me where are. Oh, that's mine. Yeah. Okay. Yeah. I think it's slideshow. Usually it will change. Yeah. Oh, it's good. Yeah. Okay. Fine. Okay. Thank you very much. So you have your presentation?
Yes, I think next presenter.
Yeah.
My name is Baba, Toshitaka Baba.
Sorry. Yeah, I know.
No. Next. Oh, yeah, this.
Here.
Here.
Oh, for the tools. So
Yeah.
it's not finished yet, right?
Not yet.
Okay, Baba, and
So
then with Babeko.
Yeah.
Okay,
Let,
okay.
let me.
Yeah.
Let me
Dennis,
check.
He has not present yet. He's Baba.
Oh yeah, there are two presentations after.
Oh,
After the
after coffee
break, right?
Yes.
Okay,
Next
good.
week.
Yeah, okay.
Yeah, next.
Yeah,
Let me
okay.
check.
Yeah, good. Then I will handle.
Then you will handle after.
Yeah, okay. Yeah.
And when there is
Audio file. Video, that's okay, no video. It's okay. I just make it speed, yes.
Perfect. Thank you.
So it is download ICTP conferences sections, right? You didn't copy, okay. Nitin will do, na? Day one.
Till now, whatever all sessions is there, na? It
They
is there.
gave, I think they gave everything. If somebody is coming in between, we don't know. Everything is good.
Because by the time it's finished, even by the
Everything they copied in between. I think she only was denying. But if it is not also, I think this will be INCOIS system. It will be there in the system.
INCOIS.
So ask, did you brought it?
I don't
No. Always it will be here only, I think so.
Okay, so we can tell them also.
Yeah, not to delete.
The vendor, we can tell them also.
Eject.
Arrangement is the same. Chair is not changed. Same. Your next presentation, you keep it ready. Next presentation is ready. Just minimize and
One only continue. Development of now this one.
He only opened the last minimize.
What is the number, Kadri. After that,
This one. Toshitaka.
come.
Most
Yeah.
People have gentle voices.
Indeed, indeed. So this is challenging, you know, having afternoon, after meals, especially after lunch. Yeah, it's quite hard. That's why we need a coffee break. Yeah.
So you're based in Indonesia?
Yeah, I'm from Indonesia. Yeah. You are from?
Live in the UK, but
Oh, you are from UK?
yeah, but the project's based in Morocco.
In Morocco.
Yeah, but we
Back and forward.
we just work.
So which part of UK you are coming
In
from?
Wales, South Wales.
Oh, okay, in the Wales. Okay, yeah.
Near Swansea. So.
Okay, I have a lot of visiting UK very often for the collaboration, for instance. Yeah. It's very nice, but crazy weather.
Oh yeah.
For me.
Oh yeah.
Yeah. Sometimes summer is very cold. Yeah. Sorry.
I've been places where the locals will still use the cook.
Hello, everybody. We continue with the session. So now we go to the software development, and the next speaker is Toshitaka Baba, and he's going to talk about development of compressive Tsunami software. Floor is yours.
Thank you.
12 minutes plus minus
12,
one.
okay. So, thank you for being back from the coffee. I want to wait a little bit longer. Anyway, let's get started. My name is Toshitaka Baba. Okay, thank you. Okay, thank you. So I'm very honored to be presenting the talk. Thank you for inviting me. So we are developing a Tsunami software called JAGRUS for the contribution of the Ocean Decade program. So in this talk, we'd like to introduce our software. Okay, so this is the content of our talk. So I will briefly explain tsunami models embedded in our software, and we'd like to show some applications tsunami modeling. One of them is a dispersive outer tsunami. The other is far-field tsunamis. Okay, this is some overview of the tsunami modeling. So we know accurate tsunami modeling is done by three, for example, Navier-Stokes equations or Euler equations. After applying long wave approximation, we can get the two-dimensional shallow water equations. So that shallow water equations are categorized as four parts. One of them is a linear long wave equation. The other is a non-linear long wave equation, which is often used in the making tsunami hazard map. And also, sometimes we have to include a dispersive effect depending on the wavelength of the tsunami. So this is a slide of explaining the dispersive deformation. If we ignore dispersive effect, the tsunami propagate as it is, shown by blue. If we include dispersive effect, we would see the tsunami wave train like this, and the amplitude would change during propagation. This depends on that wavelengths of tsunami. If tsunami includes a short wavelengths, dispersive effect is significant. So our simulation software is called JAGRS, which solves that two-dimensional shallow water equation, including the dispersive one. And also, this is the most significant point of our software. That is the inclusion of the self-attraction and loading effect. We will explain later. And this model is one of the most accurate models for far-field predictions. The code is parallelized by OpenMP, MPI, and also cluster displacement module, calculation of the cluster displacement module, and generation filter, depending on the linear potential cell, also MP. So that the thing we have to prepare is just the fault parameter and the bathymetric data to simulate the tsunami using JAGRS. And also, this code is available on many computers based on the CPU computers. And the sources are fully open to the public to contribute tsunami disaster mitigations. This is a developers. This software uses a kernel developed by Professor Satake, who is one of the most famous tsunami scientists around the world. Australian team, Dr. Phil Cummins and David Babbage, improve the software for the nested grid algorithm. I joined the team to parallelize, and we asked some colleagues in Japan from Saito and Tsushima-san there, and also who provided me with the self-attracting loading effect. And also now we are going to include that two-layer model for the submarine landside simulation, and also GPU enablement like this. So now the source are already open to the public since 2015. That many scientists use that software, including from Philippines, Indonesia, and also Australia, and Peru, Chile, like that. Okay, this is a software we are going to develop. And next, I want to show some application of tsunami simulation. One of them is tsunami caused by outerize earthquake. So outerize earthquake often happened after a great interplate earthquake. This is a famous, one of the famous pair is from Japan Trench in 1896 and 1933 Showa Sanriku earthquake as well, something like that. And we have seen such kind of pair of the interplate earthquake, outerize earthquake in the Kurill Trench in 2006 and 2007. So after the 2011 Tohoku earthquake, we anticipated such kind of outerize earthquake that is normal faulting in the subducting plate. So in order to mitigate, in order to predict tsunami caused by submarine earthquake, outerize earthquake, we carried out many submarine surveys to identify the location of the fault. So I don't talk about much detail of the marine surveys, but we found some characteristic feature of the earthquake, such as that outer upper of the outerize fault is very shallow, and the dip angle is very steep, something like that. Based on this information, we calculated tsunami using JAGRS. So this is governing equations, equation of the motion. Blue is dispersive terms. This is a Bernoulli term, very simple one, and weak dispersive, a weak nonlinear model. And this is bottom equation is equation of continuity, and also we include the Kajiura filter to generation of the tsunami like this. Okay, let's look at the tsunami simulation results. So we compare with non-dispersive, dispersive equations, and then So we would see some differences between the non-dispersive dispersive equation, so that that means dispersive effect cannot be ignored. Also, we compare with tsunami simulation with the 3D simulation results like this. So that A, B, A, D, the left-hand side panel are conventional result, and the middle one is our simulation result. Third one is a 3D model. So that the 2D model, 3D model much similar. So the a combination of Euler filter and the business term is equivalent to 3D modeling. Okay, let's move on to the next topic of the far-field tsunami simulations. We calculated tsunami caused by 2011 Tohoku earthquake for the whole Pacific. So including a dispersion and the nonlinear term. And compare with observation data observed by that system, the near Hawaii, the upper panel, and the bottom panel near Chile. The black observation, letter the similar. The arrival time is different. And after the 2011 Tohoku earthquake and the 2010 Chile earthquake, that differences caused the big discussion. And Professor Watada in the Tokyo University proposed to include the elasticity of the Earth. Okay, so he in order to include the elasticity of the Earth, so we include the self-attraction and rolling effect. That is, it's called SAR effect. That means the additional tsunami load causes tiny deformation of the Earth. We include that the deformation equation of continuity xi here. After inclusion of the SAR effect, we can get the right-hand side panel. It's pretty much well between the observation and simulation. In terms of time, frequency, phase, all completely nice. So we're going to use this simulation software for the Kamchatka tsunami as well. This is done by Tsushima-san. Tsushima-san used the data to estimate the initial sea surface displacement and predict the tsunami at the 4 data stations in the Pacific Ocean. Okay, doesn't do. Okay, this is a comparison between the simulation of the simulation and observation. I repeat that these 5 stations were used in the source estimation and simulated the tsunami using dispersive and the SAR effect model. And the blue one and the green one like this. So this comparison is amazing, I think. So this is it doesn't work. Okay, this is the D32403 is located near Chile and completely reproduced due to the effect of the SAR and the dispersive effect like this. It doesn't work, actually. Okay, this is a comparison between the tsunami simulation and observation near the Japan dense ocean bottom pressure network. So the long time prediction, this compares the 72 hours tsunami simulations, and it's pretty nice. We can see some reflected wave on the Chilean coast around 48 to 54 hours later. Okay, let's wrap up my talk. So we are going to contribute the ocean decade, providing the tsunami software called JAGLUS, and which is, I think, pretty nice for modeling dispersive tsunamis. And then the important thing is that the inclusion of the self-attraction loading effect, and that is very important to produce far-field tsunami. And we are going to now on GPU enablement and the prediction application for the land-side tsunamis. That's all. Thank you.
Thank you very much. Excellent. If there's any question, couple of questions we can have. summer.
Yeah, thank you for the presentation. I have a comment actually on the arrival times of the tsunamis. So there are three factors that play a role here. One is the compressibility of the water,
Yep.
and the other one is the elasticity of the ground, and the last one is the gravitational potential in the
Yes, it
ground,
is.
which is
They are.
very small contribution. And so my question is with regards to your model, because I've seen that it's a Boussinesq type of 3D Boussinesq model, but that's an incompressible model, right? So how did you manage to get the correction without implementing the compressibility of the water?
Okay, actually, this model does not include, strictly speaking, compressibility of the water. Just includes the stratification of the density of the water. Okay, so I assume that some layered model in the seawater that includes this term and this term. So that strictly speaking, this is not seawater compressibility, just a change of the density along the vertical profiles in the sea layer.
So that is the gravitational potential in the...
Gravitational potential is included in that GZI here. So this is theoretically calculated by Japanese, Earth deformation, including the geoid deformation. So the gravitational potential change is included in the GZI here, in our model.
So for the elastic case, what kind of Lemay parameters did you use for the elastic model? How
Okay, we assume the PREM model. PREM is a preliminary Earth structure model. And then that model provided us a green function of the deformation of the Earth. We superimposing green function to obtain the GRI.
Yeah, thank you. Yeah.
Okay, thank you very much. I think we go to the last talk of the session.
Thank you.
Thank you very well. And the next talk is IPOS Thematic Core Service by Andrei Babeiko. Floor is yours.
Could you please put the presentation on there? So, I will talk now short about IPOS thematic core services at Tsunami, and you will see on the next slide what means IPOS. So this abbreviation stands for the European Plate Observing System, and IPOS is Europe-centered. It's so-called ERIC, and ERIC is in Europe is established legal entities, and this is means infrastructure, European Research Infrastructure Consortium. So it's basically a legal entity, and there are many of them, like in different fields of science. And the IPOS, European Plate Observing System, is the only one which is dealing with the solid Earth. So it's basically our home there in Europe. And ERICs are being funded by the member states, so these are countries, and 26 countries are being involved in the IPOS, so it's a big beast, and 26 countries, and the data come and the services come from the institutions like universities or like GFZ, like my institution, and you see there is 172 different organizations which are delivering their data, and like more than 500 data and service providers. And the important point is what is also staying here are communities. So the member states, they provide membership fees in order to run this distributed research infrastructure, whose the main goal is to provide scientific services. And the services are like access to data products, software, and services. And this access should be according to the FAIR principles. It should be integrated, harmonized, and that's why how EPOS is working. So the communities, currently there are 10, seismology, near-field observatories, GNS, volcanoes, satellite data, geomagnetic, anthropogenic hazard, geological information, multi-scale laboratories, and tsunamis. Tsunamis are the last because we are very young. We just entered EPOS as a community last year, so we're only 1 year old in that respect. And just want to show you again the structure. So the assets, which are data or data products or software, they've been generated in the research institutions, in the groups, in the scientific groups, or by individual researchers. Then these researchers, they kind of come together and make a union, a consortium, which are topic-oriented, like tsunamis, like, and then this consortia, they are a part of the thematic core services of the big EPOS, and we come with our resources to EPOS IT people, and they help us to provide, to disseminate, to provide access to our resources in a coherent, homogeneous, integrated way. So now I come into our community, Tsunami. So it's kind of fact sheet where young community, we just were established in last year. Now we have 18 partners from 11 countries. So we are young, but we're a big community. I think we're number 2 or 3, like a large community in EPOS. So we now we already deliver more than 40 services. GFZ is now playing a role as a coordinator of the community. Our annual budget for integration of the services for the governments of the community is approximately 200,000. We already enlarged, so 2 new communities joined us in this year, and another one will be in the next year. And that's why I shown you also this governance diagram, not because to show that we're very structured and democratic, it's also too, but also because our interest as a community is not only to provide services. Okay, we use EPOS to provide services, but our interest of many of us is just like to have a platform to build a community and to work as a community team, because we used to come together during the big collaborative projects, like it was like in the past after Sumatra earthquake or after Tohoku earthquake, but that is not always the case. So we thought that we need kind of a platform in order to be together, to work together like in Europe, and we decided that, okay, we can use this EPOS possibility as a platform of working together. That's why we also have a think tanks where we basically sit and we think about what are the directions for the next, where should we go next. We also have a think tank, for example, on the tsunami service providers group, so they have also possibility to work with us and also to exchange their ideas with the whole community. And we also have many functions in the executive board, so basically it's a daily work. So EPOS gives us a possibility to interwork, to interchange almost on a daily basis. So that's for me the most value for us at the Tsunami community in Europe. Now to the services. Basically, we are divided into the 4 pillars. Like pillar 1 is support to tsunami service providers. Pillar 2 is tsunami data. It's experimental data, experimental facilities, but also historical data like paleo tsunami catalogs and so on. Since we are mostly numerically driven community, we have a special pillar for the models. And the final are our hazard and risk projects. And yes, and exactly, if we are together now thinking about what are the high-level objectives and what are relations, that definitely objective number 1, it's about pillar 1, and objective number 2, it's about the pillar number 4, which is hazard and risk products. So what we do, we provide the products and data which serve to help to reach the objectives 1 and 2. Distribution two ways of distribution. The first way, we use the IPOS data portal. It's the main portal of the whole IPOS, which has all the communities, and you can see that all the communities are here, like seismology, GNSS, and also we as Tsunami with our 25 assets distributed in a homogeneous way. One example is, for example, a submarine landslide database done in Barcelona. And another example is for the Pillar 4. It's the first hazard map for the Mediterranean and Northeast Atlantic, which was also a collaborative joint project. Now it's also being distributed there. And the second distribution, hotspot, is our community website. The point is that this central IPOS portal is basically oriented for data distribution, like OGS standards of the data. But we would also like to provide software workflow as a service and just some web applications. They are not now in the format of the classical IPOS delivery framework. So that's why we also distribute data through our own data portal, which you can always access, tsunami.org. And we also have the 4 pillars. I will just give you a couple examples from each the pillar. Support to Tsunami service providers, basically they're expected to be 2 assets. One is Tsunami service provider interoperability tool, which is now under development. And you know there are 5 Tsunami service providers in Europe, and they would like to have something which they can share data, forecasting, whatever, between and during the events. So it's the tool for them. And another tool is being already ready. It's from Cantabria. It's regarding the just of analysis of the past, but also the current events, but with some time delay. For pillar 2, I will skip pillar 2, but pillar 3 are numerical models. So we have many of them, like you can see here the list. You know probably the high C, the BINCLOR, it's for landslide generation. For like antifask is for stochastic slip generation on the subduction zone interface and so on. I will just show you one example of the very new. It's because I was also involved in this one. It's TS Gauss, how we call it. It's just like for very fast, almost instant tsunami simulations. It's just like one example. We did it together with INGV. It's based on the pre-computed green functions, but not on the classical green functions of the unit slip on the patches, but on the Gaussian green functions, which are distributed everywhere through the surface. And we can just take any source and feed it to the green functions, and we have immediately our response. So that's one example. It's a web interface, so it could not be currently fit into the classical IPOS distribution. So that's why we distributed on our Tsunami website. And the final example is about the risk products. It's also the project called ETRIS, European Tsunami risk service provided by UCL, and they also they partly can fit into the classical tsunami distribution, in the IPOS distribution framework, but they also have their own perfect website where you can just have analysis on the empirical data, on the vulnerability, fragility, presented as like a map service, but also just in the curves. And also, it's important to know also the risk modeler toolkit, like a bundle of Jupyter notebooks where you can make analysis based on data or on your empirical data. You can build the risk chain and calculate risk. So my final slide is just going back to GTM model, which was introduced today earlier by Jörn Behrens, because we are basically close it's basically the same community of people, but just like sitting in different, under different umbrellas, and the same, of course, because IPOS is Europe-centric and GTM is global. But since GTM was mostly organized first in Europe, so there are a lot of intersections. So what we think is our liaison with GTM is basically exchange products, exchange of the expertise and services, and we do it again at among different pillars. So that was, and thank you for attention.
Thank you very much, Alexander. We have time for a couple of questions.
Is more like dissemination of data, modeling data, tsunami data from different projects. Is it correct? That's how I understood it. So that's you develop something on some specific project and you deliver it through the IPOS platform.
Yes, IPOS is only delivery. There is no funding for the development. They only support integration of, say, my assets into the distribution system. Yeah. So this the final part. Yes, but
I know very well what is IPOS, and it's not from project. IPOS is ERIC is European Research Infrastructure Consortium. So it's something adopted at the European level, made by countries members. And every country which is dealing with a network of seismology, they are members and they participate in the whole system, which is really good because they exchange data continuously in a daily routine. Information, software, a part of they permit to have access to the users. I think this is a very powerful organization at the level of Europe. It's amazing to have almost the whole European countries there.
I should say that also, like as a researcher, I would have also an interest because in IPOS I would need to provide the product which is out of the box. It's already should be ready. Yeah? It's not something which I code, which I have written but then forgotten, but it should be really like a product like. Yeah? So it motivates me to make it final, just until the final cut, and then put it onto the IPOS. Yeah.
Thank you.
Just to add some comments on IPOS, it's definitely not related to projects, since they are also providing data like tide gauge data from the sea level station monitoring facility of IOC, which is independent, totally independent of projects. And it's not only about the data. I think it's data products, software, and services that they are provided through IPOS. So it's much more than sharing data from projects.
Yeah, sure, but I mean, one of the main differences in Europe is project start and end, and nobody knows exactly how the outcomes are going. But ERIC is a permanent organization for a long lasting, minimum 20 years.
It's a place to put your project, the project products for sustainability.
Exactly. So, Alexander, thank you very much for your talk. And I think an applause to all the speakers because we finish now the session and I give the floor to Dennis.
Thank you very much. So please stay on the stage. So I would like to invite Mr. Bernardo Aliaga for a little gift to you, Professor. I told you there would be surprises. Thank you very much, and all the speakers for session 1. So we have officially closed session 1, and now we will move to session 2 on high-level objective 2. So I would like to invite Professor Hakunti Rahayu. So I don't think I will need to introduce because Mr. Bernardo Aliaga already introduced her this morning. So we'll save time. So I will hand over the floor to Professor Rahayu. And I think we have 5 presentations before we end today. Thank you very much.
Okay, thank you, Dennis, for the introduction of the session. So now is the last session for today. I hope you still have energy to see, because this is a very important of the high-level, objective 2 of the ODTP, that we are going to focus on the 3 aspects for this session. The first one in the hazard and risk management, and then second one is community response and exercise, and the last one is technology and inclusiveness. So for the first the first topic that I would like to ask my friend Marinos from NEAM Commitment to share what, you're already there, okay? Please have the same pattern like Professor Juan. I would like to stick with 12 minutes and then 3 minutes for the discussion. If you can have shortened, so we have more time to wash up before dinner, yeah, thank you. Please take your time.
Hi, good afternoon. Thank you very much for inviting me here. My name is Meros Haralambakis. I know that the second part is very difficult to pronounce. I am a research scientist at the Geodynamics of the Auditorium of Athens in Greece, and I am leading the Hellenic National Tsunami Warning Center, one of the 5 accredited tsunami service providers of UNESCO. Today I will in the following slides, I will talk about the NEAM Commitment Project, which aims to support improved tsunami risk management and planning in the NEAM region. This project has been funded by the European Union Civil Protection Mechanism under a call for prevention and preparedness. The full name of the project is NEAM Collaboration for Improved Tsunami Risk Mitigation and Management. It has a duration of 2 years. It started early this year in February, and it will end in January 2027 with a budget with about 1 million euros. The consortium of the projects consists of 13 partners from 4 countries, from European countries, namely Cyprus, Greece, Italy, and Spain, which includes 3 national civil protection agencies, 1 municipality, 1 international organization, and 4 national tsunami warning centers. The organization of structure of the project is quite simple. It has 2 main work packages, which are the main objects of the project. The first one we will deal with national tsunami inundation mapping, and the second one with local evacuation multi-hazard mapping. And there's also, of course, a work package for management and coordination, and the last work package, which it might be last, very important, about outreach, dissemination, and communication of the project. The aim of the project, as I said at the beginning, is to improve tsunami preparedness in the NEAM region at different scales for effective risk evacuation and emergency management. The objectives are spanning from national to local levels, addressing needs for national tsunami risk planning and for enhancing multi-hazard preparedness in coastal communities at risk. Tsunami inundation maps are crucial for coastal planning and risk management, not only at the national level, but they also support local tsunami hazard assessment and evacuation planning. The one component of the national component also contributes to important global tsunami initiatives like the Tsunami Ready Recognition Program and the Ocean Decade Tsunami Program, while we are also wishing to provide our products as a project to the EPOS thematic concept of tsunami that was previously presented by Andrei, and also support the activities of the Global Tsunami Model Association that was presented early in the morning, with supporting these activities with the guidelines and the tools that we aim to provide in this project. At the local level now, we are taking into account tsunamis from earthquakes and volcanic activity, which pose significant threat for coastal communities in the NEAM region. A multi-hazard approach is being applied, considering cascading effects which are needed for effective tsunami evacuation and emergency management, and emphasis is also given on science-informed participatory workshops and decision-making to improve local planning and implementation effectiveness. The geographical coverage of the project spans throughout the Mediterranean region, with Spain, Greece, and Cyprus developing national inundation maps, and Greece and Italy having producing evacuation maps, one in Greece, Western Peloponnesus, and one in Italy at Stromboli. The first main objective of the project is to have common national maps across NEAM countries. The project built up on a previously DGECO-funded project, the 2MAPS NEAM, which produced the tsunami hazard model for the Mediterranean region. Utilizing the results of this project and by applying applying GIS tools, we will translate the offshore hazard to inundation extent along the coast of Greece, Cyprus, and Spain. We will also develop guidelines and tools that we would like also to share with other countries and regions for local implementation, and we will also have dissemination of the results across national stakeholders, but also at the international level. The second objective is location-specific multi-hazard risk management. We are going to have in the 2 pilot sites in Greece and Italy, we are going to produce evacuation maps taking into consideration not only the tsunami, but also the earthquake and the volcanic activity effects. We will also here develop guidelines and have awareness activities in the local level. The project will accomplish its goals through a science-informed participatory decision-making approach, which brings together decision makers, risk communicators, stakeholders, and scientists. In this way, decision makers and local stakeholders take ownership of the products and maximize implementation effectiveness. And the project aims to contribute to improve tsunami risk management and planning in the RIAM countries. The reason I'm giving this presentation is because the project has been endorsed by the Ocean Decade Tsunami Program as a decade project. And by this, we aim to contribute to 3 outcomes of the Ocean Decade program regarding a predicted ocean, a safe ocean, and an accessible ocean. And we are also wishing to tackle 3 challenges about improving services, including prediction for the ocean, mainstreaming community preparedness and resilience, and capacity development and equitability access to data, information, knowledge, and technology. And by that, I would like to thank you very much.
Okay, let's give applause for Marino. Is there any question from the floor? We can have 2 questions from the floor. Okay, maybe while waiting, I would like to congratulate for and appreciate what have been done related with this very interesting multi-hazard preparedness program for the community. It's very hard, even though like you're talking about from the geological aspect, and then how could the people familiar with this kind of multi-hazard, for example, like what you said, volcano, and
volcanic
then
activities and earthquakes, yes.
Earthquake and tsunami as well. So could you elaborate how you can make engage with the people because with approach of multi-hazard? Thank you.
In both cases, both in Greece, in the southwestern Peloponnesus, as well as in Italy, the local communities are mostly aware of the other hazards from the earthquakes and volcanic activity than the tsunamis. So we are going there to also introduce the tsunami aspect to these communities, and our goal is, our main tool is this, the so-called science-informed participatory decision-making workshops that engage all the local people, the stakeholders, and the decision-makers to be part of the decision that they are going to be taken. We will present them what the science has to offer to them, but they will also have to put their own ideas or their own needs on the table in order to co-design an effective evacuation plan.
Okay, thank you very much. So you don't have any resistance from the stakeholders, especially academia coming to the community and then try to elaborate maybe if you can
the most demanding stakeholder are those that are coming from the touristic industry. These are the most demanding ones that and the more reluctant to allow us to present that we are there to mitigate a specific hazard. But we're getting experienced after some years, and we know how to handle these issues.
Thank you, Marino. Maybe one from the floor, if you have any question. Okay, maybe we can continue the discussion over dinner tonight. Thank you, Marinos, for your time.
Very much.
Yeah, let's give applause. Yeah. Okay, now the second presenter is still my friends. Here is like, because we are working together in the task team of disaster management and preparedness in the TOS working group. Now is Dennis Changseng. He would like to talk about the COSWAVE, scaling up community engagement and exercise. Please, Dennis, take your time. Then we're gonna follow with the discussion. 12 minutes is a lot of time, so don't rush. Yeah.
So I'm lucky because I will use some of the time from Marinos.
Okay, thank you.
Thank you very much. So my presentation is about COSWAVE project. So COSWAVE project started in 2021. So you will see here we are talking about scaling up of community engagement and exercise. So I try to focus a bit because the project is broader across all the 4 early warning elements. So again, I just want to remind everybody here, we all know about this, but what is important is, you know, we started with single regional coordination and cooperation since 1965, and then 2004 we went through a process, and we are talking about global coordination and cooperation. And this is why we went throughout this phase, and now we have 4 regional systems for tsunami early warning system, and here we are speaking about the Northeast Atlantic and Mediterranean region. And of course, all this progress that has been achieved is due to strong international cooperation and effective coordination. So I guess this is what I mean in terms of international cooperation, because we get support from DG ECHO. So this is very important for us in NIAM region because it was very difficult to get support from partners. So since 2021, we started with COSWAVE 1.0. It was a 3-year project, and then because it was successful and DG ECHO felt it was very useful and impactful, so we went to COSWAVE 2.0. And then, of course, COSWAVE 2.0 is focusing a lot on scaling up on where we started. So basically it's about strengthening resilience of coastal communities in NEAM's region to tsunamis and other sea level related coastal hazards. So this project is implemented within the ICG NEAM TWS framework. And then of course, similar to my colleague, Marinos, this project was also endorsed by UN Ocean Decade, and the reason why we are presenting here. And of course, it's contributing to the Ocean Decade. One thing about the Ocean Decade, we have indicators. And one of the indicators is partnership, how to create useful partnership. So basically the project, we feel, is contributing to partnerships. And here you can see all the partners, different countries we work with. And every country we work with, we always look at sustainability. We don't just go for any partner. We are thinking about how to sustain even beyond the project. So just to mention, we just came from Portugal, as mentioned by Mr. Bernardo Aliaga. We spent 10 days in Lule and Cascais. One of the important things is for the first time, we are establishing connection and partnerships with civil protection agencies. They were not there before. We were working with IPMA, Portugal, for many years, but there was no civil protection agency very visible and working closely with us. So this project is making things happen in terms of making the connections with civil protection agencies, not only in Portugal, but also in France, Italy, and Turkey. So I just want to capture a little bit what we do in terms of hazard and risk assessment and evacuation mapping. I won't have time to go in all the details and every achievement. As mentioned by previous speakers, this is not COSWAVE 2.0, but an example from first project. In Larnaca, Cyprus, we work with project partners. What was really interesting about this partnership and working with Larnaca, we started basically at zero. We just had tsunami national contacts and tsunami warning focal points. We I-10 ICG, but then there was nothing much. So basically, this project started the whole thing. And one important thing to me is the partnership which was created between NOAA, Greece, Spain, IH Cantabria, and also INGV in Italy. They work on this probabilistic tsunami hazard assessment. So again, it takes more time, but very productive. We know the benefits compared to worst case scenario. So there is a lot of consultation. Again, it's about participatory approach between experts and stakeholders, but also in terms of when validating these evacuation maps and so on, because it has to be part of the process, because eventually the Civil Protection Agency need to endorse these maps for it to work. But the key message here, partnerships. So here I try to give you an example. Here is the mayor of Chipiona in Spain. They became the first tsunami ready recognized in Spain. I was there, and you can see here the mayor who is very proud about his maps, which is right at the beach. I can say, who would think that Spain will have maps like this on the beach some years ago? So this is a big achievement in terms of Spain. Now we are working on second community. We are working on another community in Cadiz. Very challenging place, but we are progressing. One thing about COSWAVE project, since the very beginning, we were very cautious. We wanted to start on a very strong foundation. We just did not want to go and implement Tsunami Ready with the 12 indicators. We wanted to understand risk. We wanted to understand risk perceptions of different people. So we understand what they are thinking, their psychology, and how we can work with them, what are the gaps and what are the vulnerabilities. And this will also help us in terms of risk communication strategies and how we train, design training materials. And I think this is very important, and you will see it in the next slide. So this is just the publication for the first project. I won't go in all the details, but every project actually did risk perception studies. One thing is 2 countries were not part of the risk perception survey, but then when they learned that we were doing survey, they were happy to join, and it was even not funded actually from the project. So just want to highlight here, there's a strong concern about tsunami, but there's weak preparedness, so this is important. And just to highlight before I confuse anybody, this was done when the project just started. So now, hopefully, in the future, we go back and do the risk perception again to measure the difference. So there's strong concern, but very weak preparedness, and there's also perceived municipality capacity gap, and also there is generational bias in perceptions, and also in terms of alert communication mismatch. We think that the message we send through SMS civil protection is the best, but it's not. They want sirens, for example. We know the disadvantage of sirens also, but then this survey tells you a lot about what are their needs and how you can design early warning system. To me, one thing which is really important if you are going to implement Tsunami Ready, because it is voluntary, it is supposed to be a community-based tool. Of course, there is a top-down approach, because for you to implement Tsunami Ready, you need National Tsunami Ready Board, and this is quite political process. But then, when it comes to Tsunami Ready, to implement, you need to know if people will accept it. So this collective action mindset tells you a lot if they are ready to receive that. So if they are happy, they feel they want to be part of it, then you have an advantage. So if they were to say, no, maybe the risk is beyond management, then this means we have to do extra work to get there. So I think the risk perception survey is very important and the foundation of everything. And this is just a recent survey which was done by Egypt, Ras El, that will become the second Tsunami Ready in Egypt, and hopefully the second Tsunami Ready in Africa, because Alexandria also in Egypt became the first Tsunami Ready in Africa. There is a potential that Morocco could become also Tsunami Ready. Everything is done, but only setting up of the National Tsunami Ready Board. But just want to show you that in this place, there was a lot of respondent female. But this shows you the gender issue, which is important for UN and all international agencies, because we want to see that. And there is immediate concern for ocean waves. And according to the survey, tsunami was ranked 3 out of 5 in terms of but then there is a clear, when we look at the data and analysis, it seems there is a clear demand for multi-hazard early warning system. And this shows you that we want to implement tsunami early warning system as part of the multi-hazard approach. So again, this shows the connection. And of course, there are preparedness gap. They all want evacuation maps. There's a lot of need for that. And even at household level, there's a big gap. There's no such levels of preparedness. So this means we have a demand, and we can go in and do what we need to do. And of course, there's confidence crisis in terms of how they relate and trust to the authorities. So just to summarize here, we've been through this map since morning. In NIAM region, we have 6, but before the project, we had 0. Of course, France and Italy started their Tsunami Ready on their own national budget, but what is important is the project was very important to start the process, and the process is moving on. And one important thing I would like to highlight is in NIAM region, 2 big challenges at least. One is the high level of formality in terms of policy and how to make decisions in terms of implementing these things. Regulations and laws, very complicated compared to maybe small island. Another thing which is a bit complicated is the scale. For example, Alexandria, 500,000 people, 500,000 in the zone. So this becomes very challenging for us. It's not like 20,000 yes, so one Tsunami Ready could be very challenging for us to implement. And of course, we are trying to find ways to learn and do better. So this is just a map to show you, for example, this is very important map because we know that one of the biggest earthquake was 1755 from the Lisbon earthquake and tsunami. 40,000 people were killed. So you can see here what is being started. So like I mentioned, we have one tsunami ready already in Chipiona, Spain, and almost one completed in Morocco. But then we are now working with other communities in Portugal and Spain. So hopefully we will have a couple of tsunami ready by the end of year 2026. And of course we want to do more, but this is a very good start. And this is for the Central Mediterranean region. Mintuno was recognized, and then you can see here other places working on tsunami ready, Nice, Marseille, and Cannes. Cannes was the first recognized tsunami ready in France. Another surprise, because Cannes was recognized as the red carpet. Many people would think there would be resistance, but no, they actually managed to move forward. Tsunami is part of the all hazard and risk approach. And this is for towards the east, Egypt, and also Alexandria, Larnaca. Again, as I mentioned, Larnaca now, the only thing left is to do some finalization in terms of National Tsunami Ready Board. Samos, Greece, and my colleague Marinos, we work very closely with Marinos and his colleague Nikos in Samos to implement Tsunami Ready. I was there. And just to mention, Samos was hit by tsunami in 2020, right? Yeah. What was the height? 2 point something?
Samos down around 2 meters, Samos Island 3 meters, and then it's cost 4 meters.
Yeah. So again, because it's a recent impact, so very well received, so we need to continue and maintain this contact with the community. And also Malta, we are working, everything done, but again, the National Tsunami Ready Board is one of the barriers. And then, okay, now we just want to summarize what we are doing in terms of the project. So basically, we have 6 tsunami ready recognized, many in the process, several. So we like to talk about realistic projections. So don't want to create a wish list. We expect maybe by the end of June 2026, when COSWAVE 2.0 will end, we will have at least 25. I think we are on target, maybe a bit less, but we keep this target. 11 member states working on Tsunami Ready. One thing is, in NIAM region, we have 40 member states, and 11 member states is below the 50%, but this is where we are right now, and there's a lot of work to be done. And one thing about NIAM region, we are not yet in this process for renewal. We never spoke about renewal so far, because renewal will be an additional layer of support and administration. So we need to think about this, how to start working on this. And of course, I believe there are other projections from other countries. I don't want to put it there. Probably there is some document on this, but we want to compare, or at least to see what are the realistic projections from different regions. And these projections, to me, for the region we are working, we look at budget and resources and partners. So just want to end, of course, we have projects, different things, hazard assessment to maps and so on. But of course, one important dimension is how to relate all of this to exercise, because exercise is a very strong tool. So basically, in NIAM region, we have done exercise in 2012, 14, 17, 21, and 23. And now we are, well, one thing I would like to highlight, we did exercise, different drills, but we have never done exercise at the local level. So thanks to the project, this was done. And of course, now we are planning the next exercise in March 2026. Normally we plan our exercise between November to align with World Tsunami Awareness Day. But this time we decided to shift it to March because it will coincide with the ending of Coast Wave project. So member states who are part of a project will participate in the exercise, and then they will qualify or achieve this indicator number 9, I think, small letters here. So by getting involved in this exercise, they will qualify and achieve this indicator. So one thing I'm working on, and also we will bring it to TASTIM on disaster management, is best practices, key challenges, and key recommendations across all ICGs. So this is just a picture to show evacuation mapping exercise, and also the visit we did in Lule and Kashkash. This picture here is very powerful to me because you can see Civil Protection Agency very proud about their work in terms of establishing Tsunami Ready in Portugal. And then, of course, we had a ceremony for the 1755 earthquake and tsunami with the mayor, and this was really an important event. I will end there. Thank you very much.
Okay. Thank you, Dennis, for sharing. We have one question from the floor. Okay, yes. Yulong, Shasha? Okay, Yulong, please, yeah. Here. Can I have the microphone, please?
Thanks, Dennis, and congratulations on the major achievement you made, in a short space of time. I just want to draw your comment on what do you define as community, by the way, in your situation, and how. But it looks like it's a city, right? And what's the population that it currently has been already recognized? And how do you advise other countries to decide what community should be considered when they do the TRRP?
Okay. Thank you, Yulong. Yes, would you like to respond?
Yeah, very tough question, this one, because we discussed this in TASTIM on disaster management and preparedness with our chair. We had a process to define what is a community. So we are very aware of that question. So we are working with community, and of course we are looking at the political context, we are looking at the geography and the boundaries, and also how disaster management is exercised within that community. So this is a big question because we are facing one big challenge in our member states in terms of that question, actually. So, but what I would like to highlight, when we are deciding on Tsunami Ready, of course we think about the risk of tsunami as a key criteria, but in reality sometimes we have to decide based on interest. For example, in Shipiona, the mayor actually sent a letter to IOC UNESCO requesting support and to implement Tsunami Ready. So it depends. So again, community is a little bit difficult to define, but it could be from 5,000 people to 500,000 or even more. So one of the questions we have been asked actually from one of our experts in ICG, Niam TWS, and he's also working in the Caribbean, Mache Perosh. How many signage do we need to put up? Difficult question, so we are working on it. Thank you.
Okay, thank you, Dennis. Maybe before Pak Hardito, because this question actually represents a Temi question during coffee break. I'm really surprised in your presentation that you can have women engagement 75% or 90%. It's really surprised me. How could you do that? Women engagement, yeah, in the project. Thank you. Then
Well,
Ardito.
Yeah, thanks. This is from Egypt, and this community, actually El Raspa, this community is in Egypt, the one here, sorry.
Yeah.
Yeah, this one. So this is in Ras Elba. What is interesting about this place is that there is a lot of people working there from not locals. So many of them are women, actually.
Okay, so hopefully answering your question, Tammy, that women also participate a lot, yeah, in many sections. Okay, maybe last but not least, maybe Pardi would like to ask question, if you don't mind. Dennis, yeah.
No, actually not a question, but just to respond to the definition of community. I think we have been developing a kind of additional tools for the manual and guide number 74, which helps to define what is a community. And basically, every country can define their own community. So we are only providing some criteria in terms of how to implement Tsunami Ready. Like, for example, as Dennis mentioned, understanding about the risk, understanding about the number of populations, how it's easy to manage, difficult to manage, as well as the areas, as well as having all the components like the disaster management agency. So it will be an annex to the manual and guide 74 to help to define what is the community for organization or member state who would like to implement Tsunami Ready. Thank you.
Thank you, Pardito. Yeah, let's give applause to Dennis. Thank you very much. Yeah, I believe a lot of questions you can ask over coffee. Now we have, still this is all the group from Task Team of Disaster Management who has this, yeah, from the action endorsement. We have my friend Sylvia. She's will representing on the tsunami and climate risk reduction as protected area in Costa Rica. So it's very interesting to see how is the decade action has been endorsed. So you can come from the Marinos and then Dennis, now Sylvia. Please take your time, Sylvia. The same 12 minutes, but let's see how it goes. But don't make it less than 12.
Yes. All the presentations are very interesting and very important and large projects, and this might seem as a small project, national and very localized, but I can assure you it has been a lot of work. In this project, the background is that Costa Rica, about 25% of our territory are wild protected areas of different categories. And as opposite as the popular belief, we have had tsunamis, approximately 45 tsunamis since 1746, where a tsunami hit the Caribbean coast at a fort constructed by the Spanish army. So some of the tsunamis have had consequence and impact. Therefore, we started 10 years ago a project on building tsunami evacuation maps for coastal communities. And with the beginning of this project, Ostional, that is a coastal community that has a national park, was recognized as Tsunami Ready in 2017, which unfortunately hasn't been renewed yet. And then Cocos Island, that is another national park located 500 kilometers offshore the continent, Costa Rica. We performed capacity building 10 years ago, and also starting to exchange information with the rangers, with the park rangers, about tsunamis that they had witnessed. There is an amplification effect in one of the bays, and the populated bay in the island, and they had recorded several tsunamis: 2011, 2014, 2015, 2017, I think, and several others. So we started exchanging information and capacity building with the rangers, and we were able to deploy a tide gauge in 2018 with the support of the NOAA and the University of Hawaii Sea Level Center. And also we had performed a Caribbean wave exercise in another national park in Cahuita in 2019. And through our work with coastal communities, we realized that those that had national park or protected areas, that was a main stakeholder for the communities. And then we say, okay, it is very important to work together with this national park and these protected areas and rangers to increase the tsunami preparedness of the communities. And that aligned with another project I will tell you. So the summary of the project is we perform tsunami inundation and evacuation mapping for the communities and the protected areas. And another part of the team performed climatic and psychosocial vulnerability assessments because we realized we could join efforts together for climatic vulnerability and tsunamis and make better preparedness together. And perform capacity building for the staff and support preparedness and response plan. And finally, propose strategies for risk reduction and management, which include mitigation for both climatic extreme events and tsunamis as well. And this is a project entirely funded by the National University in Costa Rica and together with the CINAMOD program, that is the one that I direct, and the Environmental Sciences Department. So here are a couple of maps of this one. You can see in the left side, you can see the map of the protected areas in Costa Rica. Different categories are different colors. And in the right side, you can see the ones we are working. The project will finalize this year. So 2 in the Caribbean. We were going to work in a third one over here by the border with Panama, but we had to desist because there was a huge corruption scandal there. And then the directors were dismissed, and they bring new directors, and everything was kind of messy. So we decided we better not working with them yet. And then several in the Pacific, including the Cocos Island, that has very restricted visitation. So I think, yeah, we chose 8, well 9, but then we removed 1. So based on a tsunami risk index that we prepared, considering not only exposures, so also vulnerability and capacity. And I will be presenting in the symposium 1 poster regarding the case of Tortuguero. So I invite you to visit the poster. I am not going to discuss Tortuguero here because it will be in the poster. And I want to talk about a few of the cases. One of them, the first one we worked, was Manuel Antonio National Park. And it was a good timing because Bernardo contacted me and told me they were starting I mentioned this project in some conversation, and then he said they want to do a pilot project on a biosphere site for coastal threats, including tsunamis, of course. And it was a joint effort between the tsunami section and the Men and Biosphere section of UNESCO. And so we start working on this, that finished in 2022 and was recognized as Tsunami Ready in 2022. And also, this is a picture of the drill, picture after the drill we had in 2022. And another national park is Cahuita, that was quite interesting. Actually, the both places we work in the Caribbean are quite particular. Cahuita, the town, you cannot see it here, but it's somewhere about here, like to the west. This is the national park. This in the middle is entirely mangrove, so you cannot cross the point. You have to go all around the pathways. The treks are around the point, so it can take there are 8 kilometers to go from the one entrance to the other one. And the local tsunami might arrive in less than 5 minutes. And thus, this is what was observed in 1991 with the last tsunami there. Of course, you cannot walk 8 kilometers in 5 minutes. Regional tsunamis might arrive as early as 60 minutes. The community was recognized as Tsunami Ready in 2024. The community is outside of the national park. And one team of the University of Costa Rica proposed a design for vertical evacuation based on the conditions of the place, the soil, etc. But it will be needed several of these, 7 in total, to be able to reach them in less than 5 minutes along this is the pathway in blue. So this is one of the entrances, and this is the other one. You can see the town over here. But unfortunately, the funding has not been identified yet. And this is the cost, $29,000 for each one. And this is the cost in, this was proposed in 2023, so it's probably more now. And unfortunately, funding has not been identified, so we don't know if they're going to be able to build them. Another case is Cocos Island National Park. It's a small island, as I say, very far away from mainland. The boats take 1.5 days to get there. It's very restricted to tourism. There are only 2 companies that have the permission to go there to bring tourists. It's one of the prime sites for diving, particularly with sharks. Probably you saw in the news a few months ago, one Mexican researcher was bitten by one of the sharks. I don't remember which kind. I think it was tiger shark. I don't remember. But still, there could be in the island between 8 to 20 people any time of the year, between rangers, volunteers, paramedics, and temporary visitors, scientists, and so on. Tourists sleep in the boat. Tourists cannot sleep in the island, but still the boats are, you know, anchored there. So it's very important and very vulnerable because they are like Hawaii in the middle of the ocean, so they can receive tsunamis from anywhere. And the main bay, the beach, the island has only 2 beaches, and the main one where the access to the facilities of the park has this amplification effect that I mentioned before. So we have performed 2 drills with them, August 24 and August 25, and they have completed the Tsunami Ready guidelines to be recognized as Tsunami Ready. It will be the first national park to be recognized as is, because there is no community over there. It's just the rangers. The challenges we have found so far is that most of these national parks or protected areas are understaffed with very limited resources. We have, consequently, the planning and responsibilities that they should that they have, they are not being accomplished. They cannot do it. They are understaffed. At least 2 of them require vertical shelters, and we can say the authorities, national and local authorities, have not started searching the funding to build these shelters. They receive the reports and they say thank you very much, and they probably store it somewhere and just forgot about it. The coordination between these national parks and local governments is very important, but needs to be improved. National authorities, they don't really have a clear view of the needs of and the reality of these national parks. Corruption is very extended, unfortunately. There is a big scandal in that one I mentioned before, because they give permission to build hotels in one of the mangroves and protected areas, and so on and so forth. And unfortunately, we face now almost at the beginning of the project that the project results probably won't be replicated in other national parks. As the resources are very, very limited, they probably won't be able to put the energy and the time and the staff to do it. So, but with the project, we have developed some materials, some guidelines that they can use or that can be replicated in other countries, and we can also use them working at a community level with other communities that we continue to work with. This is a picture that maybe is not easy to see, but this is the tide gauge in Cocos Island, and this is my colleague that visited in August. He went to see what happened with the station, because the station stopped transmitting like a couple of hours before the arrival of the Kamchatka tsunami. So we were not able to see it, and probably it's not easy to see in the picture, but the station was entirely covered by spider webs. It was like a Halloween decoration. You can see entirely completely covered. And once he cleaned it, it started transmitting again. So this is one of the challenges we face in the tropic. Many, many life everywhere. So thank you very much.
Thank you, Sylvia. Any question from the floor? It's very interesting how she tried to work tsunami ready for the restricted area, and then is very less effort from the local. Any question? Okay, yes, please, yeah.
Interesting presentation. I was actually thinking about evacuation routes. I mean, if vertical shelters are not possible due to funding reasons, you could use a boat and go offshore, couldn't you? Wouldn't that be a evacuation possibility?
Yeah. The problem is there are no docks or piers there. It's just a pathway around. And there is a, whoops, it's not, the pointer is not very good. But there is a coral reef here. Maybe you can see it. We were not able to, thank you. We were not over here. We were not able to survey. We had to do the bathymetric survey there because there is almost no data on bathymetry, coastal bathymetry in Costa Rica. And we were not able to survey inside the reef, of course, so we had to approximate it. And then many people is skeptical and they say, no, the coral reef will protect us, and maybe, but maybe not. And so there are many boats that bring people over here, but they just go by the beach. And when you have a 5 minutes arrival time, it is really hard to put people on boats. But on the poster I will be presenting in the symposium, there is another case in the North Caribbean coast, and we will be discussing this evacuation with boats as well. Thank you.
Yeah, well, actually, it's not a question, just to mention that, I mean, this is a very good example of tsunami ready in biosphere reserve. So in the project we are working on, for example, in Portugal, one other thing which is interesting is the two communities I spoke about, Luli and Kashkash. We are part of the UNDRA Resilient Cities program. So again, it's not just multi-hazard early warning system, but also in terms of other resilient programs, how we can make these connections and synergize, you know, because this is where we make benefits and contribute to society. So this is just to add.
Yes, this is very important because I mentioned before, we started this project on tsunami evacuation maps for communities 10 years ago. And thanks to this project, many communities have organized and created emergency committees that have assisted them attending other threats, more common threats than like meteorological, hydrometeorological flooding by rain and other stuff. So even our disaster management office had told us that this tsunami preparedness have assisted in many other things. So this is part of, we try with this project to articulate efforts with people from other areas to help us all. So yes, thank you.
Okay, thank you. This is a good example for this high-level objective 2, which is leaving no one left behind, even though only few staff there, but we need to do something to protect them. Yeah. Thank you for sharing with us. Let's give applause to Sylvia. Okay, we still have one topic, I hope you don't mind, that we have also very important speaker, please, on the technology and inclusiveness. Fatima, would you like to share on the People Center? Yeah, early warning system in Indian Ocean region. Yeah, please take your time in 12 minutes. And then after that, there is also presentation from US. This is from Glorimar Gomez, is recorded. And then followed by myself, it's just very short one, about the technology inclusiveness. Thank you. And Pak Erdito will take over. Huh? Would you like to do it now? It's up to you. Okay. So I hand it to my partner, co-moderator.
Oh, thank you. Better now. On behalf of the team of the PC Twin project, this project that is almost halfway through its funding period, it's a 4-year project funded by the Indian Ministry of Earth Sciences and UKRI NERC. So it was a joint venture that was aiming to help the understanding of geohazards in India. Just to talk very quickly about the motivation for this work, we can see India is close to 2 important subduction zones. So if we look at it from a very high level sort of manner, we can see that tsunami arrival to Indian coastlines can take something between 15 minutes to an order of hours. So clearly, this is a time scale where tsunami early warning can really make a difference in saving lives. And that's why the proposal is focused on the scientific, participatory, and operational capacities of the Indian early warning system. So just to talk a little bit about the high-level priorities that were evidenced by the Ocean Decade program, I would just say, first of all, the project was somehow born into the Ocean Decade. So from the very beginning, when we contacted colleagues at INCOIS, the idea was to really build the project, its objectives, the whole structure of the project in a way that it was perfectly aligned with the Ocean Decade priorities and early warnings. It's not an accident that the project really is very much aligned. And I am going to show the work packages of the project that reflect this alignment, because it basically, the first work package is focused on improving the knowledge of tsunamis to use it as a basis for improving the capacities of an early warning system. So everything that we produce in the first work package is really intended to be fed into the operational capacities of the early warning system of India, which is work package 2. And work package 3 is focused on participatory activities, so that everything we do is also grounded in the local participation and ownership. So with this, I would just kind of very briefly present the project. I'm going to be very fast, because the project is quite covering a lot of different topics. So I'm just going to go very fast as a snapshot, and hopefully give a flavor of the different ranges of activities that are being reflected. So the first work package starts with work done to have a better understanding of physics of tsunami genesis, and that would help with better characterization of seismic sources, and also lead to scenarios, plausible scenarios for both earthquake and landslide. And this gonna feed into PTHA analysis at both the national, so at site-specific level, for Odisha and Kerala. And also, we're going to focus on modeling human exposure. I'm going to talk a little bit more about it. And all of this is going to feed into generating risk-informed alerts and evacuation maps, and also PTRA results. So this is currently underway. So the activity is to prepare a roadmap for PTHA. As you can see, PTHA really is consisted of different steps, very careful data acquisition, very important setup. So, and we have like a very big team involved in it. So right now we are really trying to set up the whole process so that it is also feeding into the Indian Ocean, ICG. So we really need to think very broadly, and also to define and distribute the responsibility. So that's where we are right now, to define this work map and kind of
distribute the responsibilities, who does what, so that everything is going to be sort of a sustainable product that can serve also for future and also for the region. So focusing on the physics of processes, there is work being done by colleagues at the University of Edinburgh and Earth Observatory of Singapore and INCOIS on using GNSS data for having a better understanding of the source in the Andaman and Sumatra subduction zone, and also to have some insights about what is happening after the 2004 tsunami and how the fault is relocking itself and what are its characteristics. Also, there is some work being done, which is at the service of source characterization to understand sources to produce significant tsunami event along the Indian coast. So focus is on extreme, like magnitude 9 earthquakes generated in the Andaman-Sumatra zone, and kind of to see how far do we need to model so that we can achieve like tsunami that is important to be considered. So, and that is also important for the economy of analysis. Another topic that my colleague Finn at NGI described in much more detail, so I'm not really go into the detail of this. I would just limit myself to say that from the very beginning of the project, we understood and considered landslide modeling one of the focuses, one of the innovations of the project. The purpose here is to improve landslide source modeling and also to couple it with tsunami modeling so that it would be like a sort of a first step towards having a PTHA for landslides. So here we are being very careful, but we would like to create a good basis for it. And also about exposure modeling, I'm going to talk about it more in detail in the symposium. So here I would limit saying that we are focused on modeling of human exposure for tsunami risk modeling, and it is going to be at two different scales. So we have a national level, and we have also a site-specific level. At the national level, we're going to use the information results using some machine learning algorithms. We meter of resolution, and at the level of let's say the communities, like site specific, we're going to focus on capturing the mobility of the population, what we call it the dynamic exposure, which is really quite important for tsunami, but that we're going to kind of couple with our site specific PTHA calculations, and so that is like somehow like a more ambitious, let's say, objective here. This is just an example of work on their way. So it is like the kind of, let's say, the exposure map, the static exposure map that is developed for Puri, and which is, I guess, along the eastern coast of India, and it shows very good results. So we are working on this, basically. Moving to the second work package, as I mentioned, it is very much focused on the next generation of early warning system, what can be in the future. And we are focused on rapid source characterization, on probabilistic tsunami forecasting, and also on communication of risk, which is a very central topic in this realm. And I'm just going to provide like a snapshot of activities, not all of them for the interest of time. So this is one of the first activities, one of the first deliverables of the project, which is putting into operational use the GNSS stations in Andaman Nicobar Islands. So this is very soon going to be operational. So colleagues at INCOIS and GFZ are working on the pre-processing, on processing and validation of the data. And also, this is a little glimpse into the future, inspired by the probabilistic tsunami forecasting work done by colleagues in the Niam region, thinking of developing a prototype version of probabilistic tsunami forecasting for the Indian coastlines. So here we can see like the different implementation level, but this is a work that is kind of needs to start, and there is a reason why it has not yet started, because it is deeply rooted in our hazard calculations. So the scenarios that are going to be generated from our PTHA analysis are going to be directly fed into this. So that kind of shows why knowledge is important for early warning. So that's like a very important link here. Last but not least is the work package that is focused on participatory activities that are aiming at gauging the behavior of communities, the response to threat of tsunami, and also they're focusing on inclusivity of the plans for tsunami preparedness. And finally, they bring the whole project together in a sort of a support to a tsunami ready kit, so that it provides tools and for communities to be able to kind of follow the procedure even without a strong institutional support. So I'm just going to quickly show the 2 workshops that we did in our first annual meeting in Kerala this spring. So the 2 workshops were focused on participatory evacuation mapping and also on crafting storylines. So I just very briefly want to just show the findings from them. So the first workshop was basically was aiming to characterize the vulnerable groups within a community to see which are the groups that may be left behind when there is a warning being generated, when there is an impending threat. And there were quite important insights that emerged from it, and I'm not going to go into that detail. And the second one was focusing on these different, let's say, vulnerable groups and how would they act in response to a tsunami event. And with that, I thank you for your attention.
Thank you very much, Fatime. It's very interesting because you are working for answering the whole ODTP program, like Objective 1 and 2. It's a massive, and good luck. Hopefully, it will be completed as you're targeted. It's really great. And then I attend one of your workshop. It's really great approach, like the persona. Approach, yes. Very good. So I give one question from the floor. Okay, anybody would like to ask? Okay, anybody? No, maybe I would like to ask question, because this is a very important that you try to capture in the people-centered early warning system for this Indian Ocean region, that using this Objective 1 and 2 and then covering massive, how you could manage about having a lot of experts joining from all over, from UK and then from Indian Ocean, especially from India, how you can manage this progress very well. Yeah, if you can share, because it's need a secret from you too. Yeah, thank you.
Yeah, that is very correct, Harkunti. It is very, very challenging because we are indeed different groups coming from different, geographically different, and also, so it is challenging. And as I said, we are kind of in the beginning, although we are getting halfway through it. I hope that we will be successful, because we really have to be successful, that we have no other choice. I guess that's one secret to it. And the other one is really the fact that there are a lot of participatory activities. For example, the workshops that you saw were good for kind of linking us with the communities, but they were also good for creating a bond between us who are working with each other to get a better understanding of what we mean by different terms. So I guess hopefully that will be something that will give us the energy to do all of these really ambitious, let's say, promises.
I know NERC is very tough, especially asking the progress. I've been receiving also NERC in these past 5 years. Yeah. Okay, thank you once again.
You.
Let's give applause to Fatime. Yeah, I hand it to Pardito now.
Thank you. Yeah, so, well, Ibu Harkunti will change her hat from moderators to presenters. So I back her up in terms of moderating for her session. So this is the last session, still about the technology and inclusiveness. And we have the first is the integration of the blind and visually impaired in tsunami warning services. This is a project activities.
Good afternoon, everyone. My name is Glorimar Gomez, contractor with the International
by US, and she already started to speak. So, unfortunately, they are not able to come, but very fortunate that they have been able to record. So let's hear from her presentations on this. So it will be given by Glorimar Gomez.
Good afternoon, everyone. My name is Glorimar Gomez, contractor with the International Tsunami Information Center Caribbean Office for the Caribbean Tsunami Ready project. Today, I'm honored to present on behalf of the U.S. and the International Tsunami Information Center Caribbean Office and its manager, Krista von Hillebrand Andrade, at the first conference of the Ocean Decade Tsunami Program in Hyderabad, India. Our presentation will focus on the contribution towards the integration of the blind and visually impaired in tsunami warning services. To set the stage, let's look at some important statistics. In the Caribbean, blindness is estimated at 1%, according to the Barbados Eye Study. Also, Orbis, an international nonprofit dedicated to fighting global blindness in Latin America and the Caribbean since 2002, in more than 16 countries, reported in 2020 that there were over 26 million visually impaired individuals in Latin America, with 3.2 million being totally blind. These numbers highlight the need for tsunami warning services to address this population. As United Nations Secretary General Antonio Guterres stated on March 23, 2022, early warnings and actions save lives. To that end, today I announce the United Nations will spearhead new action to ensure every person on Earth is protected by early warning systems within 5 years. This is the driving force behind our work. To achieve this goal, at-risk communities, such as the visually impaired, must also be served, starting with their integration in the planning process and development of new policies for tsunami preparedness. In 2023, a significant milestone was reached, the first ever printing of tsunami safety information in Braille, available in both Spanish and English. We distributed over 1,000 copies of these tsunami safety rules in Braille throughout the Caribbean and globally. Among these communities are Bahamas, Jamaica, Dominican Republic, Colombia, Barbados, Costa Rica, and St. Lucia. This effort was the result of the request of the government of St. Lucia as part of the implementation of the Tsunami Ready program. Among the initiatives and products adapted to Braille for visually impaired communities, I developed an interactive activity that was presented to the Puerto Rican Association for the Blind. During the activity, some 20 blind adults participated in a tactile game to identify the contents of an emergency backpack, which included items such as a foldable cane and supplies labeled with different textures for easy identification. Building on that success, 2024 saw the first ever printing of an earthquake and tsunami themed Braille coloring book named Tori and Teo. Also in Spanish and English, copies of the books were tested by students from the Visual Impairment Program of a school in Puerto Rico. Also, networking and socialization efforts are continuous through participation in local, state, and international events with organizations for the blind, such as the International Day of the White Cane. In 2024, we participated in the World Tsunami Awareness Day at the United Nations headquarters in New York, focusing on sensitization. This event was attended by countries' ambassadors, representatives, and survivors in the 2000 Indian Ocean tsunami. Tsunami Safety in Braille was introduced to the audience, highlighting our efforts to provide the visually impaired children and youth in the Caribbean with accessible literature, promoting tsunami knowledge and awareness. An updated tsunami safety rules flyer for the Caribbean was prepared and printed to cater to a global audience with an additional 400 new copies in Braille in both English and Spanish. Responding to the request of those with visual impairments who are not totally blind, we also developed an enlarged text version of the tsunami safety rules using contrast of black over white background. This material is designed to be easily readable for this specific audience, but in fact is appropriate for all audiences. I participated as an observer in the World Blind Summit in Sao Paulo, Brazil in September 2025. This event promoted insertion, public policies, accessibility, and assistive technologies for the visually impaired. I attended several conferences and established connections with blind organizations such as the Blind Latin American Union, the International Council for the Education of Visually Impaired Persons, and the Foundation for Latin America, among others. My main objectives in attending this summit was to collect feedback to validate the usefulness and applicability of the Braille and large text tsunami safety rules documents. It was essential to have this material tested by visually impaired individuals from different countries. In addition to people from the Caribbean, interviews were also conducted with visually impaired from Japan, Hong Kong, New Zealand, Fiji, and others. We gathered valuable feedback. The vast majority found the content of the Braille materials very useful. We received formative recommendations for the Spanish version. A key point was made that Braille dots can flatten over time, becoming useless if they get wet. A recommendation was to print Braille on plastic or stickers and place them over printed documents for durability. While written Braille is useful, there's a strong suggestion for availability in audible or digital formats. Importantly, blind individuals reported feeling more prepared after reading the Braille document, and it was noted that even though the safety rules weren't specifically written for the blind, they include realistic actions for them. This feedback reinforces the value of continuing to reproduce this material. For the enlarged text material, the feedback has been very positive regarding color contrast, which was deemed excellent. The earthquake protection image with gray contrast on white was preferred over the one with a dark background. It's considered important that all texts, including introductions and websites, are in enlarged text. We also learned that people with visual impairments find the zoom out feature helpful. Looking ahead, we hope to continue our work, including actions to continue increasing participation of visually impaired populations in the Caribbean Wave exercise. Also, with the support of the University of Puerto Rico in Mayagüez, a video version of the coloring book Tori and Tio, using descriptive language, special effects, and sign language will soon be posted in English and Spanish in the YouTube platform. As part of the project, I wrote a book for children and named it Diego and the Invisible Waves, featuring a blind boy living by the ocean, stating how ready and prepared he is to overcome a tsunami, and the actions taken to affirm his statement. This book's purpose is to create empathy and understanding toward the blind, and recognizing all their capabilities to manage risk using their other senses. In addition to the communicating and mainstreaming the efforts within the UNESCO IOC Tsunami Program and the other ICGs, we are proposing efforts to reach out to other United Nations bodies and international organizations that work with blind and visually impaired. There are people with other types of disabilities, and it would be good to extend to them efforts catered to their needs. To keep learning and understanding the means to approach the at-risk population with disabilities, empathy and care is essential to create a much safer and resilient world for all of them in case of tsunami.
Thank you for your attention. If you want to know more about our work with the blind and visually impaired in the Caribbean, do not hesitate in contacting me to glorymar.gomez@noaa.gov or to Krista von Hillebrand Andrade, Manager for the International Tsunami Information Center Caribbean Office at krista.vonh@noaa.gov. You can also visit our website at tsunami.gov.
Let's give applause. I think this is another important works, and I think this is also part which is responding to the early warning for all as well as leave no one behind. So this is very important. So I'm sure there is a lot of questions. I really encourage you to contact Glorimar or Krista as they have said. Another amazing work is being done by Harkunti, and this is related to, again, making sure that there is rewarding for all and leave no one behind, basically looking into the technology of inclusiveness. So Harkunti will shorten her presentations and present for this session.
In 5 minutes, yeah. Okay. Thank you, my friends. Distinguished guests, as also still have energy to listen. So actually, this is the approach is very complement with Krista and the previous speaker. Actually, we are talking about the technology as well as inclusiveness. So we are thinking about technology and inclusiveness. This is rely on the early warning for all. Actually, we are thinking about that. The early warning for all is just like not only responding on the ocean tsunami program high-level objective 2, but we can see the situation in the global. About 1.3 billion disability population in the world. So it's about 16% of the global population. As well as the Indonesia itself, 22.5 million disability people, and it's about 8.5% of the national population. This number is quite scary. It's not the number of population. If there is a disaster, earthquake, tsunami, what happened? This number will be increasing if we didn't do anything. The mitigation, the preparedness, awareness is very important. And then hopefully, this number will not increase due to the disaster. But a lot of cases in Indonesia that we found, people become disability because of the affected by the earthquake. For example, in Padang, then they become, handicapped. They need the wheelchair to move, and they become blind because of the accident or during the disaster. So this is very important to think about it. So having access to the early warning, they are very different. Just use this one again. They are very different. We are talking about the golden time. So far, we are thinking about the last mile for the non-disability. We are talking about the distance, 30 minutes that people have time from the subduction region. And then, but for the disability people, it's really different. The time can be double, triple, and everything. So this is why we need to make only also the technology, not only the SOP. Why I have this, my interest on the technology and SOP inclusiveness, because of this experience, 2016 IOWAVE. We conduct IOWAVE exercise in Padang. During that time, I have research funded by US. I've been working there for 5 years. And then suddenly, in the middle of 2016, we have IOWAVE. And then a group of the disability school or special school, they would like to join. I was really panicked actually. What should I do? We don't know what to do with these kids. And then, the kids like the special needs school, the range is from the kindergarten up to high school, year 12. So I don't have any guideline, but they are willing to do that. So this picture gives you a sign. So based on this picture, actually I have moved on, that we need to do something with this disability group. That's why we try to to do some research with some key question. How is their social cognitive? How different they are with the non-disability? and then how the physical and non-physical factor, if they live in the urban area or in the rural area, will affect them. Because in many cases, the school for the special needs school, they are huge population and located not only in the city, but sometimes in very remote area. They just become neglected. So this is very important to do some investigation. And then how is the multiple disaster-related actor would like to join and helping them, and then characteristic of the inclusiveness that they need. Just give you idea, we thought about the number especially for the special needs school. The total number is quite huge. Maybe I'll share in the next slide. That's why we need to make a new device. Using the very simple technology, we are collaborating with BMKG. We develop, improve the smartwatch, the chip smartwatch, and also smartphone. The smartphone, quote and unquote, function like for the school teachers or the principal, like warning receiver system. Very simple, connect with the information from BMKG, and the watch for the school is using the vibration-based watch as also the bling-bling. So the student with the hearing impairment or vision impairment, they feel something, or they have handicap, they feel something and take a look, but this need to be socialized. How they can use it and how they can integrate with the school system or SOP when they do this for the, what I call here, the drill. So this is just give you example. Based on the city evacuation route, it's impossible for them, but they have been given that they have to walk about 3.5 kilometers. You can see on the up ramp is on the based on the city evacuation route. And we have to make rearrangement again based not only the watch and the technology, but their ability to move. That's why make it shorter. Maximum is like, 2.6 kilometers, still impossible. And we propose to the local government, please make vertical evacuation shelter like my presentation before. This is very ironic. The same city, the location of the school only 500 meters from the coastline in Padang City is high prone for tsunami. And the shelter actually built in the complex area that I shared in the morning. But this is more needed. And we show during the drill with all the devices that we made, and the mayor think that they would like to also to help to make the school become the shelter. So this is the situation about talking the technology we developed. Actually, there are also conventional technology. The sign language by the teacher to do the, information to the student, and the red flag. We introduced the green, yellow, and red flag. What does it mean by the red flag? What does it mean the green and yellow? So we put this information into their SOP, and then this is like, just give you idea, the location of the school, the blue one here, is like 500 meters from the coastal area. So this is one of the schools you could imagine. 44 teacher only with 134 disability students. Many, right, hearing impairment, vision impairment, as well as they need the wheelchair. 3 types, and then the Down syndrome. Could you imagine the burden of the teacher? They have also the kids at home. That's why we try to make this participatory approach with the community as well as the people. So this is just keep this one, to work together to make the inclusive SOP in Padang City for the school and introducing the use of the simple technology. And this is, we try to do this, and then we make the documentation that can be used for the future school. And then here, like we are using in the audio, video, and using sign language and the text. I just get the feedback with my colleagues, Krista and Elisa Brown from the Caribbean, that like presented before, the Braille is really disadvantaged because it's were not through the time. And that's why we changed our mind, not using Braille, because now is era of digital. Digital, they are interesting, so we have this on the video, audio, so people or the student can learn how to evacuate. I will share the video, maybe not now. I give the link so you can take a look at the YouTube, and we have 2 minutes video, how we develop this SOP and also the devices that students can understand and other people also can learn. Okay, thank you very much. So this is my last, thank you, Aritan.
Thank you very much. Let's give an applause to
Professor Harkunti. I think it's another amazing works and very important works. So let's, is there one question before we end the session? Yes, timely.
Thank you. I think this is a brilliant presentation. I think even though it's the last presentation for the day, my reflection is, you know, we work so hard at every stage of tsunami warning systems, but if individual people cannot take the early action that the tsunami warning says, then we've all got it wrong. So I think this is such a brilliant presentation to make sure that we leave no one behind. My question is, I think it's very obvious that there are a lot of benefits to this work, not only for tsunami preparedness, but all hazards, all sorts of disasters. So I was just wondering if you've got next steps in terms of how you're working with these communities or sharing this knowledge or the SOPs with other hazards like tropical cyclones or flooding and things like that. The technology is so transferable. So that's my question. Thank you.
Thank you, Tammy. That actually the ongoing process is like we need to adopt AI, because last month I was invited with the AI Innovation Summit, because this project actually is sponsored by British Council and Indonesian government when we developed this technology. And then during that time, I'm the only person who is sharing about this from the perspective, and a lot of people from the AI approach would like to join to see about not only for, you know, the text, audio, visual. We need also to introduce AI for the young generation, especially for disability group. And I'm sure for other hazard it's very interesting, because like a lot of cases in Indonesia, not in the coastal area, like in the midland, they're exposed to earthquake, also the haze. You know, haze is quite scary also for this disability group, I mean special needs school, because they need the warning also, because otherwise they just trap into the haze and then they don't know what to do. So even though it's low onset, but they need also to be equipped. So I think there is a lot of homework that we need to do. They are the one actually to be, the very, very last mile that we need to take care of. Thank you.
Thank you very much. Again, another applause for Harkunti. And she will change her head again to moderator, so I hand it back to you.
Thank you, Pak Ardhito. So I'm multitasking from the manager into the sweeper. Okay, thank you very much. I return to Dennis because he's gonna make the closing of the day one, and then some logistic announcement. Thank you.
Okay, thank you very much for Professor Harkunti and also Ardhito for moderating this session 2. Of course, it's not complete yet, but for now, I would like to invite Professor Tanioka on the stage again to present Momento to Professor Harkunti, and also another surprise to Mr. Ardhito. Please come. This is collectiveness. So just before we end, just remind moderators to at least prepare for tomorrow in terms of the session to provide feedbacks, brief reports, so that we can discuss in session 6. And tomorrow morning we'll start at 9, and of course we'll continue with high-level objective 2. We will focus a little bit on tsunami ready, a little bit in different countries, different regions, and then we will continue with critical infrastructure, which is one of the important agenda of Ocean Decade Tsunami program, and it's one of the areas I like quite a bit also. So when we will continue again, I will not extend more than this. So maybe I would like to invite Sunanda to come and brief us on dinner. Right? Thank you.
Thank you, Dennis. So now today's session is over. We are having a lab visit, and my colleague Ajay will lead to the lab. You can take steps where is fit, and the others can take the lift. It can fit only 3 or 4 members, so we may have to go many times to the lab. It is in the 2nd floor. So we will be there until 7:30, and then 7:30 we'll come down, and then we will move to the same area where we had lunch. So the dinner is arranged there. I know you all are tired, but dinner will be good. Dinner, whoever is done, maybe as a group we can send to those hotels, please. Maybe 9:30. Yes. Is that fine? Maybe for you. It's your convenience. If you want to leave early, also let us know. So we'll start arranging vehicles from 8:30 onwards. So yeah, you can start moving. Thank you.